Hi, Dirk.
Hey, Melanie, welcome. We are finally here.
I'm very excited. And this is your first year hosting, right?
Yes, it's my very first year, and I have to admit, I'm really nervous.
It actually is very nerve-wracking. I thought I would be less nervous this year than last year, but it's pretty much the same.
It's like public speaking. You never get used to it. You just accept the nerves, but they never leave.
It's true. And more improv. So should we get started?
Yeah, let's get started.
Cool. So this is Posette, an event for Postgres for 2025. And we're really excited. We have a lot of amazing speakers today. There are 4 live streams. This is the 3rd live stream. And so there's one more live stream after this in the Europe and EMEA time zone. And the live streams 1 and 2, which also had amazing speakers, are those live streams are up. But and if you want to see the videos on YouTube, those will be individual videos will be up in a few days.
So actually, we're already halfway this event.
I know. Did you get a chance to watch any of or tune into any of the live stream yesterday?
Yes, both yesterday and today. Was not able to watch them all. My kids are out. They are staying with my mother-in-law. So I had to go out for dinner yesterday. So I had to miss a few. But I will watch them back.
Yeah, it's been cool seeing the chat be active in Discord too. And so I'm Melanie. I'm a Postgres committer and contributor working at Microsoft, and I'm excited to be here. I do some other community organizing, so it's great to be a part of community events.
Yeah, it is. So my name is Derek van Veen. I'm a database specialist at Azure. Basically, I'm allowed to play around with Postgres databases the entire day. And besides that, I love giving talks about Postgres, and I'm actually organizing PG Day Lowlands again this year. It's the 2nd time we are organizing it.
Well, how do you feel about organizing events? Do you like it? Do you feel like it is more work than you plan or less?
It's always more work than you plan, but
Yeah.
it's also very rewarding in a way I didn't expect. Someone made a joke about it, and it's like when you're doing the good work, it's like wetting your pants. Everybody knows how it works, but only if you do it, you actually experience this warm feeling.
That's an interesting saying. What I find is that the day before the event, I'm like, I'm never organizing another event. And then the day after, I was like, that was awesome. Let's do it again next year. So, yeah.
Actually, I have a question. Do you know what all the non-Microsoft hosts have in common?
No, what do they have in common?
They are all PG Day Lowlands organizers.
Really?
It's coincidence, but we only realized it yesterday, I think.
That's pretty crazy. I guess you all didn't have enough to do already.
Man, it's like you say yes to these things. It's like you're looking ahead in your schedule and say, oh yeah, I have time this evening and I can do this and I can do this. And then by the time it's there, it's like, okay, I overcommitted again. But
yeah, totally.
It's lovely.
Well, we're really excited. Those of us at Microsoft has invested so much in the community, and putting together this event is another awesome investment that they make in the community. So we're really grateful to them and to having the contributors team that I'm part of, and they really do a lot to try to give back. So thank you to Microsoft. And the cool thing about Posette is that it's totally virtual. So one of the things I hear as a conference organizer a lot is, I'd really love to come to your event, but either I have, a family conflict, I can't travel, whatever. And I think that it's really special to have such a professionally produced, awesome event that's fully virtual because it's completely inclusive. And that's something that I think is great about Posette for sure.
Yeah. When I started speaking and public speaking, I only was doing the real-time events. And then I met Claire, I think in Belgium. She said, like, what do you prefer, like online or offline speaking? And I was like, yeah, definitely. I like the real-time events and you can feel the energy and the audience. But then she said, like, but don't you realize, like, if you do this online, so much more people can actually see it, enjoy it, rewatch it. And not everybody has the luxury to travel to conferences. So some people are just never able to make it.
Right. Yeah.
Like, I never realized this. And then I signed up for the next Posette episodes.
Yeah, and I think another thing is, as a speaker, if you get a really high quality video recording. So a lot of conferences, it's questionable how the recordings go, or they don't even have recordings. So if you have a talk that's high quality content, when you participate in Posette, you actually have this like awesome professionally packaged recording of you doing the talk after that you can use. And I think that's one of the coolest things about being a
That's
speaker at
also
it.
really cool. You can really
Yeah.
use it as, how do you say this, commercial value to show
Yeah.
people what kind of speaker you are.
Right.
Although I
Exactly.
have to say, like, speaking to a webcam is completely different than speaking to a big audience.
Right. Totally. Totally. Yep. All right, so we abide by a code of conduct. So please, in the Discord, any other way that you're interacting with Posette content, be inclusive, be respectful and friendly and welcoming, and just really live up to the standards of the Postgres community. So if you have any issues or would like to report something, there is a link and a QR code there to do that.
Yeah, captions. I think Microsoft and Claire in general, or specifically, she's so proud of the high quality captions. I think this year they are available in 16 languages. And if you just struggle with anything, you probably can find caption in a language even it's your mother tongue, or you can read it. Yeah, it really makes these talks even more accessible to people. I think
I
people underestimate the effort it takes to make good captioning, but the effort is put in and it really pays off. It's really good.
I heard they added Dutch this year.
Yes, they added Dutch. I was making jokes like, well, none of the Dutch speak proper English, but
Cool. So if you are posting on social media on basically every platform, you can use the PosetteConf hashtag, and the Posette staff team might boost your posts, and we just love to see what people are thinking about, while the event's going on. So please do post and follow the PosetteConf account on all of these social media platforms. Tag us in your posts, and more people will see it. And a conference is not a conference without speakers. Obviously, they're the content, right? We're here just talking, but the speakers are where the value and the content really is. So it's a lot of work to put together a talk, as you know, Dirk. It's not something that the number of hours that goes in is a lot, and then what comes out is 25 minutes, and that's like a really hard length to produce good content that's brief and informative. And so really appreciate all of the speakers taking the time to do that.
yeah, and some people say like, but it's a 25-minute talk, right? That's less work than a 45-minute talk. But I would say it's the opposite. Because 25 minutes, it's pretty short. So you have to be really accurate in what is my message? What do I want to tell? So I think preparing a 25-minute talk is actually harder work than making a 45-minute talk. There's less time to wander around about your topic and find good quality content to put in. It's more like shifting more out.
Totally agree. So thank you so much to all our speakers. And there's a really nice guide that tells you different angles of like what you might be interested, which talks are good for you. So check out the Posette guide. There's a QR code there, and you can just go to aka.ms/Posette guide. And there's the groupings of the talks and what's relevant to who and that kind of thing are all in the Posette guide here. So you can see it's split up, it's tagged, it's super easy to find what you're interested in. So I really recommend checking it out. And Discord. So I mentioned the Discord earlier. This is a link to get on Discord. Some of the speakers will be there answering questions after their talk. And it's a great place to, ask questions, and other people in the community will answer. And, Discord's pretty hopping these days in the Postgres community. So if you're not on there, I recommend joining.
Yeah, and also this is, for me, the hallway track these days at conferences is maybe more important to me than the actual talks. And a online conference, you don't have the hallway track. You can't meet people. So I think having this option here, and hopefully all of the speakers join, actually also during their talk, so you can have questions. But also you can just talk to other people, because people are hanging around on Discord, asking questions, providing answers. So
Right.
I would say the best thing about hallway tracks is playing chess. That's hard on the digital chess, but if you want to, there is a lead chess, Postgres lead chess club you can join, and maybe you can even challenge some people today.
That sounds pretty cool. I didn't know about that.
Well, it's open source, and we have a lot of chess players around in the Postgres community.
Very
We actually
cool.
played a tournament last year in PGConf EU.
Oh, wow. I did
Yeah.
not know that. Very cool. Yep. So just go on there. Speakers should be there and answering your questions on the open source Discord server. And there's awesome swag. Most of my socks are socks from Microsoft for Postgres. So all my socks are Postgres socks at this point. They've slowly replaced all of my other socks. So if you go to aka.ms/Posette swag, you can get some for yourself. They're very nice socks, I can attest.
What I really like about the socks, I have so many nowadays, like you, like all of my socks are either Postgres or Microsoft, but the colors are kind of similar. So I have a green pair and a blue pair, and I always mix them. So I have the matching, non-matching colors.
I didn't think of mixing them.
So I hope this purple thing is slightly matching the other ones, and then I can mix them again, because now I have a purple pair and they don't mix. So
all right. And if you want socks, so the survey is really, really important. There's one for the event, and then there's a specific survey for Livestream 3. So for any of the talks you want to give feedback, go to the Livestream 3 talk survey, and you can select the talk and then provide feedback for the speaker. Speaker feedback is so important. I know as a speaker, you don't always basically ever get as much feedback as you would want, but any feedback I do get, I always take really seriously and try to incorporate. So please take the time to give speakers feedback.
I want to add something to this, because my ego really loves it when people say like, good talk, I loved it, I gave you 10 out of 10, but that's not how I learn. You can also hurt my ego, and you can give me 1 out of 10 or 1 out of 5, then my ego hurts a bit. But what really helps a speaker is like, if you can provide content like, what is the single thing you remember for a talk? Or what was the moment you drifted off? Or what was the moment you came back? That is really the kind of feedback that helps a speaker to make a better talk next time, next year, whatever. So please provide the feedback. And also, if you really want to help, take the extra mile, take the free field option, and provide something which really helps the speakers. It's really appreciated.
100%. Totally agree with that. I love when I didn't understand this part, or something like specific and actionable. Totally. All right, so we have 11 talks today, including Bruce's keynote, and I'm excited. We should get started. And so let's see a trailer.
Hi, I'm Bruce Momjian, Postgres core team member and EDB employee. Today I'll be talking about databases in the AI trenches. I've always been curious about how AI worked, and I had the opportunity to do a lot of research to understand the internals of exactly how AI is processed. And as part of that, I was able to understand how databases can be most effectively used for AI workloads. I think that might be the most important thing I'm going to be talking about today. We do have a lot of slides, but it should be an interesting presentation.
Hello, so I'm Chris Ellis, the head of technology at Next Team, and I'm going to be talking about fun with UUIDs. So this is a talk about the kind of pitfalls and advantages of using UUIDs as primary keys instead of just standard database sequences. So this kind of talk is really for any kind of application developers who might be working on multi-tenanted, say, SaaS applications, where the advantages of using UUIDs will probably be out benefiting the kind of problems that they cause.
Hi, I'm Karen Jex, Senior Solutions Architect at Crunchy Data, and today I'm presenting Managing Postgres at Scale, Challenges, Tools and Techniques. So I'm going to be talking to you about some of the things that you might encounter as you work with Postgres at scale, whether that's managing huge databases, whether it's managing many databases with large numbers of users or high transaction throughput. And we'll look at some of the things that you can do, some of the tools that you can employ to make that easier. So please stay tuned.
Hello everyone, my name is Alexander Kukushkin and I work as a principal software engineer at Microsoft. I'm a Postgres contributor, and today I'm gonna talk about synchronous replication in Postgres and some myths and truths about it. If you are application developer or DBA, this talk might bring very interesting insights about these topics.
My name is Varun Dhawan. I'm a principal product manager here at Azure Database for Postgres team at Microsoft. Me and my team, we work on building Azure Database for Postgres Flexible Server, which is our flagship managed server offering. If you are using Azure Database for Postgres Flexible Server or planning to use it, this will be a great talk, to stick around. So see you there.
Hey everyone, I'm Jimmy Zelinskie. Today I'm going to be talking about implementing strict serializability with pgexact. If you're interested in correctness and the internals of Postgres, this is the talk for you.
Hello everybody, I am Krishnakumar. I work as a group engineering manager at Microsoft, working on PostgreSQL open source as well as the managed service side of things. Today, I bring to you a talk called PostgreSQL and Linux kernel interactions. In this, you will learn a lot about the internals of how Postgres interacts with the Linux kernel and how to look at this, how to debug this, and a lot more. Welcome and come watch my talk.
Hello everyone, my name is Sarat Balijepalli. I'm a principal engineering manager at Postgres, Azure Postgres team. Today I'll be talking about Postgres partitioning challenges. My talk would be useful for database administrators and database developers. So let's get started.
Hi everyone, I'm Neeta Goel, CEO at Newt Global.
And hi everyone, I'm Sandeep Rajeev. I'm the sales director at Newt Global.
Today, we will be talking about migration considerations to go from Oracle to Postgres. If you are considering migration from Oracle to Postgres, this talk is for you.
Hey everyone, my name is Abe, and today I'm going to be talking about building intelligent applications with graph-based RAG on Postgres. If you're someone who's already built a RAG application or want to learn more about making your RAG apps more accurate, this is a great talk for you.
Hi everyone, my name is Taiob. I'm a Microsoft MVP on Data Platform. Today I'll be talking about Azure Database for PostgreSQL, 15 essentials for compliance and security. If you are using Azure Database for PostgreSQL, doesn't matter if you're a veteran or if you're new, you should be listening to this talk.
Great, super exciting.
It's so cool. There are so many good topics around. I think for everyone, I'm really excited. Actually, I just want to get started.
Yes.
All right. So, first topic. It's Bruce Momjian. I always feel bad about introducing him. I think by far the most known Postgres person around, and I can say all kind of nice things about him. But what I think a lot of people don't realize is how much effort and energy he actually puts in the community and the people of the community. And when I realized this, it's like when you're talking to him, you're the only person on earth that exists for him. And he's doing these things just to help the community. It's not for him. It's not for Postgres. It's not for the company he works for. It's just for the community and the product. I think that's the coolest thing about Bruce.
Totally.
He's such a good speaker, and I've never seen this talk of him before about AI. And he can explain topics so well. So I think we should just dive in.
Let's do it.
Let's do this.
Hi, I'm Bruce Momjian, Postgres core team member and EDB employee. Today I'll be talking about databases in the AI trenches. I've always been curious about how AI worked, and I had the opportunity to do a lot of research to understand the internals of exactly how AI is processed. And as part of that, I was able to understand how databases can be most effectively used for AI workloads. I think that might be the most important thing I'm going to be talking about today. We do have a lot of slides, but it should be an interesting presentation. Okay, let's get started. It's wonderful to be with you today. I really love this talk. I spent so much time working on it and trying to understand the intricacies of artificial intelligence. As you may know, I already have an artificial intelligence talk on my website, but this one is much newer, and it covers a lot of the new information about generative AI and RAG and so forth. If you're curious about these slides or any of the other presentations on my website, you can see my URL right there and a QR code underneath it. And that's where you basically see these slides and 62 other presentations if you're interested. We do have 86 slides here. So I am going to be skipping or going quickly through certain sections. As I mentioned before, I do have another AI talk called Postgres and the Artificial Intelligence Landscape. Again, URL there at the bottom. If you do download these slides, anything in blue can be clicked on, and therefore you would go right to that slide deck or to the website or whatever supplementary information I've shown here. But what are we going to talk about today? We're going to talk about the AI explosion, the huge amount of new information, new details, and interest in AI that is surprisingly new. Surprisingly, this whole AI sort of excitement is only in the past 18, 20 months. So we're going to talk about that. Then we're going to get into a lot of complexity. I am going to go kind of quickly through that. We're going to talk about hyperdimensional vectors, which is fundamental to AI. We're going to talk about how training happens, again, fundamental to particularly generative AI. We're going to then get more practical. We're talking about semantic and vector search. We'll talk about transformers, which is sort of the internal part of generative AI. And then we're going to talk about retrieval augmented generation. There's a lot of database use there. And then finally, deployment options. This is where I'm going to focus most of the time because there is a large component where databases can help. And I think this will be probably the most interesting to the audience. But again, you have to understand how AI works to understand where databases can help. If you just kind of launch in and try and use database without understanding how they work, you can't really make the best use of the database. Where does it fit? Where does it not fit? I have some details about that. I think those will be particularly helpful. So the AI explosion, November 30, 2022, big date. I know it doesn't really register as a big date for you right now, but historically we may look at that as a big date looking back. The big interesting part was the release of ChatGPT 4. And it's basically the ability to have human-like conversations and human-like output, particularly at that point, text-like output from AI. And this was just foundational and really set the AI world in storm. And we're still really living in the ramifications of that date and that release. If you're interested about generative AI, I do have a URL right here at the bottom. It's basically a 6-part, probably 5-hour YouTube series about generative AI. Feel free to look at that. But to really define where we are today, we have to talk about the two types of AI. And up until, I would say, the ChatGPT 4, the general understanding of AI in the public was one that was discriminative or predictive. So things like classification, fraudulent credit card, that's a classic, image recognition, recommendations for websites, predictive trends, and even language translation were pretty much the bread and butter of AI before ChatGPT 4 became popular. But generative AI came in and really changed the public's perception of what was possible. Particularly ChatGPT 4, which was for text, and DALL-E, which I'm not going to talk about too much today, which is for images and allowed for the creation of AI image content as well. Generative AI use cases, we're still trying to understand what all of those use cases are, but things like chatbots, semantic search, which I'll talk about, summarization, language translation, of course, image creation, that's one of the creation of text, creation of images. And there are some software aspects, particularly code creation, code analysis. I've used that a couple times. Even programming language conversion, I've been pretty impressed with what is possible there. So you might want to look at, again, some of the URLs there at the bottom to get more details. Comparing the two, discriminative, again, before ChatGPT 4, really focusing on domain-specific problems and supervised learning. And it usually outputs some kind of prediction or recommendation, whereas generative AI requires much more training, but is much more of a general solution, and it outputs new content, which has really shocked a lot of people. Again, the concept of generative here is significant. For discriminative, you're doing the training trying to basically create boundaries between various outputs or various probabilities of output. Whereas with generative AI, you're effectively creating these vectors in very high dimensional spaces, which I'll talk about in the next section. And those vectors are actually used to generate unique content. Really creative use of AI, I think. So hyperdimensional math, again, I said we were going to talk about some complex stuff. We are going to be talking about some higher dimensional math because that is fundamental to generative AI. Mathematics is very good at representing things that aren't possible in the real three-dimensional world. For example, thousands of dimensions, numbers of atoms that are far exceeding, numbers that far exceed the number of atoms in the universe, for example. Calculus, another example of doing representing infinite values or infinite processes. Again, really interesting. But there is a concept called duality, which effectively you can look at things in different representations, physical, computer, or even abstract. And that's where mathematics comes in. Now, most dimensionality vectors in generative AI use typically between 1,000 and 12,000 dimensions. Now, we live in a three-dimensional world, so it's kind of hard to understand what that looks like. But what I have here is an image of a 10-dimensional graph. And again, if this is 10 dimensions, imagine what 1,000 looks like. The range of values in that much of a dimensionality space is so vast that we really have trouble as humans, I think, conceptually understanding what that looks like. Basically, that's all I wanted to talk about in terms of dimensionality. Then I want to talk about the training aspect. Again, generative AI requires a huge amount of training. That you basically create. I'm just going to go through a very simple example where you take every word in the English alphabet. Let's suppose that's 50,000 words, and you basically create a vector randomly for every one of those words. So imagine 1,000-dimensional space or 12,000-dimensional space. You just randomly create these vectors. Now, 50,000 vectors in 1,000-dimensional space, they have there's nothing near these vectors. They're just kind of floating there with no vectors near them at all because 1,000-dimensional space is just huge. So what happens after that is that you take a huge amount of documents and you basically adjust these vectors in these 1,000-dimensional spaces to make them closer or farther away from other words. Now, that might sound kind of like a non-useful thing to do, but what happens is you can make small adjustments to represent relationships between words, and that's typically how generative AI actually generates its output. Again, a lot of URLs here at the bottom, a lot of detail. But let's look at a simple example. I took the words king and queen, man and woman. This is the traditional 4-word example that most generative AI uses, and I randomly placed them in this 2-dimensional graph. Again, not 1,000 dimensions. But what I do is I take some statements like the king is a tall man, and I basically move each word closer to the other words in the sentence. So king moves closer to tall, king moves closer to man, and so forth. So you basically take the thing you break them up into words and you move them mathematically, because king is normally appearing with the word man or tall or whatever. Queen is normally appearing with woman. Beautiful is normally appearing with woman or queen. And castle and throne are typically together. And you can see how words start to move a little bit. And again, they're in such a huge space, it's actually not a huge problem. But again, the words are moving closer a little bit at a time. A lot of mathematics involved here. This is particularly why it's a very compute-intensive process to do training for generative AI. But at the end, What we have is a new relocation for these vectors. Man and woman are very close together. As you can see, king and queen are very close together, but also the distance between man and woman is the same as the difference between king and queen, because in that training process, we've kind of moved things toward each other as part of the training and the math. So what you end at the end is something called a text embedding. This is not a picture of that. This is just a basic implementation of what a vector would look like, where it has so many different components. And again, you're making small movements for each word, depending on how one word appears near another word in the text. So having done that, I'd like to talk about semantic and vector search. We're all familiar with text search, full text search, which effectively has a word and tries to find another word in the same text. But semantic and vector search really is a new way of doing searching. And it uses the training data that we just talked about to allow you to basically search for a word that is near perhaps another word in that 1,000 or 12,000 dimensional space. I know that's kind of hard to grasp, but I'm going to show you some examples, and I think it should be useful. So what we do is, to do semantic search, we first download a pre-trained text embedding. So somebody's gone through the training process for us. We don't need to do that. We're going to create our own text, and we're going to basically download one, or we might create our own. And then we're going to chunk the text into sentences or paragraphs or documents. And then we're going to basically find the text embedding of every word that is in our search. We're going to average those vectors, and then we're going to store them in a database. So in that step 3, we're basically going to take the document, not search it yet. We're going to take each word, each sentence, break it up into words, look up the words, average the words into a vector, and store that vector in a database along with the chunk. And then to do a search, we're effectively going to take the search. We're going to take the words in the search. We're going to average the words in the search. We're going to create a vector, which is the average of the words in the search. And then we're going to search for the closest neighbor. If you're familiar with nearest neighbor search in Postgres, this is exactly how it works. So I'm going to give you an example. I have a set of text here. The king is a tall man. That's my first sentence. Queen's a beautiful woman. They sit together in the throne room of the castle. I take my first sentence, average 6 vectors. I create an average of that. I store it in a database, second. Same thing for the third. And now I'm going to issue the search. So I've stored 3 vectors, and I said, who is the king? That's all I said. And the result I get back is the king is a tall man. And the reason I get that back is because when I take who is a king, I get the pre-trained or vectors for the 4 words. I average them together, and I say which sentence is closest to that result. It turns out the king is a tall man is the closest. How does this actually work? I don't have time to really go into detail, but I'll show you just a little real world example. I install PG Vector. I create a document table. I create an embedding table. I load my sentences into these tables. I then run a Python tool, which will look up the OpenAI embeddings for my text. And I basically store those embeddings in the database. And as you can see here, the king is a tall man has an embedding in red. The queen is a beautiful woman, the same thing. And they're all basically stored in the database. Now, to do a search, I basically take the text somebody gives me. I again look up the OpenAI embeddings for those words. I average them. And then you may recognize the nearest neighbor operator here, the less than dash greater than. And I effectively do a search. What's the closest one? And I get the answer. So, for example, who is the king? The closest example is the king is a tall man. Who is tall? Again, the sentence is the king is a tall man. That's pretty straightforward, even for a full text search. But if I ask who is short, I get the king's a tall man, which might surprise you, but short and tall are related. So it thinks that those are the best matches. who is pretty. The queen is a beautiful woman. It knows that because it's using the OpenAI trained embeddings, it knows that pretty and beautiful are related to each other. Who is in the palace? Again, it knows palace is typically in a castle, so it gives me that sentence. And find where is the chair? It knows that that sit is related to chair, and probably also that throne is related to chair, so it gives me that answer. That's all I wanted to talk about in terms of semantic search. I'm going to talk real briefly about how generative AI works. Again, I recommend you go to my website if you want to watch a video of me giving this talk in a larger format. So there's something called transformers. Transformers effectively create these blocks, which can use a pre-trained algorithm to create new text. Of course, GPUs are very useful for this. So they create something called attention blocks, which I'm not going to cover, but effectively what happens is the way the generative AI works, we have a text like, what is the capital of France? And effectively we look up the vectors for that. And then we run through a process. I'm sorry, I'm going to have to go so quickly. We run through a process where we adjust the vectors for each of the words based on other words in the question. So for example, capital in France, those get moved closer together. And as we run through these attention blocks, you can see there's a lot of computation going on. We're slowly moving the vectors closer to each other. And then finally, at the end, we get the last vector represents the first result word that we should return to the user. Then we run the process again. We get the second word and so forth, and effectively becomes a machine that generates text. It sounds crazy, but it actually works. So generative AI, let me give you an example of this. For example, what is the capital of France? It knows that the capital of France is Paris because capital and France are close. It moves France close to capital. And once you do that, the resulting vector is actually very close to the Paris vector. Very similar to how king and queen moved around. Capital of France is, it knows what that is. I'm showing you here some adjustments. There is another Paris in Texas. So if you say Columbus is in Ohio, where is Paris? It doesn't, it does mention Texas there. If I say I live in Texas, where's Paris? It actually talks about Paris, Texas, because the word Texas moved the Paris word closer to Texas and farther away from France. It's kind of interesting. Let's talk about how databases can be used here. There's a very common popular retrieval augmented generation capability for AI, which uses databases. So I can actually say, where is Paris? And what happens is that we can create a JSON document, which effectively looks exactly like this. And you pass this to the AI system, perhaps with some other information. That's what RAG typically does. It adds information. And we get some results. So if in RAG, what you do is you have some pre-training information that precedes the query the user types. And typically this information can come from a database. That's why RAG is used. Retrieval augmented generation means we're augmenting our retrieval with some database information. So here I'm retrieving it in red here. Here's a better example. I actually can augment my information with some JSON data that I retrieved from an order entry application. And now I can ask questions like, when were the orders made? And the output is actually using that JSON information to give me information related to those invoices. What's the earliest invoice? It knows that. It can read the JSON. What's the total of all invoices? It can do calculations for me. Kind of crazy. What is the average invoice amount? Again, it's using that data I retrieved from the database, and it's actually giving me an average of those invoices. I can even ask for payment information. I say today is April 15th. What's with 30-day payment inspection with which invoices are overdue? It actually walks through this. Incredible how that works. You can even ask, what is the total invoices that are not pencils? And it can do that for me. Again, it's reading the JSON document that I prefixed to the query. And you can imagine how an application programmer would use this as well. today, what is the next expected order date? And it actually looks at the days between orders trying to predict. Okay. You can even ask it to generate an SQL query for you. Here's an example where I actually do the RAG call, but I specifically pull the JSON document from Postgres and then append it to the query. Okay. So this is the talk I wanted to kind of finish with, and I think is most valuable for you. And that is, how do databases make sense for an AI workload? First off, obviously you can do generative AI in a whole bunch of different ways, cloud, self-managed, and so forth. But this slide, I think, is really helpful. On the right and left-hand side, it talks to the various AI features. The middle, it talks about details. But at the right, it explains if this is good for AI or good for databases or not. So semantic and vector search, I already showed how that can be done very easily with AI. Text embedding, vector training, probably not good with a database. There's just too much computation. Database strength really doesn't benefit there. Doing transformers, probably not a good place for a database. Retrieval augmented generation, I've already showed you how that can be used really well. Language queries on retrieved data, I think there's a huge potential here of allowing non-SQL language people to query a database and get a reasonable answer. Data analysis and regressions, I think it's very good. And again, even generating SQL queries, I think, on the fly is something that's going to be interesting. I have a URL here at the bottom about that. There are a lot of Postgres AI solutions. I've already talked about PG Vector. Tembo has one. EDB has one. Timescale has one. PostgreSML has one. All the cloud vendors seem to have them. There's something called Lantern Cloud. There's WorkKit, PopSQL, a bunch of different ones. And again, dbTune for server tuning. So this is in its infancy. I expect a lot more AI solutions to come along. Now, in conclusion, I just want to give you sort of a sense of where the landscape is for AI. Again, AI has been around for, well, back in, I don't know, hundreds of years, where they were thinking about what AI, what a computer, what a machine would look like, how do machines change man's relationship to the world. That's the pre-computer understanding of AI. We had the Turing test in the 50s, expert systems in the 80s. AI winter was really a sort of a down area for AI. There wasn't a whole lot of thing going on. 2010s were robotics, but really, surprisingly, 2013, this is really where it took off, at least academically, with something called Word2Vec by Google. And then the concept of attention blocks in 2017 really laid at least the academic groundwork for what happened in 2022 with ChatGPT and DALL-E. And again, we all know what has happened since then. How did Google miss the boat? They basically were so focused on their core business, they didn't understand that generating new content and bringing content from multiple websites together to sort of amalgamate and aggregate and summarize information was actually going to be useful to users. Again, they have Gemini, they're trying to catch up. But again, this is one of the reasons I think they weren't the first in this industry, even though they had done a lot of research before them. And I'm going to just close with these two quotes. And again, you have to think about what they mean. But what this gentleman is basically saying, that if you told me it is in 2013, if you told me a year ago we'd be able to do all these things with AI, I would have told you it wouldn't happen probably in my lifetime. And now, within 1 year later, it has happened. And he's basically shocked. And I totally understand that. But the second quote is also important. And this is a cautionary tale about what we expect from AI, basically saying that we used to think the idea that people could express themselves or manipulate language was smart, but that's not true. And I think I've shown you this already. You can manipulate language and not be smart. And that's basically what these large language models are demonstrating, because that's exactly what I've shown you when I showed you the transformers, how basically it's using vectors to generate data. It doesn't understand what it's saying. It merely is able to generate it. So I hope this has been helpful. Again, my main focus was to explain what generative AI is, what it does, and then try and merge that with the database needs to try and explain, okay, here's what it is, here's where databases can help, and here's where databases maybe don't make sense. And hopefully that will help you to have a better understanding of where you can take AI with your current database needs and requirements. I think this opens a whole new chapter for what databases are going to be possible for, and it's going to be a very exciting time going forward. Thank you for listening to me today.
Very cool. I heard lots of good things about that talk from people that had heard it at other events, and I was not disappointed.
This is a really good start stream. He can explain so well. I think he started his career 10 years ago as a school teacher, maybe a little more than 10 years, but still, how he can explain such a complicated topic with an easy example, and it's like, oh, now I understand how this works. It's so cool.
He's definitely our educator-in-chief.
Yeah, definitely.
So just a reminder to fill out your surveys. If you go to Posette Survey Talks LS3, the link down there, you select the talk you want to give feedback for, and then it's super easy, and you can get stocks if you do it. There's also event feedback.
Yes, just to make the goal for the open goal. How do you say this in English? I don't know. Make it obvious, saying the obvious. Bruce was giving the keynote for those who don't know who he is. And he is an amazing speaker, but still loves to get the feedback because he also wants to improve his talks. They are already good, but he likes to make them better. So please give your feedback.
Please do. And also, he was answering questions on the Discord. So ask your questions. I'm sure he'll stick around for a little bit, and you can ask more questions. And the next speaker will also, you can ask your questions and discuss the topic there.
Yes, Chris is already in Discord.
Oh, okay.
And Chris is having the next talk.
Yeah, I'm impressed you're able to keep an eye on Discord and look at the camera at the same time. Cool. So definitely you can get your swag, and there's codes also for other kinds of swag than socks, like stickers and stuff like that. So you can look out for those, I think, in the Discord.
Yes, there he is, Chris Ellis. He is head of technology. And I when I think of Chris, I think of elephants, because Chris can make these really cool elephants, and you can have the lads on.
I have mine too.
He makes them. Yeah, I have that one. And this was actually the speaker gift from Peace Day Lowlands. So it's a Postgres elephant, but then the ear is a tulip, which is a typical Dutch flower. But besides making these really cool elephants, he has a cool talk about UUIDs. I actually already seen a longer talk about the topic from him earlier this year. And I think he's really good at playing around with things. So
yeah, I'm excited to, as a contributor, I always like to hear what Chris has to say.
Yeah, let's go.
Hello, so I'm Chris Ellis, the head of technology at Next Team, and I'm going to be talking about fun with UUIDs. So this is a talk about the kind of pitfalls and advantages of using UUIDs as primary keys instead of just standard database sequences. So this kind of talk is really for any kind of application developers who might be working on multi-tenanted, say, SaaS applications, where the advantages of using UUIDs will probably be out benefiting the problems that they cause. Okay, so now let's have some fun with UUIDs. So first off, a little bit about me. So I tend to go around calling myself a bit of an IT jack of all trades. I'm kind of as comfortable dealing with and building hardware as I am kind of designing and building front ends and everything in the middle. I spend most of my time working as kind of application kind of developer and architect around kind of back-end systems and databases. And over the 20 years I've been working with Postgres, I've kind of worked on a whole range of different projects, from search engines to subscription systems and smart energy analytics and IoT platforms. And to kind of really start with, let's first off talk about what is a UUID and what do we mean by one. So first off, the acronym stands for Universally Unique Identifier. And most people are kind of used to seeing them like this, where we see them as a 36 character string of hexadecimal characters with a few hyphens sprinkled in. Now, obviously, this is actually just a 128-bit number or 16 bytes of data encoded as hex in this particular form. So actually under the hood, it is just 16 bytes of data and a 128-bit number. And to Postgres, that's exactly what it is. Now, in general, most people are kind of used to using and seeing what are called version 4 UUIDs. So inside the UUID itself, there are two nibbles which provide certain bits of information. So there's the version nibble and then the variant nibble. So the version here kind of captures the particular version scheme of this UUID structure. And as I said, the one that people are most used to coming across is a version 4 UUID. And this is what Postgres supports out of the box. Now, a version 4 UUID is basically just a complete random number. The rest of the kind of information there, the 120 bits of non-kind of version information, is just a randomly allocated number. There are very little control or concepts about how that should be allocated. Obviously, most systems will want to try and use some form of cryptographic random number generator to do this, but it is just 120 bits of random number. So using this in Postgres is really no more complicated than if we were to use any other data type. It is just a data type as far as Postgres is concerned, and we can use it just like we can a big int. So we can declare it as the primary key of our table in just the same way as we would normally. UUIDs in Postgres are still fully compatible with B-tree indexes, and you can use it just as you would your standard kind of serial. And you can't necessarily auto-generate these in as such like you can with using the big serial data type, but fundamentally they are just a data type as far as Postgres is concerned. And we can use them for foreign keys, we can join on them, we can query on them, we can use them in all sorts of different ways, just as we would any kind of other data type in Postgres. So let's go and talk about kind of what are the often cited problems with using UUIDs. And we're going to start with the really obvious one. Just the size. They are twice the size of a 64-bit number. And that obviously is going to have some form of impact on you. It's using twice the storage space inside Postgres to store that information. And in places, that's not really necessarily always a massive problem, right? But in certain situations, it might be. But at the end of the day, right, the kind of data in your table is going to be predominantly taken up by the contents of your row, as opposed to the identifier of your row. So the size of it is also kind of like, frankly, a minor disadvantage, but later on actually can maybe be a significant advantage to your system and application. And what's more important is most of the kind of problems we see with UUIDs come from the fact that they are by default and at the moment randomly allocated. And most of the problems comes from this random nature of them, as opposed to, say, anything inherent about it as data type. And this is where it's really important to understand that on the surface of this data type, it's maybe not as simple as just other things. And, you know, there are multiple ways to construct and use that space, which is the kind of importance here. Now, from a perspective of indexes, the kind of random nature of it is going to create a bit more churn than it would if it was sequentially kind of stored in your kind of system. It's going to take a bit more kind of work because every time we're going to insert something, it's not necessarily going to go into the same page. Whereas the nice thing about kind of a sequential number that's always increasing, then it's going to roughly end up in the latest page inside your index. And this kind of like natural correlation that we tend to have with sequentially allocated index keys and indexes is actually quite advantageous, and Postgres has certain optimizations, specifically the free space map, where that correlation is actually quite important. And there's a very good blog post about this, and we can take a very simple query to kind of look at the impact of that, and then we can use that as a bit of a benchmark to see if we can actually get better or more useful performance out of UUIDs by constructing them better and then still having the advantages we want from them. So we're going to start off with a very simple test case throughout this kind of talk. We have a table which has an ID, primary key. We have basically a big int version, and then later on we have a UUID version. And then we have a value, which is just a text string. And for the purposes of having in this talk, it is a 500-byte kind of string, which is the same on every record. And that's there just to represent that in most normal real-world situations, you're going to have some data in your kind of row as well as just your ID. So we're going to try and keep these benchmarks and tests semi-realistic. So obviously the UUID variant here, the only change in the particular table structure is the data type of the ID column. Now, if we go and take a index-only scan of the ID, we can start seeing the impact of this free space map problem. So first off, actually, let's just have a quick look at the size of the kind of tables, and you'll see that actually the bulk of the kind of table space is used just by the row data. We don't have a significant impact, maybe at most 5-10% kind of extra space used, but that's going to vary deeply depending on the size of your data. And the indexes are probably almost double the size, but we kind of expect that given the identifier is double the size. And then, so let's then kind of look at the kind of free space map implications of this. So if we just do an index-only scan across that integer sequentially allocated table, we'll see that we don't really kind of hit more buffers than we kind of really expect to kind of see in that index. And that's because kind of we can cheat and use the free space map to check the visibility of those records that the indexes point to. So a key problem here in Postgres is that indexes don't have tuple version visibility. However, what's fascinating is if we do this exact same query but against our randomly generated UUIDs, we see a significant problem where we have an order of magnitude more number of buffers that have to get checked. And this is, again, because stuff's not neatly correlating between our free space map and our index. And it means that as processing that index scan, we've got to go and check a lot more active buffers. And that's got a cost of pulling them in and out of memory, even if they're in shared memory. Now, what's fascinating is if we do the same thing, but on a 64-bit integer column that's been randomly allocated, we get exactly the same problem. So this is a very simple way to demonstrate that some of these optimizations are not necessarily about the data type itself, but about how we're using that data type. So the fact that this kind of data type has been randomly generated here, and the fact that it's still a 64-bit number, it's the random nature and distribution of it that's causing the bulk of these kind of problems in some of our performance optimizations that Postgres has. So with this in mind, why do we want to use UUIDs, right? Why do we want to go to this effort? And this is kind of where this sort of talk came from, was a discussion I had with somebody explaining like actually the reason I like them and why I kind of use them. And there's a number of advantages about this, which is there's some security advantages here. In web apps, exposing sequential IDs is not great. Like nobody wants to be able to just increment a number on a URL and be able to download somebody's photos. And this is not really necessarily a full security argument, but it's definitely some form of like security through obscurity. But being able to just use UUIDs here makes our kind of URLs way more difficult to guess and just kind of cuts out a range of problems easily just by using a different data type. And at the end of the day, 128-bit numbers are very big. There's an awful lot of combinations. It's very hard for people to try and guess them, brute force them, and we get a kind of number of advantages from that. Another thing that I think is actually maybe not thought about quite so much is that a big downside of database sequences is, by definition, they can only be generated by the database. So whenever I want to allocate an ID to something, I have to go and call the database to insert that data, and then often, and this is a nice advantage of Postgres, say returning ID. Now, the great thing with UUIDs is I can generate them in the application layer, and I can generate them across all nodes in my application layer because by definition, they are universally unique. Now, that's kind of maybe doesn't seem like a massive advantage in places. It can reduce some bottlenecks here and there, but actually there's some kind of latency gains you can get by this. If you're in a situation where you're inserting a parent record and multiple child records, or you have a kind of complex nested data structure that you're storing, you need to issue multiple insert calls. Then if you've got to go and insert a record and then wait to get the ID that's been given back to be able to insert the second record, you now actually have a kind of latency problem here, whereas actually the great thing we can do is if the application can generate those IDs, we can just issue all the insert statements in kind of one latency hit across the network. This is a kind of like small little thing where those kind of little things actually, as an application developer, do add up and can make your application feel more responsive, even the fact that you're using a bigger identifier. And that kind of, again, the advantages of these being like universally unique is great for situations where you might say have geographically dispersed data. So if you've got data across 2 different European regions and you want to kind of actually be able to pull that data back together in a data warehouse at some point in time, UUIDs are great at knowing that realistically you're unlikely to collide if they're random, and if you're designing them carefully yourself, you can guarantee they won't collide. And this can be a massive benefit to sharding, and especially if we do what I like doing, which is encoding additional information into UUIDs. So, and somebody pointed out, this is maybe the hardware developer in me, but I like to bitwise encode information into UUIDs. I just see them as a 16-byte data structure that I can do something with if I know what I'm doing. And a lot of my applications across the years have been multi-tenanted, and what we've done is we've encoded the tenant information into the UUIDs. So by just having an object identifier for a record, we know which tenant it's for, and we can then go and say select a shard to go to or talk to, or we can get a whole kind of routing layer sort of for free just by using the size of UUIDs to be able to encode this information. Or for example, we might put a cluster ID in there for some certain distributed systems, or we could maybe get smart and use some form of partitioning information inside that kind of data type, maybe for say some certain kind of IoT or monitoring type platforms and systems. And then another one I quite like doing is just the ability to be able to know that this ID is like this type of record. So by just being able to put a simple tag inside your ID that says, actually, this ID is for an insurance claim and this ID is for a repair against that claim, can be kind of a massive advantage in certain situations where you might have systems where people have to type in these form of numbers or maybe a slightly smarter encoded form of that number. And you can make some kind of quick and simple decisions in your application there based on that kind of simple information and metadata that's inside your kind of identifiers. So as a simple example of here, right, let's just say a very simple multi-tenanted UUID setup could be, we make the upper 64 bits of the UUID, so the most significant bits, to be our tenant identifier, and then the lower significant bits of our UUID are just a 64-bit random number. So we've still got those kind of nice properties of them being kind of random and secure and hard to guess, but they're all namespaced by tenant, so we get some nice advantages routing. This is a very simplistic approach that's kind of worked perfectly fine in some of my kind of smaller systems. But this is where we can start getting some advantages out of it. But how do we then sort of trade this off with the performance concerns we've talked about? And how do we try and solve those kind of problems and get the best of both worlds? So how do we balance those different trade-offs together? Well, there's a new upcoming standard that's been kind of sort of ratified more the last couple of years called UUID v7. And these are effectively time-bounded or time-ordered UUIDs. So the upper 48 bits of UUID v7s are effectively an epoch-based timestamp. So it kind of gives you millisecond granularity of time. And then the rest of the ID, again, is just randomly allocated, or can be. And this is actually great for fixing the bulk of the problems we saw in kind of Postgres index performance, because we get that kind of natural kind of co-location of information again. And that correlation between where data naturally falls within our table heap, and therefore our free space map, and also the index. And as part of doing this talk, to some extent, I've been trying to formalize this kind of UUID schemes that I've used across a number of applications and actually just document this and share this a bit wider. So I decided to come up with the fun name for it, which was Fluid, Flexible UUIDs. And this is just a really simple version of using what's called a version 8 UUID, which are custom UUIDs that you can design your own schemes for. And this is, not necessarily perfect for everybody, and you might want to design your own for certain situations, application cases. But this is a great kind of getting started, and you can use these kind of approaches and how I designed them as potentially a shortcut, or use them directly in your system. So hopefully we'll have some kind of Postgres extensions to use and some kind of application code to make this a bit easier. And I've got two main forms of this. I've basically got a multi-tenanted UUID and then kind of an extended time version. And the idea here is that we still have a time component in there, so we still kind of play nicely with Postgres' indexes. And then we've got the information encoded in there that we can make useful to our application, such as that tenant identifier, some information about the entity, but then again, that random identifier that I kind of want. So we can take these and let's just kind of rerun our same performance benchmark. So if we take that kind of extended kind of format where we've got 32 bits of time information there, so we've got second granularity time information in there, then you can see we don't really run into that kind of shared buffers problem that we were seeing with the randomly allocated UUIDs. And this is very comparable to the performance you'd get if you just used UUID v7. So we kind of can see we've solved the biggest problem here just by actually making the higher order bits of the ID still being time bounded. And of course, right, if we talk about pure security context, there are situations where we don't necessarily want to leak this time information, but if you're really that sensitive about your IDs and you're in that particular use cases, you should probably not be exposing them at all. Now, the multi-tenanted version in the benchmark doesn't do quite as well, but we still don't see the kind of catastrophic kind of randomness that causes the problems. And then this is much more dependent on how many different tenants do I have across the data set within the benchmark. And maybe we can look at kind of sizing that, the amount of space we use to store the time correlation to kind of still fix and improve that. So these multi-tenanted UUIDs are actually only got hour level granularity. And maybe we'll need to spend a bit more space to try and fully solve the performance of this, or keep it at least at a reasonable, so it's not too much of a performance degradation for people. So let's just take a quick look at, well, what's the actual impact of my application from a perspective of insert performance if I was to store these. So I wrote a quick benchmark. I'm going to insert 10 million records from Java. It's fairly quick code. It's not the most optimized. But this is just to prove that actually the performance degradation is not that significant. We may be talking about, in the best cases, a 10% performance loss. And so again, this is a situation where all the records are 500 bytes, and we're starting from an empty table with an empty index. So we're not even bothering to create the index afterwards. And we can see here that the time to insert our kind of like multi-tenanted UUIDs is maybe only 10% slower than our standard big use case. And actually here, I suspect the performance difference we're mainly seeing here is just the extra pressure on generating lots of random numbers for this particular benchmark. And of course, it wouldn't be one of my talks without a nice bit of Postgres stored functions. And I also just want to prove that even in just pure SQL, that we can generate these kind of structured UUIDs inside Postgres. Now, we've got some tricks going on here that we're basically relying on the fact that the way we structured these identifiers, everything is aligned to nibbles. So we can actually just manipulate these as strings because we don't have any kind of bitwise functions to manipulate UUIDs directly. So we can just kind of, maybe it's not the most optimal approach, but in situations where you can't install custom extensions on, say, managed service providers, this kind of just proves you can still do it, and the performance isn't that terrible. It's obviously going to use a bit more CPU, but you can still use generate series with this without it being too much of a problem. And then, of course, we want to do the other side here, which is let's decode these identifiers inside Postgres as well. So we can take these identifiers and we can parse them. And again, we can just use those simple tricks of, well, we're just going to slice up the string, pull out the hex character we want, and then convert that hex character to a number. So we can easily extract the time information from these UUIDs, and we can extract the tenant information from these UUIDs. And we can do that inside Postgres, which then means we can say do something like this, which would be to query our tables and find all identifiers for, say, a particular tenant. Now, that's a fairly straightforward kind of thing where we can just call that function on there. And obviously in this particular situation, it's the most optimal is going to do a full table sequential scan because we're going to call a function every row. But again, this is where Postgres is awesome. And we can just use a functional index to actually now just index the tenant information. We don't actually have to have a tenant column on a table. We can just build an index where we need it and pull that information out of our identifiers. And then obviously up in our application land, we can use that tenant information that's built into our IDs to do sharding. So we can just decode the UUID that we've got in our request, select the kind of shard for that tenant, and then go and connect to that shard. And this is like so simple and so much of a benefit for certain applications where, especially SaaS applications, where you want to try and have some form of distribution. You don't have cross-tenant kind of connections within your data model. And so it's actually nice and easy to shard stuff per tenant. And then again, like, because we structured these IDs using the time portion as the most significant bits of the UUID, we can actually then use the fact that there is still some time correlation with our identifiers, and we can actually query these identifiers based on time. Because from Postgres' perspective, these identifiers are just 128-bit unsigned numbers. They still have some form of order guarantees. You know, a bigger UUID is still bigger than a smaller UUID. All that not necessarily seems so obvious. It's still true. And so we can actually use that. And so this particular query here, whilst those UUIDs might be difficult to understand what they actually represent, is querying for like a 5-day period on the start of these kind of the epoch of these IDs. And we can kind of use that kind of tricks to then do partitioning. So we can time-based partition just with a UUID column. So as a simple example here, we're going to take our very simple table and we're going to remove the primary key because we're going to partition by ID. And then we're going to say we're going to partition by the range of that ID. And then we can create some partitions against that kind of main table and this is where like a helper function to build those IDs from a timestamp makes it a lot more easy to understand what's going on. And we can effectively say here, well, we're going to create a partition for each month or each quarter or whatever, each year, whatever makes sense to your particular data scenario. And we can then just partition and based on that ID by saying, well, we know it's going to be greater than this value and less than this value. So thank you very much for listening. And if you want to find out more about that, go and check out fluid.dev. And there's kind of a bit more information about these kind of different UUID schemes I've got and how you can maybe go about using them.
Right. Thank you very much, Chris. I really love UUIDs. I use them in live, so I can confirm UUID v7 works really well.
Lots of good discussion on the Discord about this. Very active.
I'm surprised people are so passionate about either in favor or against UUIDs.
Yeah, totally. So just a reminder to do talk feedback for the speaker. The link is here. You can get socks. And actually, so there's a podcast. I don't know, many of you probably heard of it, called Talking Postgres. And Chris was actually a guest. So you can go back and listen to all of the recorded episodes, and there's new episodes coming out all the time. I was a guest as well. Dick, I think I listened to your episode live. So lots of good stuff there.
Yeah, so next talk is from Karen. She is a senior architect, if I say it correctly, at Crunchy Data, and she has seen a lot of companies on the inside. So I'm really curious about her talk about how to manage Postgres at scale.
Me too.
Hi, I'm Karen Jex, Senior Solutions Architect at Crunchy Data, and today I'm presenting Managing Postgres at Scale, Challenges, Tools and Techniques. So I'm going to be talking to you about some of the things that you might encounter as you work with Postgres at scale, whether that's managing huge databases, whether it's managing many databases, databases with large numbers of users or high transaction throughput. And we'll look at some of the things that you can do, some of the tools that you can employ to make that easier. So please stay tuned. Okay, so let's get started. Who am I? I'm Karen Jex, so Senior Solutions Architect at Crunchy Data, but also PostgreSQL Europe board member and chair of the recently formed Postgres Europe Diversity Committee. And here you can see that I come to my current position with a database background, so 20 years as a database administrator. And the talk today is based on experience, past and present, from customers who are actually working with Postgres at scale. So what do we actually mean by at scale in this context? Well, it could be massive databases, and the size of a massive database varies, evolves over time. So at the moment, that might be something over tens of terabytes in size. It could be a park of hundreds or thousands of databases. It could be particularly busy databases with a lot of concurrent users or very high transaction throughput. It could be databases where you've got a mixture of your day-to-day transaction processing, your OLTP activity, and complex queries for analytics. Or, as is usually the case, it could be one or more of those things. So this is what we're going to have a look at today. We will look at what some of the challenges are of managing databases at scale, and then some of the things that you can do, some of the tools and techniques that you can put in place to make that easier. So some database design and architecture aspects, monitoring and alerting, things that you need to do for high availability and disaster recovery, how you can optimize your database for a hybrid workload, and then some maintenance tasks, in particular auto vacuum. So each of the aspects that I already managed of databases at scale comes with their own set of challenges. If you're working with huge databases, then you've got to store large data volumes. You've got to deal with tables that have got millions or more rows. That might mean you've got bulk loads to do. You've got to think about data archival. You might have slow queries that are running over huge volumes of data. Maintenance operations can take a long time, things like re-indexing, vacuum, etc. And you might even run up against hardware limits if you're using all of the resources available to you. If you're managing hundreds or thousands of databases, you're likely to encounter scaling issues. So you either might need to keep increasing the number of people that you have in the team managing the databases, or the people in the team are going to only be able to do firefighting because they won't be able to keep up with all the necessary tasks. Or better still, you would put some automation in place so that you can handle more databases with a small team of people. It's difficult to keep things consistent across a lot of databases, so you'll get things like configuration drift. Maintenance tasks can be very time consuming, so just as with huge databases, but this time because you've got to perform the tasks across all databases. You've got things like security that needs to be implemented across all the databases, and monitoring that needs to be in place for all of the databases. If you've got very busy databases, you can encounter things like lock contention, potentially deadlocks. You could have too many concurrent database connections. You could have slow queries. You could have write bottlenecks. You could have I/O saturation. And you could potentially have issues with checkpoints and replication lag that you need to monitor and manage. If you've got hybrid workloads, then you can have other issues that come along with those. You've got workloads with competing needs. So you can have contention for resources. You could have conflicts with indexes. You could have to make sure that you carefully configure your database to be able to manage those complex long-running analytics queries and make sure that doesn't impact too much your day-to-day activity. So we'll have a look at some of the tools and techniques that we can put in place to help with some of those things. First of all, some database design and architecture considerations. So you might have to think about things like multi-tenancy. You might have many different users using your databases. You'll have to think about what kind of infrastructure platform you want to use, what operating system, what type of storage. You might want to look into partitioning, and you'll probably need to look at indexing. So multi-tenancy, as I mentioned briefly, that is where you've got multiple applications, customers or users, whether that's internal or external, all using your databases. And if you've particularly got a situation where each of your environments or each of your database clusters has multiple users or applications, then you've got multi-tenancy considerations. So I've talked about this in detail in a previous talk on multi-tenancy, so I won't go into it in too much detail, but there are many different ways that you can implement a multi-tenant architecture in Postgres. And to decide which is the right one, you need to make sure you balance the requirements of your different tenants. So you need to figure out how to co-host them and make sure that they have the isolation that they need, that they're going to get the performance that they need, that either you've got them all in one place so that you can manage them together, or that you've got them separate so that each tenant manages their own environment. When it comes to platform choices, you might think either of running your environment in bare metal, on VMs, or in Kubernetes. If you have a small number of huge databases to manage, then you might need predictable high performance for high numbers of transactions. You might need isolation from other workloads. You might need isolation in terms of security and that kind of thing. So in that case, you may well be choosing a bare metal architecture. VMs, on the other hand, let you manage more databases on fewer physical servers, but you still get that isolation for your database environments. It's much easier to provision a new VM than it is a bare metal server, and you can scale resources more easily. You've got a choice of cloud providers as well that will make VMs available at the press of a button or via an API. So that can obviously be a really convenient choice if you've got a larger number of databases to manage. Running databases on Kubernetes is extremely useful if you've got large numbers of databases to manage and you want as much self-healing, scaling, and automation as possible. Partly because Kubernetes automates a lot of the things that otherwise make managing large number of databases such a headache, including things like provisioning, scheduling, the self-healing, creating services and networking for you, providing persistent storage via persistent volumes, and partly because you've got Postgres operators for Kubernetes available for you, so such as the Crunchy Data Postgres operator, which CPK uses, Crunchy Postgres for Kubernetes. A Postgres operator takes care of a lot of the day-to-day tasks that a database administrator would otherwise have to perform. So your high availability, backup and recovery, security, monitoring and alerting, creating databases, database maintenance tasks, and even performing minor and major Postgres upgrades for you. You just declare what you want your Postgres cluster to look like, and the operator, Kubernetes, and the tools that are integrated will take care of the rest, keeping your cluster in that state that you defined. Even if you're not working in a Kubernetes environment, then automation is hugely important, and it's critical if you're managing a lot of databases so that you can have things repeatable, predictable, and you know what's happening and how things are working. If you're working with huge tables that can become difficult to manage, so for example, maintenance operations could start to take too long, perhaps you want to be able to create table spaces so that you've got separate storage volumes for some of your data, then partitioning is a really useful way to split a single large table into multiple smaller, more manageable tables. So imagine that this table, for example, contains millions of rows rather than just the 9 that we can see here. With partitioning, you conceptually still have one single large table, but it's physically split on the partition key into smaller, more manageable tables. Those are the partitions. So the partition key that you choose will depend very much on your use case. It depends on the way that your data is accessed and managed. So here, for example, I've used the ID as the partition key, and I've created partitions based on a range of IDs. So we've got IDs 1 to 3, 4 to 6, and 7 to 9 in those partitions. So as I said, it is important to choose the partition key carefully depending on how your data is used. If your queries mainly access data based on year, for example, then it would probably be much more sensible to partition based on year. That way, a query for 2022 could go directly to the 2022 partition to get the rows it needs and ignore the rest of the table. If your data was mainly accessed by region or some other field, then that might be the partition key that you choose. Partitioning is also really useful for things like removing large quantities of data. You might have data in your database that you're not allowed to keep for longer than a certain amount of time, or that's taking up space that you don't want to use. So you'd ask yourself the questions about how long you're allowed to keep data, how long you want to keep data. Do you want to delete the data, or do you just want to archive it to somewhere else where it's still available, but perhaps not as immediately? Do you want to do what we call a soft delete, so just mark the data as deleted, or do you actually physically want to delete the data? And partitioning can help speed up and make very easy that kind of deleting of old data. So here, for example, if you needed to delete all of the rows from 2022, if you did that as a delete operation, it could be a very costly, time-consuming operation. You'd probably also then need to regenerate statistics. You'd need to maybe recreate your indexes, form vacuum, etc. On the other hand, if you partition your table by year, then you've got a few simpler options open to you. You could, if you wanted to, just drop the entire partition for 2022. If you want to, before dropping it, you can detach it. You can turn it into a standalone table. So that could be useful if you wanted to use that to aggregate some data, or if you wanted to perform a final export or something like that. Indexing is very useful and necessary in a lot of the situations that we discussed. You can create indexes on multiple columns. You can create indexes on column expressions. You can create indexes that are just partial indexes, so that you're only actually indexing the data that you're going to filter on. So that can help make your indexes smaller and more efficient. So indexes will help speed up searches that are based on values of columns in the index. So things that filter, and they can also be helpful for other things. They will enforce things like primary and unique keys, but at the moment we're looking at ones that are useful for performance purposes. So you've got various different index types available to you in Postgres. They're useful in different situations, and I've linked to the documentation so you can look up more about those. But the default type, and the one that's used in most situations, is the B tree, balanced tree. The main thing to be aware of really with indexes is that you don't want too many. You want to create the indexes you need, but they take up space and they need to be maintained. So they can actually slow down operations that modify data. So you just want to be careful not to create more than you need. So here I've just given an example of what a B-tree index looks like. So it's a multi-level tree structure. It's got a single root or meta page. It's got multiple or one or more levels of internal pages, and each of those points down to the next level. And then there's a single level of leaf pages, and each of those contains tuples that points to the actual tables in the row. So this index represents an index on a beer table, on the beer type. And I've just shown the example for how the leaf page there would contain the pointers to all the rows that contain the beer type red ale. Monitoring and alerting. So you need to make sure that you've got the monitoring, logging and alerting in place that will make sure you know what's going on in your database. So if something's going wrong, or if you think something might possibly go wrong at some time soon, you can react quickly and make sure that doesn't happen. The ideal, if you can, would be to have some kind of integrated logging stack that will export database statistics for you, that will then send those statistics to something like Prometheus, where you'll define metrics and alerts, alert manager that will send off alerts to whatever system you want to use to be told of any issues, and something like Grafana, where you can define dashboards so that you can keep an eye on what's going on in your databases. You preferably want all of that to be automated for you, and you want to be able to turn it off for particular databases, because if you're performing a planned maintenance operation, for example, you don't want lots of noise going to the people that are having to manage and react to those alerts. Even if you don't have that kind of setup, then you can get a lot of useful information just from your Postgres logs. It's important to make sure that you've got some parameters set to make sure that you get the information in there that you need. So I've just given a couple of examples here. So for example, log min duration statements will write to the logs any statement that any completed statement that ran for longer than that given time. So here I've given an example of 1 second, but you'd set that for whatever counts as too long in your system, and is very useful for debugging purposes or in development, but just be very careful in production, because you could end up generating a lot of noise in your logs. And the other one that I've shown is the logline prefix, because by default, you don't get much information in logline prefix. You just get the timestamp and process ID. So you can set that to include a lot of different parameters and whatever text you want, so that it gives you useful information about who's doing what, where, when in your database. Another useful tool that many people use with Postgres is pgstat statement. So it's an extension that you need to add to your shared preload libraries. Then you can create the extension pgstat statements in the database that you want to use it in. And once you've done that, you can query pgstat statements to get information about long-running or frequently executed queries. A little word on high availability and disaster recovery. So even if you're not managing lots of databases, you're likely to need some kind of high availability in place. Certainly once you've got hundreds or thousands of databases to look after, you want as much of this to be automated as possible. You want to know that even if you're busy doing something else, if something happens to your primary database, one of the standbys is going to take over. Everything's going to be put back in place and be back up and running, so you won't lose time and you won't lose data. So this is just a diagram showing one example of how that kind of high availability architecture might be put in place. And I've given the links here. I'll share the slides so that people have got access to all of the links that I share in them. If it's not properly configured and monitored, then wall archiving is something that does tend to trip people up sometimes, and it's something that can cause issues in a busy database. So it's very important to make sure that you monitor, check that your walls are being archived to your backup repository as expected, check that your online wall directory is being cleared down as expected. Make sure you're alerted if there are any issues with wall archiving. Make sure there's nothing preventing this from happening. Otherwise, you could end up finding your entire system grinding to a halt, and then there'll be some kind of emergency as you try to fix it. I assume that you're using a tool such as PG Backrest to take regular database backups. As mentioned at the beginning, if you've got huge databases, then full database backups can start to take a long time, and they're obviously going to take a lot of space. So you could consider the frequency of your backups. Perhaps you can take less frequent full backups and replace some of those by incremental or differential backups. So an incremental backup will only back up the changes since the last backup of any type, and a differential backup will back up the changes since the last full backup. So those will usually be faster and take up less space than a full backup, but you just need to be aware and test your recovery to make sure that that still fits your requirements, because Postgres or PG Backrest, the tool that you're using, will need to combine those backups to get you restored, recovered, and back up and running if you need to restore. Okay, and then some words about optimizing for a hybrid workload, because a lot of people seem to be in this type of situation at the moment where they have both transactional and analytic activity going on, either within the same database or within a related environment. Configuration parameters are important for any type of workload, but particularly important in this case where you've got potentially competing workloads that don't necessarily have the same needs. So some parameters have to be set for the entire Postgres instance, and for those you need to carefully work to find a compromise that will work well for both types of workload. For the ones that you can set just for specific users or individual sessions or transactions, you can create, for example, an analytics user, and you can set the appropriate configuration parameters just for those users. So we'll just look at a few parameters for now. So database connections, max connections, you want to make sure isn't too high in general. So default's 100, we usually say maximum of a few hundred concurrent connections. If it looks as though you're going to end up with a lot more than that, for example, if you've got a lot of users or a lot of applications sharing a Postgres instance, then you'll probably look at something like connection pooling with a tool such as PG Bouncer. And you could look at creating a separate pool for your analytics connections, making sure that there aren't too many of those because they will be resource heavy. And then I'll just go very briefly through these. I'll leave the links so that you can look at more information. Work mem, you might need to increase for sessions that are performing large sort and hash operations. So that would include some of your analytics queries. You can make sure that it's set correctly by checking for temp files. So if temp files are being created, it implies you might need to increase that. You probably don't want to set it to a high value for your entire instance because you'll end up using a very large amount of memory. So you probably just want to set that for specific sessions that need it. Statement timeout, if you think you're going to have long-running analytics queries that could cause a problem for your other workloads, then you could set a value for statement timeout. That means they are cancelled if they run for too long. We spoke briefly about indexes in general, but for a hybrid workload, you will specifically need to look at that because analytics queries will probably need very specific indexes, particularly indexes on expressions. But again, it's very important not to create too many indexes because you don't want that to have too much of an impact on your day-to-day transactional activity. For analytics, is very useful to pre-calculate data, so you can create things like stored generated columns and materialized views. So a materialized view is a physical copy of your query results. So you've got that pre-aggregation. You refresh them as needed. So you would need to set up some kind of cron job, for example, to refresh the data as needed. And you can index materialized views. Best way of optimizing something is generally not to do it. So if you can avoid performing analytics activity on your application database, that's great. If you can have a separate analytics database. If you don't have a completely separate analytics system, then you can offload the activity to one of the standbys. And this works not just for where you've got a hybrid workload with analytics, but also for any type of read-only activity. If you've got heavy read-only activity, then you can offload some of that to a standby database to take some of the load off the primary read-write database. And you can also use a logical replica to do that kind of thing. Logical replication is more complicated than physical replication, and it has caveats, but you can replicate just certain objects. You can replicate to and from multiple targets. So you've got a lot more flexibility there. And then finally, in the maintenance tasks section, the thing that comes up the most often here is auto vacuum, which is described in the docs as optional but highly recommended. I prefer to be a bit more firm than that and say, please leave it switched on. But if you've got very heavy workload, very large tables, etc., then the default settings might not be enough to keep auto vacuum running as you need it to prevent table bloat, etc. So there are some parameters that you can set to make it work more efficiently. I won't go into these in detail. I will leave them here. I will just mention them. So you've got the max workers, the number of processes that can run at any one time. You've got how long it will delay between auto vacuum runs. And then you've got various thresholds that you can change. So if you don't think that auto vacuum is being triggered enough on a particular table, you can change some of these threshold values and scale factors, which will allow for the table sizes. You can change some of those so that the vacuum will be executed when you need it to be. So just as a summary, we had a look at what we actually mean by Postgres at scale. Talked about some of the different challenges that come with managing databases at scale, and then looked at some of the things that you can think about, some of the things that you can do to actually mitigate some of the risks and work around some of those challenges. So making sure that your database design and your architecture choices reflect the needs of your environments, make sure that you've got monitoring and alerting, automate as much as possible, especially things like your high availability and disaster recovery. Looked at specific optimizations for hybrid workloads, which is quite a special use case. And then a brief look at maintenance tasks, in particular, auto vacuum. So obviously, a short talk isn't enough time to go into all the details of all the things that you might encounter when you work with Postgres at scale, but hopefully this has given you enough of an overview and some of the most important things to look at so that you've got a good idea of where to start. And I would love to hear more. I'd love to answer your questions, so please do get in touch. Thank you.
Thank you very much, Karen. That was a lot of stuff to cover in 25 minutes. For those providing feedback, the title of this talk was Managing Postgres at Scale. And I have to admit, some of these things are painfully familiar. So,
next we have my colleague, Alexander Kukushkin, talking about myths and truths about synchronous replication in Postgres. Alexander is a principal software engineer at Microsoft, and he's really the expert on this. You're getting the expert. He's the primary maintainer of Patroni, super expert in high availability, and has a deep understanding of synchronous replication. So there is no better source. I think what's really cool about this talk is he does myth busting, going under the hood of how synchronous replication works, but he also at the end will touch a bit on where certain features that people want are in the community pipeline. And so I feel like it's a really great insider look at this kind of thing.
I feel this stream is a real treat. There are so many good speakers and talks and topics.
Totally.
Hello everyone, my name is Alexander Kukushkin and I work as a principal software engineer at Microsoft. I'm a Postgres contributor and today I'm going to talk about synchronous replication in Postgres and some myths and truths about it. If you are application developer or DBA, this talk might bring very interesting insights about these topics. Okay, let's dive in. We should start with defining what write-ahead lock is, because it's a central point in Postgres which makes sure about your data integrity, and on top of it, Postgres implements recovery, archives, replication, and so on. If you look into Postgres data directory, you will find in the PGWall a whole bunch of files with hexadecimal names, which typically is 16 megabytes in size. Although one may change size of write-ahead lock file. On top of write-ahead lock, Postgres implement replication. And there are two types of main types of Postgres replication. One is a log shipping replication, which is implemented on the primary by calling archive command. Archive command simply supposed to copy write-ahead log file to some remote storage, and on the standby node there is a restore command which copies write-ahead log file from remote location to PGWall directory, and Postgres will be able to replace this file. Besides that, on top of write-ahead log, Postgres implement streaming replication. And there are two types of streaming replication. One of them is a physical streaming replication, which is the main topic of this presentation. And the second one is a logical replication. Let's look at how physical streaming replication works. On the primary, Postgres write WAL files to PGWall directory. And there is a special process on the primary that exists, and name of this process is WAL sender. In fact, this process does not exist on its own. It is being started when WAL receiver on the standby node connects to a primary and starts asking for write-ahead log files. WAL sender streams content of write-ahead log files to WAL receiver on standby node, and WAL receiver on standby writes those files to PGWall directory. Surprise! It will be in this totally the same format, and content of those files will be exactly the same as on the primary. Besides that, on the standby node, there is a special process type which is called startup process exists. It reads files from PGWall directory and applies changes, transaction changes to the database. Basically, this way we get standby, which will be fully identical to the primary. There are two types of physical streaming replication. One of them is asynchronous. It means that when you execute transaction on the primary, it simply writes it to write-ahead log, flashes it to disk, and it is being streamed to standby. And your application doesn't wait until a transaction received by synchronous standby or any kind of standby. And the second type of streaming replication is asynchronous replication, which is the main topic of this presentation. And in synchronous replication, primary has to wait until a synchronous standby, one or many, depending on the configuration, confirms that they received, saved to disk, flashed, or applied your transaction. Before it happens, your application will not get a notification that transaction was successfully executed. And there are two types of configuration parameters that control synchronous replication. One of them has name synchronous commit, and the second one synchronous standby names. Let's dive deeper into every of those configuration parameters. The first one is synchronous commit. By default, Postgres sets synchronous commit to on. It guarantees that transaction that your application executes is durable locally on the primary. It also guarantees that it will be replicated to a standby, and it will be durable in case if Postgres crashes or the entire operating system or the entire server crashes. In case if you want to get confirmation only when transaction is already applied by standby and visible on the standby for client queries, you should set synchronous commit to remote apply. This setting must be set on the primary node. That's important. In case if you don't care about durability on server crashes, you can set it to remote write. And of course, like in this case, it will not be waiting for remote apply. And the second parameter is called synchronous standby names, and it defines two types of synchronous replication. The first type is priority replication. To use priority replication, you need to use very special format of synchronous standby names. You say first a number and then list of nodes that you want to have synchronous in parentheses. The way it works is that primary will be waiting from first nodes in the list for confirmation that transaction was either received, flashed to disk, or applied on the standby node. If the first node from the list does not respond, for example, it crashed primary, will switch to the second node and will wait for confirmation from a second node. It has certain disadvantages because it may take some amount of time for primary to realize that node 1 in the list is not responding correctly before it will switch to node 2. That's why in Postgres 10 we got a quorum type of stream synchronous replication, and to enable it you should use slightly different syntax of synchronous standby names configuration. Instead of first, you say any, and again number of nodes that you want to have synchronous and the list of nodes. In this case, primary will be waiting for confirmation from any node. Whichever standby node is faster confirming, that sort of wins, but it does not ruin guarantees that your transaction was committed, safely committed to more than one node, which is a primary. And let's try to discuss some myths about synchronous replication and try to bust them. The first myth that I really like, and sometimes people don't understand how it works under the hood, is people usually think the transaction is committed only after receiving confirmation from synchronous standby nodes. This is entirely not true, because the truth is transaction is always committed first locally. But primary holds logs, and transaction does not become visible until sufficient number of standby nodes confirmed that they received, flashed, or applied this transaction. And logs are released when necessary numbers of confirmations is received. However, there are exceptions. Transaction might become visible when a query is cancelled, like for example your query or your commit query is cancelled, when connection is broken, or for example when Postgres is restarted and you reconnect, and you will see the transaction is visible, although it wasn't replicated to a standby node. Let's try to see on the picture how the entire workflow of synchronous commit works in case if we say a synchronous commit is set to remote apply. It means that standby must apply transaction before primary can confirm to the application. Application sends a commit request to the primary. Primary writes commit log record to PG wall directory. Wall sender reads this commit record from PG wall and sends it to wall receiver on the standby node. Wall receiver writes commit record to PG wall on the standby node. Startup process reads from PG wall and applies your transaction. After transaction is applied, standby sends confirmation via the same TCP channel between wall receiver and wall sender, is the same connection that receives data, and it notifies primary that transaction was successfully applied. Only after that, primary will release logs and send confirmation to the application that transaction was successfully committed. You see how many steps there are, and in fact, commit happened first locally, and only after that it was sent to a standby node. So I think the first miss was busted, and therefore we continue with the second miss. Many people think that synchronous replication guarantees a 0 point in time point recovery objective, or it means that they will not have a data loss in case if they fail over to a synchronous node. The truth is, it depends. First of all, application may disable synchronous commit per connection in case if they want to or if they need to, by setting synchronous commit to local. In this case, a transaction will be written only to a primary, and application will not, and primary will not wait for confirmation from standby nodes before sending success to the application. And the second point, transaction also becomes visible on the primary when log is cancelled. It may happen when application actively cancels query, or DBA may also cancel this query when TCP connection between application and the primary is broken, or when Postgres, for example, restarts. How can we emulate this behavior? We start a single node Postgres and we set synchronous standby names to unknown, which means that it is supposed to get confirmation from the node, from synchronous node with the name unknown. Since this node does not exist, our transaction on the primary will more or less wait forever. So we create a table from a select query, and it hangs. Therefore, we just press Ctrl+C and cancel our query. And when after that we run select, we notice that table test, which supposed to be not created or not replicate or not become visible until it was replicated to a standby node, in fact, is there and it is visible, and we can read from this table the number of rows that we insert. For some people, it is a big surprise, but this is how it works in Postgres. And in fact, it's a very big problem, such cancelled waits, because it may lead to visible data loss if synchronous standby is promoted. There is some discussion happening on the Postgres hackers mailing list, and this discussion, this mailing thread exists for, I think, 5 years, maybe longer, and unfortunately it's not moving forward. But as far as I know, most of the cloud providers or some big vendors implement their own patches to mitigate this problem. And I don't understand why in Postgres core such patches are still not present. But it's not the single problem that transaction becomes visible on the primary after it's being cancelled. In fact, let's think about a situation when TCP connection between application and between primary was interrupted. In this case, application will need to decide whether it needs to retry this transaction or maybe it should not, and it has to somehow figure out the state of this transaction after reconnecting. And there are a couple of approaches to mitigate this problem. The first one exists for many years, and it's called two-phase commit. It's not easy to use on the application side, and it requires you some to put a lot of effort to implement it correctly. The second approach, which you may use, it's a special function which is called TXID status. It allows you to check whether your transaction, or not exactly your transaction, but some transaction with transaction ID was committed, aborted, whether it's still in progress, or maybe Postgres does not have current information about it already. How it can work? We start transaction on the primary, we insert some data in create table, insert some data into it, and before committing, we get transaction ID by calling function txid current. We can check in pgstat activity that after hitting commit, Postgres is waiting for synchronous standby to confirm. And we will see in the pgstat activity wait event type and wait event, which are set to IPC and sync-rep respectively. If we kill our connection, and if in my case, I also killed PSQL application. And after reconnecting, we can check status of our transaction by using txid status. And as you can see, transaction was successfully committed, although it wasn't replicated to a standby. And it's also visible, which is not nice. All right, so coming to the third myth, some people think that reading from synchronous standby nodes is like reading from the primary. You can, when you execute transaction on the primary, after that, you immediately can see it from the synchronous standby nodes. It's not entirely true, because transaction on synchronous standby is visible immediately, while primary may be still waiting for more synchronous standby to confirm. And it means that if you run a query and get result on the standby, fresh result on the standby, and you run the same query on the primary, you may not see such results because it is still waiting. As a result of that, please never do write on the primary based on reads from a standby. There are more side effects of this behavior. In fact, asynchronous standby node can be ahead of synchronous nodes. It means when you're reading from asynchronous node, you may also see some features that never happened, in case if primary failed and synchronous nodes didn't manage to replicate some transactions. And it is a big surprise to many people, but logical replication connection exhibit exactly the same behavior by default. If you don't configure your Postgres 17 in a very special way, or if you don't use PG failover slot extensions to mitigate it, your application that relies on logical replication again may see some events that didn't made it to synchronous standby. And there is no easy way to rewind your logical replication. And the last point on this slide, with quorum-based synchronous replication, you never know which standbys in fact are synchronous. You may randomly pick some of them, but it doesn't mean that they receive the latest transaction. In case if you want with 100% certainty read from a standby the same transaction in state you after executing it on the primary, you have a few options. First one, you need to set your setup to be fully synchronous by listing all standby nodes in synchronous standby names, and second, number of nodes equals to to number of nodes you have. The second option, you need to implement some logic in your application, which will be waiting for synchronous standby to catch up with the primary. The way it works, like before committing transaction or after committing transaction, you need to get current wall insert LSN, and you need to wait until standby replay up to this LSN. It would be nice to have a function in Postgres that implements such behavior, but it's not yet there, although discussion in the hackers mailing list are happening. Okay, and now the myth number 4. If we run synchronous replication, we don't need to use PG rewind. The truth is that wall on the primary is written independently from standby nodes, and while your application is waiting for a confirmation from the primary, some parts of walls of write-ahead lock maybe didn't made to a standby, and as a result, when primary fails, there will be no visible data loss, but primary managed to write a bit more write-ahead lock than standby, than the point when standby promote. It also may happen not because of transactions, but because some background job in Postgres like vacuum or after vacuum are running. They are changing some data, they are writing logs, but they are not, I mean, like, they are not changing your data, they are changing the data pages, but again, they are generating write-ahead log, and it may lead to the same problems. What means that PG rewind is required, like even in synchronous setups. And there is one more point when PG rewind might be required. For instance, there is asynchronous standby, which is a bit ahead of promoted synchronous node, which is totally fine because we might promise that transaction that there will be no visible data loss when we promote standby, asynchronous standby, but we don't count on asynchronous. And in such case, asynchronous standby also must be rewound. And the last myth in this presentation for today is that synchronous replication is slow. In fact, it's partially true, and to understand like what is happening under the hood, I did some benchmarking on my laptop. I put benchmarking in double quotes because my laptop is not powerful, of course, and to run benchmark, I used Docker Compose. I started 3 Docker containers with Postgres, and I used IP root tool to emulate latency between Postgres nodes. I was using more or less default Postgres configuration, only max connection was a little bit increased in order to handle required number of connections from pgbench, which was initialized with scalar factor 100. And on my laptop, synchronous commit was set to on, again default, and I was testing 2 different setups: priority synchronous replication and quorum synchronous replication. And here are the benchmark results. Please don't take it as a reference, like they just prove some like certain points about how synchronous replication affects your transaction latency, not more than that. And as you can see, latency of a single transaction in asynchronous setup was 5 milliseconds. And with synchronous replication, with quorum replication, it's already 12 milliseconds, and with priority replication, synchronous replication, it is 14 milliseconds. And transaction rate is almost twice smaller in asynchronous versus synchronous. Although when we increase number of connections, the transaction rate of synchronous replication is increasing a little bit. When we increase latency further, like between nodes to 5 milliseconds, we see that correspondingly latency of our transaction is growing. But the total latency of transaction consists of more or less three numbers, like latency of disk on the primary, latency of disk drive on the standby, and round-trip latency between nodes, which more or less matches this number. When we increase round-trip between nodes even further to from 5 to 10 milliseconds, we see that TPS latency is also increased by almost 5 milliseconds, maybe slightly above. And when we finally set round trip between nodes to 100 milliseconds, we see that transaction latency increased above 100 milliseconds. And at the same time, TPS really dropped for synchronous workload. What are outcomes of this benchmark? First of all, speed of synchronous setup depends on hardware and round-trip time between nodes. Please don't run synchronous nodes between continents because your application will be very slow. In most cases, for asynchronous setup, additional latency, transaction latency, is introduced by round trip between nodes. And it happens because clients has to wait until synchronous standby confirms when it received, flushed, or applied transaction. You can scale, of course, TPS by increasing number of connections, but final TPS will be always lower. So that was it for today in my presentation. Thank you for listening, and if I'm here to answer all your questions.
Whoa, that was a lot. Again.
I really enjoyed it. I got to preview it, and I feel like I definitely learned some things too, and I've worked on parts of replication. So
yeah, I have a talk about this topic as well, but it's more aiming for developers and kind of introduction into high availability. And I know we are skipping over some of these things, and I know they are not fully true, but explaining this high availability topic to developers, it's so complicated in my opinion. I always struggle, like, what can I tell them? What can I skip? But then they design on it, so they should know understand the details, but they're so hard to easily explain to someone. How do you do this?
And I think that also, even for developers working on Postgres features, it's cool that he includes the links to hackers, the discussions, because, you know, if you're not focused on a particular area, like I don't work that frequently on replication. So when I see threads come up about it, I don't always read them. And so watching this sort of piqued my interest. And then he has those threads like, you know, here's this discussion on hackers where, you know, I think this feature should be in core. And I feel like that really gets out to a wider audience of Postgres developers.
Yeah, it should be. So for those providing feedback, this was the talk about myths and truths. So that's the subject where you can leave the feedback. And again, please join the hallway track. You can ask your questions there. People are answering. It was a little bit quiet, actually, on Discord during this talk.
People are getting lunch, maybe. Well, on the East Coast. I guess not for you.
I would say having lunch is actually a very good moment to step in and be more active in Discord.
That's true. It was a really meaty talk, so I feel like well, a lot of people will be even rewatching it later once it's posted.
I'm definitely gonna rewatch this one. I just missed one detail about where the asynchronous could be ahead of the sync, and I was like, what? How? And then I missed it. So I will definitely scroll back to that moment to figure it out.
Yeah. Very cool. Cool. So next we have Varun Dhawan, and he is another awesome colleague of mine. He's a principal product manager at Microsoft. I met Varun, I think, the first time at PGConf New York a couple of years ago. And, you know, we corresponded, you know, not in person, but it was really cool to get to meet him in person. And he's so good at working the booth. Like I was working the booth for the first time and I was so nervous, and I don't, you know, know half as much as he does about all the features in Azure Database for Postgres. And so he's really great at talking about the features and listening. He's a great listener too, because he's really like customer obsessed, right? So there are people, that's like a catchphrase, but you meet people that are actually like that, and you're like, oh, wow, you like really care about customers and their experience. And he has insider knowledge about all the features. So he's really good at helping you pick your Azure database for Postgres. And he's going to talk about some of the new exciting features like autonomous optimization, elastic clusters, and disk ANN, as well as some of the bread and butter stuff. So it's a really good overview.
My name is Varun Dhawan. I'm a principal product manager here at Azure Database for Postgres team at Microsoft. Me and my team, we work on building Azure Database for Postgres Flexible Server, which is our flagship managed server offering. If you are using Azure Database for Postgres Flexible Server or planning to use it, this will be a great talk, to stick around. So see you there. Hey, hi. So let's get started. So my name is Varun Dhawan, and I'm a principal product manager. Prior to working in this team, I've worked 20 years before in many relational databases, particularly in Target as the DevOps DBA and in McKinsey. I'm based here in Minnesota, the beautiful land of 10,000 lakes, and I enjoy hiking and blogging, and particularly that's my blog, datanerd.blog.com. You can also find me on my social channels, including LinkedIn, Twitter, and Git. So this is the agenda for today. We will understand, what is Postgres, why it is so relevant in the industry right now, followed by what exactly which we do in Azure Database for Postgres, which is our flagship service. We'll go through the deployments, new features over there. We go through the enterprise readiness features, and eventually discuss a bit of an AI. So let's just dive in. So why Postgres? So Postgres is a large open source database. It's been around for almost 30 years. It's 30 years in development, and it's pretty advanced. From its time, it's extensible. It has got a lot of tooling around it, and enterprise loves it. Whether you are a small organization or large organizations, people have been using it, and it has got a lot of performance and scale. It can scale to any requirement. It has a lot of variety in terms of data types, whether it's text, whether it's search, whether it's geospatial data, and then more recently the vector data. And then this is something which you've consistently seen in most recent year, which is of course becoming more and more popular. Whereby this is from the Stack Overflow survey, where 51% of respondents in favor of Postgres above any other database. So there are two different personas when we build your database with Postgres service here at Microsoft. So one persona is the enterprise, like what is enterprise requirement, and the other being the developers. So let's go through each one of these items and then see what we've added in each of these areas, in last 12 months. So when you get started with Postgres, Azure Database for Postgres Flexible Server, the first thing you have to think about is what is the instance type that you will be using. So usual choices being the burstable, general purpose, and memory optimized. The burstable is a good choice if you want to get started, with a smaller footprint, and then you want to go, grow as you go. General purpose, if you're running a standard workhorse kind of a workload, it's great. It's 1:4 CPU to memory ratio, and you can scale up to 96 core. Memory optimized, otherwise it's for a larger, more resource intensive requirements. If you want to keep most of your data in cache, if you have a very high IO heavy application, then we suggest using the memory optimized. You can stop these instances. You can scale these instances, you can scale up, you can scale down, and you can take leverage of reserve capacity pricing to save on the cost. Now, key thing, running a managed service on the cloud is the elasticity, which means you can scale your resources up and down. You can scale your compute, you can scale your memory, you can scale storage. And most of these scalings can be done in online operations. So you really don't need, a lot of downtime. Now, storage is critical to any database because you store data, within the database, which eventually sits on, some persistent store. And then storage has to be highly performant, to keep up with those, queries that you run or the workload you run. With Azure Database for Postgres, there are two different storage options. There is SSD, which is the previous generation, and then there is SSD V2, which is the new generation. Now, V2 has certain advantages over the old SSD, which is, the larger disk size. It can scale up to 64 terabytes. It supports up to 1,200, megabytes per second is the throughput, and the IOP can go up to scale up to 80,000 IOPS. IOPS is very, it's very important for databases if your application is sensitive to latency. The most important thing that we've added recently is the ability to auto grow storage if in case you're running outside the storage. So you don't need to pre-provision the storage upfront in demand. And then storage auto grow is available both for V2 and then the older generation SSD. And then we just talked about compute, scaling compute. Now, near zero downtime is also a new capability that we've added, which allows you to basically scale your compute or your storage within 30 seconds. So you can scale your compute and storage together. You can scale them, separately. There's a very small downtime footprint abroad, which can easily be handled if in case your application can use a retry logic. And then eventually, how we handle it under the covers is we basically spin a new VM, and then we scale it with whatever resource sizing you want, and we just swap the VM. So that's how the near zero downtime helps you get the lower downtime. Now we run open source Postgres, and one thing which Postgres community does awesome job is to release one new major version every year. Last year, we released Postgres 17 on September 30th, which is technically just 4 days, after the Postgres 17 release, the community release. Besides the major version, which are released once a year, there's also minor versions which are released every quarter. And in Azure Database for Postgres, these minor versions automatically get applied as part of your, scheduled maintenance, which happens once every few months. Minor version upgrades, which gets deployed as maintenance, just normally take a very small downtime. For major version upgrade, there is an in-place upgrade option, and you need to plan for the downtime and you need to account for the breaking changes. So we've just talked about scaling of compute. We've talked about scaling of resources, how these can be done online, but there is another important aspect with Postgres, which is the scaling of connections. The Postgres is rather sensitive about connections. So every new connections, take some CPU resources, take some memory resources. A good way to scale your connection footprint is by using a connection pooler. And PG Bouncer is a very popular lightweight connection pooler. The extraordinary job that my team has done is that we've taken this open source connection pooler, we've baked it inside the service. So this comes as a no extra charge to you. And if you want to take advantage, you just go to the server parameter and just enable it. I recommend enabling this. And then instead of connecting to the default port 5432, you connect to 6432, and all your application connection goes via PG Bouncer. PG Bouncer will take care of all the idle connections, and it will bounce off the connections if they're not being used, and it will save a lot of precious memory and resources and CPU footprint for you. So you should you should definitely try this out. A larger public cloud provider, is known for, for a lot of geo scale. And one thing which we do extraordinarily good is try to make sure that Azure Postgres is available in most of the regions. So as we talk today, I think this is there in already 64 regions. It might be even a little more time, since the slide deck was updated. So you can take advantage of these regions, for your data localization and residency requirements. You can also take advantage of these locations, whereby you want to use paired regions for your geo disasters and geo backups. Now, high availability is very important. as you decide to run your mission critical workload, your e-com application or your banking or financial application, you just want most of these applications to be highly available. Now, there are scenarios where things cannot be available, some expected or unexpected downtime. High availability is an option to handle that. So when you choose to have your database highly available, at the provisioning time, we automatically create a secondary replica copy for you, whether in the same zone or cross zone, whatever you choose. And then we build a synchronous replication between these connections where your data, which you commit on primary, automatically also goes to secondary. And in the event where primary, is not available, it goes to an automatic failover, So whenever if there is a issue with specific instance or there is an issue with whole zone, the failover happens automatically. What we've very recently introduced is, HA health status monitoring, just to make sure that even when you do not have a requirement to failover, you can always check the failover readiness of your HA instances. Now, backups is the job number one for the DBAs, because data being the most important asset that DBAs manage. We have two different types of the backup. We have physical backups, which is managed via disk snapshots, and the logical backups. Let's talk about the disk backup first. The disk backups come auto provision. So whenever you create an instance, you automatically get backup. These backups are available. You can retain them from 1 day up to 35 days. Default is 7 days. I'll say go with the higher, it's like they save you a lot of pains, And then we also have an option for logical backups, which is basically the PG dump backups, which is your data written to a dump file in a secure location. And then these long-term backups can be retained separately from the database, so can be dealienated. And then you can store them up to 10 years with the help of Azure Vault. So take advantage of these two different backup strategy. So depending upon your application or business case requirement here. And then finally, we also have geo-redundancy, like what happens when the entire regions, is compromised. So for geo-redundancy, there's a couple of options, starting with the geo backups and the read replica. What you see over here is a classic read replica, where you can have up to 5 read replica. The diagram shows 2, where East US is your primary region, West US is your replica within the same zone, and then Canada Central is your replica, which is cross zone. So if something happens to East US, you have a choice to fail over to West US or Canada Central. The key difference over here is, in case of a read replica, the data replication happens asynchronous, which is, we commit it and it eventually is going to be consistent. Due to this, there is no automatic failover. Instead, it's an on-demand failover. So whenever you think that there is a requirement for you to promote replica, you can promote the replica. You can create up to 5 read replicas, and it's an asynchronous replication. So expect a little bit of a lag, which you can easily monitor using some of the metrics that we published. The key part over here is that besides being a synchronous replication, each server, has a different endpoint. You can fail over, and with the help of site swap, which is a new capability, you can also fail back. So it's really help you, offload your, read. Let's switch gear and talk about security. So there are 3 things I'm going to talk about, which is intro ID, customer managed keys, and private endpoints. Now, very important thing with the security is you need to know who is logging inside your database and what are they doing. While you have the local stored logins, which is your username and password stored within the Postgres, now you also have the ability to use the managed identity or the intra ID logins. Now, intra ID logins are the ones where the passwords is not stored inside the Postgres. Instead, it's managed by your corporate AAD, formerly AAD. Now we call it intra ID. And then user authenticate the intra ID credentials and all the management and login management that happens at the intra ID. So it takes away a lot of your pain, in managing users and logins and password, at the local level. But you do have a choice if you want to maintain the, the local Postgres username. Encryption is very important from a compliance purpose. You will just want to make sure that your data is encrypted, even at the rest, at the disk or at the backup level. And this can be easily achieved, by simply checking one single checkbox, which is customer CMK, customer managed keys. Today, we also offer the ability to automatically rotate the keys and make them versionless. So, it's very easy for you to manage the keys for CMK. And then you can store these keys with the help of Azure Key Vault or Managed SSM, which is a hardware security module. So I'll suggest, it's like there's no performance, hits for doing this. So you should definitely be using this. And then finally, we have private endpoints. I mean to say, hosting your database on a public cloud always makes you think, that now anybody can access my database. It's available on internet. Using private endpoint, you can make sure that anybody, only the connections which are originating from your own VPN virtual private network, they are accessible. They just go inside the database. With using this, you can prevent basically the data exploration and make sure that there are no leakages, and the private endpoints is directly mapped, to your specific database resources. What else is that you can even go further and configure more fine-grained access control with the network security groups or NSD. So private endpoint is like makes your defense more secure. Yeah. Now we talked about many things, including the backups, replica, security. One thing that DBAs loves and sysadmin loves is once you've everything configured, you just want to monitor all this, and you want to monitor it at a larger fleet level or a scale level. The monitoring in Azure Postgres is achieved with multiple ways using metrics and logs. We use a central service, which is Azure Monitor, which continuously aggregates your metrics and logs. And then once these metrics and logs are aggregated, you can do multiple things. So you can derive insights using multiple monitoring solutions and query performance insights. You can easily chart and visualize this data using your favorite tools like Grafana, Workbooks, Power BI. You can respond to them by setting up alerts or using the service health. And you can analyze this for a long-term predictive model using writing powerful KQL queries or using the Matrix Explorer. We want to bring in some autonomous capabilities beside the reactive monitoring. And one of the autonomous capabilities that we've recently introduced is the index recommendation. Index are building blocks of performance. And then one feature that we introduce is the index recommendations, whereby once we enable the index recommendation, again, just a checkbox, we automatically start analyzing your workload. And based upon your workload analysis, we start suggesting you a couple of things regarding your indexing strategy. So A, are you missing any index? Like by creating an index, can your workload run faster, your queries run faster? And then number two is, do you have a lot of redundant or duplicate indexes, which is just every time your auto vacuum is running or every time you're inserting your database, it's an extra overhead of updating, these duplicate data structures, and you can get away from these indexes. So once you enable this, you automatically get these recommendations, and you can, choose to follow these recommendations. And then what you see on the right-hand side is, some of the, some very high-level analysis for our customers, who have enabled index recommendations, and they have seen drastic improvement their query execution time, both for select, inserts, updates, and deletes. It's almost half, after enabling the automatic index, recommendations. Postgres, is really extensible. It's really special as a database. You can extend the capability of Postgres in many different ways. There are thousands of extensions in Azure database for Postgres. We support like almost 70 plus of those extensions, the key ones, including timescale, Postgres, PG audit, more recently PG vector. It's very easy to enable an extension. You can do it with a CLI command. You can do it with a portal. You can do it with an API or Terraform. What recently we have introduced is the ability to upgrade the extension version. So you don't have to basically go to a different version of Postgres only to have a new extension version. You can just do it staying within the same version. And some of the new extension at the time of writing this deck were the Anon and Oracle FDW. Then we have the ability to do the major version upgrades. A major version upgrades, Postgres community release one major version, every year. They've been very consistent for past many years. And every major version comes with a lot of improvements, a lot of performance improvements, and we want our customers to always be taking advantage of these major versions. While you can use more conventional tools like a PT dump and restore, but one of the most native and easy way of using a new major version is running the major version upgrade, which is just one single click upgrade feature. You do not require to migrate the data. You do not require to set up a separate server with a separate cost. There is some downtime, but fact that everything is automated in a major, in the MVU experience that we built in, that downtime is minimal. You can do the MVUs with both portal and CLI. And there is a lot of observability logging, which is available for major version upgrades. So just in case you run into some pre-upgrade issues, we generate a log. We tell you what are the reasons by which, your upgrades are not compatible. The reason why you cannot go from 15 to 16, for example. You can read the logs, take care of those issues, and then retry the upgrade. So I say, definitely, whenever it's possible, try to stay latest, be running on the more latest version. Now, Elastic Clusters is a new feature that we've introduced, last year. Everybody loves, this the awesome extension Citus, which helps you scale your database horizontally. Otherwise, the relational databases are basically known to scale, vertically. With Citus extension, you can shard your database, and you can shard based upon this row-based sharding, the schema-based sharding, or maybe shard at the database level. With Citus extension baked inside the Azure Postgres for Flexible Server, which we call the Elastic Clusters, now you have almost the infinite scalability, and you have a very simple sharding mechanism where you do not have to spend a lot of time re-architecting or rewriting your applications. You can promote your database from standalone to a Postgres cluster. So if you're today running a single standalone flexible server instance, you can actually convert this into a Postgres Elastic cluster, and it has 100% compatibility with Postgres. All the goodness of Citus extension. From an AI perspective, I want to talk about a couple of things. So one, definitely PG Vector, gets supported out of the box because thanks to the goodness of PG Vector extension. Now, using PG Vectors, one thing we realized is that it was quite a challenge, for DBAs to integrate the PG Vector, extension and then talk to LLMs, for all the AI requests, which is why we also built an Azure AI extension. So combined with PG Vector and Azure AI, you can actually vectorize the data, and then you can integrate it with any large language model such as an OpenAI, and then easily run your AI type of workloads. The thing that I'm specifically calling out in this slide is the disk KNN. So every data type needs its own specific indexing. Initially, we had HNSW and IVF flag. However, Microsoft Research, have worked on a new index type which works, beautifully with the vector, which is disk KNN. And we have implemented disk KNN. It's available as an extension in Azure database for Postgres Flexible Server. But it makes the vector queries run faster, and it makes the vector queries runs really accurate. So this is also a new feature that has came along in last few months. So if you're planning to use vectors, and if you're planning to use Azure AI extension within Azure database for Postgres Flexible Server, give disk KNN a try. Compare it with HNSW and IVF flat, and you will see the performance improvement that we achieved from quantization, the compressions and the SSDs. Finally, a lot of things that I've talked about, we almost, we have a good release velocity. We release a lot of these features, every month. And one thing that our team does a lot is blog about these features. So this is our blog. You can follow our blog over here, which is Azure Postgres blog, and then you will keep seeing all the new features. We'll keep talking about all these new features over here. Yeah. And then this is a bunch of resources, some of the important ones, like I will really recommend to get started, with a free account, if you haven't tried. If you're already using Postgres, then obviously our blogs and talks is something that team invests a lot of time in making sure that these are updated with month on month every time we release a new feature or we release a new improvement. There's a lot that team does, on LinkedIn. and other social platforms, you can ask questions over the channel and reaching out to us over the email. Yeah, with that, we've come to an end. Thanks for being around. Now, while I'm over here in the conference, I'm also taking questions from Discord. So just in case there is anything that you had in question which I presented, or anything which I never presented and you still want to ask about Azure Database for Postgres Flexible Server, I'm hanging on in Discord, so definitely shoot your question over there. If in case you also want to hit me up, on LinkedIn, please feel free to do that. So again, thanks for spending time with me and listening to all the new features that we have released for Azure Database for Postgres Flexible Server in the last 12 months. Hope you find them useful and enjoy your conference. Thank you.
Thanks to Varun. You should give him talk feedback if the link below for Posette survey talks LS3, and then just search for what's new with Azure Database for Postgres there. And
so Melanie, trick question. How many languages do you know of this final slide?
I think that one of them was Hindi, but how many do you know?
Yeah, one. I have no clue about all the others.
Was it English?
Yeah, the thank you, I think is English. I can manage that one. All the other ones, I was like shocked. I feel so oblivious to these things.
There's quite a few.
Yeah, but I expected more Roman scripts. Yeah.
Well, next we so there's one more live stream left, live stream 4, and we're going to watch a trailer for live stream 4 to see all of the cool things that it has in store.
Hi everyone, and welcome to the 4th year of Posette, an event for Postgres. My name is Charles Pedersen. I'm the Director of Product Management for Postgres at Microsoft, and I'm pleased today to be able to tell you about all the things we're building in Postgres at Microsoft in 2025.
Hello everyone, I'm Marco Slot. I work at Crunchy Data, and I'm gonna talk about a journey we've been on for the past 18 months to build a Postgres data warehouse. So if you're interested in using Postgres for analytics, or you want to know more about what's possible using Postgres extensions, this will be a very interesting talk.
Hi, my name is Derek van Veen. I'm a database specialist at Azure, and I mainly work on a partitioning framework. So, of course, this talk is about partitioning. So if you're managing tables around 100 gigabytes and more, this is definitely the talk you want to see.
Hello, I'm Amit Langote. I work at Microsoft in its Postgres open source team. In this talk, I'm going to talk to you about how Postgres executor interacts with modern CPU and how that impacts its OLAP query performance. I'll talk about a few things we've done to improve that, and then some architectural directions we could take in the future. So if you're interested in OLAP performance, please join me.
Hello there, everyone. I'm Michael John Peña. I'm a Microsoft MVP and MCT, Data and AI Director at Playtime Solutions. I'm here to talk about building enterprise RAG applications with Azure PostgreSQL. And if you're looking for something about embeddings, vector search, all things around LLMs, this is the right place for you.
Hello, everyone. My name is Péter Farkas. I'm the CEO and co-founder of FerretDB, which is an open source alternative to MongoDB. And today I'm going to talk about turning MongoDB into an open standard and implement it on Postgres. So if you're a MongoDB user, if you're a Postgres user, if you are both, then you might be interested in this presentation where we combine the power of these two database technologies.
Hi everyone, my name is Adam Volk. I'm a Principal Technical Program Manager for PostgreSQL here at Microsoft. Today I'm going to tell you how to travel using row-level security with PostgreSQL and Citus. So grab a towel and join me if you want to learn how to use row-level security with your application.
Hello, I'm Eileen and I work at Marketing at DBTune. My talk is titled Setting Max Connection, Building Postgres User Groups that Bring People Together. I'm really excited to be here at Posette today. I'll be sharing some practical advice on how to create successful Postgres meetups. If you're interested in fostering thriving Postgres communities and creating interactive and fun small and large scale events, this talk is for you. Now let's get started.
Hi everyone, welcome to Posette Conference. I'm Rahila Sayed. I work as a senior software engineer in Microsoft. Today I will be talking to you about monitoring in Postgres and also will be explaining a design of monitoring feature in Postgres. This talk will be useful for developers and administrators who are looking to learn more about monitoring in Postgres.
Hello and good day, this is Jan Karremans. I head up sales in Cybertech, but I still think I have sufficient technical background to take you along on an interesting journey in securing Postgres with streaming replication. It is one of the hidden in plain sight cool features of Postgres that might just help you save the day.
Oh, there's a lot of talks I'm looking forward to. We did not get to preview Livestream 4 videos, so I have not seen any of those yet.
I've only seen one of them.
Which one?
Wow.
Oh, yours.
Actually, I've not seen it, but it's always a bit weird to see yourself.
You didn't watch it?
I think, were we able to watch our own videos? I think we just did recording and
Oh, okay. I never used to watch my own talks, but then Robert Haas said to me that he listens to his old talks and then uses that to try to improve specific areas that could have been better. And I was like, oh, I should really be doing that. So now I force myself to listen to them, as painful as it is.
Yeah, I do the same. I usually record them on my phone. I ask someone to just put my phone against the glass or something, so I have the recording and some visuals of my own talks. And sometimes I delay watching them for a week or 2 weeks because it's so painful to watch.
It's really hard.
It does help you improve your presentation. So I keep on doing it and I keep watching them back. So
yeah, you can feel confident knowing it's never as bad as you think. You're your harshest critic.
That is definitely true as well. But then when you watch it, you see everything.
Totally.
It's like the audience looks at the bigger picture, but if I'm looking at myself, it's like, this hand gesture or how I formulated this sentence or...
Totally. Well, I'm really excited to welcome Jimmy Zelinskie next. He's a co-founder of Offset and the CPO, Chief Product Officer. I actually have a friend who works at Offset and told me about what they do, and I got to talk to him about it. And he was a coworker with Jimmy at CoreOS before, and that team's just amazing. They, really are responsible for bringing containers to the mainstream. etcd, you might have heard of it. So they've done a lot of really amazing things, and really helps are a really big part of contemporary distributed systems. And so Jimmy has a lot of deep expertise in consistency models, which we care a lot over here in database lands. The interesting thing about this talk is that the project that he's going to talk about, SpiceCV, needed strict serializability, which is even more strict than regular serializability, which Postgres only has serializable isolation level. So they had to find a way to implement it, and they did it on Postgres, which is something I wouldn't even have thought to attempt. So it's pretty interesting, and it's cool to hear him talk about internals and there's all these people and companies out there in the ecosystem and startups and projects that are really getting their hands dirty in the Postgres source code and doing cool things with it. And I think this is a great example of that.
Hey everyone, I'm Jimmy Zelinskie. Today I'm going to be talking about implementing strict serializability with PGExact. If you're interested in correctness and the internals of Postgres, this is a talk for you. Okay, let's get started. Today I'm going to give this talk, but I'm going to break it down into a couple of different chapters just to give everyone an idea of the structure of the overarching talk. Right now I'm giving you the agenda, but then I'm going to give you my bio just to understand who you're listening to, why you should be taking these seriously, why anything I'm saying matters whatsoever. Then we're going to kind of give everyone a refresher if you're unfamiliar with what consistency is. I'm going to cover that at a very high level, hopefully enough for folks to understand it if they've never been introduced to the concept whatsoever. But it'll be mostly a refresher for folks that are familiar. Then next up, I'm going to cover what strict serializability is, which is a particular type of consistency that is the focus of this presentation. Then I'm going to cover why we at my company needed strict serializability and why you might need it. Odds are you probably haven't heard of it or needed it if you're listening to this talk. So definitely needs covering. Then I'm going to talk about our initial approach at trying to actually get strict serializability out of Postgres, how we implemented it at the beginning, and then where we arrived once we discovered pgexact. And then I'll kind of cover some of the trade-offs associated with how we did it and kind of give conclusion on that. So who am I? My name is Jimmy Zelinskie. I am the founder of a company called AuthZ. AuthZ builds a particular type of database called SpiceDB, and that is specialized for building authorization infrastructure. So our domain is explicitly designed around kind of who has access to what. But prior to that, I worked at a company called CoreOS, which is really known for kind of pioneering the container and cloud native movements. And alongside Docker, CoreOS was kind of like the major company that kind of brought containers to the mainstream. While I was there, I worked both on scaling out kind of SaaS products running Postgres and MySQL. So I have a really good understanding of the internals of those systems from that experience. But also CoreOS built a database that had a particular type of consistency level called linearizability that we'll cover later. So I also kind of worked deeply with consistency models. And ultimately, etcd actually became the underlying data store that's used for Kubernetes. So out there, everyone running Kubernetes is also running etcd, and maybe I'll cover a little bit about why that matters for that use case. So what is consistency? If you're familiar with databases, you may have heard this term ACID before. That stands for atomicity, consistency, isolation, and durability. Some folks say that the C was originally made up just to make the acronym work. Whether or not that was the case when they made up this acronym versus how it's used today, totally irrelevant. Today, it's very much so a real thing, and it's one of the things that people care about the most because it's the thing that people are actually using to kind of design trade-offs and make trade-offs in the systems they're designing versus a lot of the other properties are kind of fairly standardized among databases. So there's a lot of ways you can define terminology. I think, especially when it comes to computer science research, you can get pretty deep. But what I think is most important is kind of covering terms in the way that everyday engineers kind of talk or how software developers communicate with each other. So my definition for consistency, kind of using that philosophy, is the contract for how data can actually be observed. So when developers are building systems, there's kind of these three different systems at play. There's the domain that they're working in. So say you're building like a healthcare application or a financial application, right? A banking application. The domain is like that logic around finances or doctors and patients, things like that. Then you have your application. That's the code that you're writing. And you're going to be making assumptions about your domain as you're writing that code. But you're also going to be making assumptions about the third system, which is the place where you're storing your data. And there are fundamentally guarantees that your database is going to be providing you about how you can actually observe and interact with that data. And if at any point in time in between those three, one of your sets of assumptions mismatches with reality, that's where things start to go really wrong. If you're lucky, you'll get errors. If you're unlucky, you'll just actually have data that is effectively corrupted. It never followed the assumptions that you needed for either your domain or the assumptions you're building into your application. So that could completely create invalid data for your entire data set. So these things are really bad. And when that happens, your data is invalid, which means you might have to restart from scratch from all of your data, depending on what you're working on, or you might have to choose a completely different database technology and completely re-architect your application, all of which very, very big changes that you have to make to your code base. So giving like a little bit of an example just to make this concrete, because that's fairly abstract what I just talked about. I'm going to give this example of a parent supervising a child purchasing something from a shopping cart. What is going to happen is a child is going to read the shopping cart. They're going to look inside the shopping cart, see the item was already in the shopping cart, and then they're going to purchase the item. And then the parent supervising everything is going to check out that shopping cart and see if the purchase took place or not. And what's really important about this is if you're modeling the system, basically, this is the ideal scenario. It's actually probably the most unlikely of all the possible scenarios that are going to execute. What is far more likely is this scenario, which is there's going to be some interleaving of these events. The child opens up the shopping cart, and then the parent opens up the shopping cart. And then the child buys the item, and then the parent happens to buy the item because when they loaded the shopping cart in the first place, the child hadn't performed the purchase yet. So there was kind of like nothing informing the parent that they needed to like refresh the shopping cart after the purchase took place. And so this kind of double purchase took place, and that's totally undesirable behavior in the system that we're modeling. So that's the most likely scenario. And there's kind of one important thing to note here is that what's happening is the purchase decision is actually dependent on that shopping cart view. So reading the shopping cart as a dependency of actually making the purchase. Because computer scientists like to sound smart and use terms from physics, this is called causality or a causal dependency. But really what it just means is that dependency, that data dependency between you have to have read this to ultimately make the decision to perform this following action. Now, one solution you might be thinking about is, okay, what if we take everything with causal dependencies and smash them into one event that takes place at once? That would actually be largely talking about atomicity inside of these database systems, and with using the ACID terminology, and a little bit of isolation in there as well. But that's not actually kind of covering consistency. And that's because in real world systems, not only is there this ordering of the events as they take place, but this additional factor that is talking about the visibility by which when changes are actually viewable by other folks operating in the system. So here I've kind of combined the child's operations all into one atomic procedure. So they're reading and buying all together. And I have the parent still broken out. I think that helps just to help understand the interleaving, but it doesn't matter if I had that also combined to be one atomic event. I have this item on the bottom of the timeline, which is when the child's purchase actually becomes visible. It's quite possible that that could happen even after the parent performs the read or an atomic read and buy. And that is, you might be thinking like, hey, I've never heard of this visibility thing. Like, what is that? How is that even possible? But you probably have heard of this. You've only probably been thinking about it when it comes to read replicas, when you have a leader and a follower kind of set up in your database architecture, and you're streaming asynchronously changes to the follower. You don't always have the most fresh data to work with in the view that's queryable from the follower. So that's probably intuitive that this scenario can happen in that case. However, this also happens on single node deployments of databases like Postgres, because there's a time at which a transaction is being committed to the system and when it becomes visible at the query layer. And so that, while the window is way smaller than something asynchronously replicating across the network, is still a real scenario where visibility is impacted and you can start making these types of errors in your system. Great. So now we understand the basics of consistency. I have this kind of eye chart on the right. I don't think you need to worry too much about it other than just understanding that there's kind of a hierarchy of talking about the guarantees that you get at different levels that are kind of modeled so people can pick the right systems that provide the guarantees that they need. Today, what is really important is to just look at the top three and note that strict serializability, which is what we're talking about, is literally at the top. So today we're just trying to get Postgres to actually be as consistent as we know how to model in computer science. There's kind of color coding and things going on there. That's not super important for what we're talking about, but it is kind of talking about like the roughly failure domains when you choose these types of models. So what actually is strict serializability? Well, strict serializability is basically the idea that your database, you can kind of group it all together as one object, and that every single transaction that happens on that database object has a strict ordering, and everything, every transaction that happens can see the results of the transaction that happened before it. So the idea of having that total ordering is what serializable means, or serializability means. And the idea that you have this visibility of the thing that happened before you is the real-time constraints that you get out of a system that is linearizable. So that's kind of why these two come together to give you this kind of comprehensive total ordering where everything is visible one after each other. All right, when would you need this? And why did SpiceDB need this? So this is the thing that's going to vary greatly depending on what you're working on. For SpiceDB, because our domain, our business domain, is authorization logic, we actually need to solve a certain class of errors that can happen when a user is revoked access from a particular resource. And after that revocation, if they were basically evaluated with a stale permission, they could see new content. So that is a security vulnerability fundamentally in the system. I don't want to get into too many details about the domain just because it's not super relevant. But needless to say, our domain has this requirement that is based around kind of revocation. And if you use a stale view of the system, someone could potentially see something they otherwise shouldn't. And when it comes to authorization and permission systems, that is the name of the game. If you can't build a system where you can guarantee that folks can only see the things they're supposed to see, then you failed to build a secure system. So we fundamentally need this to solve our problem in our domain, which means we need it just no matter what we were doing, we would actually have to solve this problem. Now, how does SpiceDB relate to Postgres? That's a great question. Lots of databases have this storage layer abstraction built into them. And Postgres and MySQL are no exception to this. They usually work by having an underlying key value store that persists things to disk. And that's usually pluggable to some degree. And what happens in SpiceDB is we also have a similar layer, but instead of plugging it into key value stores that persist things to disk, which we totally could, instead what we do is we actually persist that data, similar data, to external databases over the network. Why would we do this? This seems kind of crazy, right? The value you really get out of that is folks can then run SpiceDB and point it to a managed cloud service already providing like managed Postgres. So then they don't have to run another stateful service and they can just kind of get that managed database experience for free. That gives us some unique requirements, like we can't use custom Postgres extensions. We can't write custom code and extend Postgres because we need guarantees that whatever strategy we're going to use to get strict serializability has to work across all of these different cloud implementations that don't allow people to install custom plugins and often aren't even built on the same core storage engine that Postgres itself is implemented with. Think of things like Aurora on AWS, which ultimately underlying everything is still DynamoDB at its core. So that is kind of the overarching challenge that we had. And then kind of just making this very, very concrete. One of the APIs that SpiceDB has is literally a change feed where we publish updates to our consumers in order. So fundamentally, we have to have everything in order and in real time so we can publish these results to the consumers of this API. Great. All right. So how did we even start approaching this problem in the first place? Well, we kind of looked at what was available to us. And Postgres actually supports serializability built into the core engine. So we could reuse at least Postgres's ability to order things. But that wouldn't give us that real-time visibility, that linearizable aspect. So what we ended up doing is saying, hey, we can't use transactions as they're built into Postgres, like natively. What we have to do is implement our own abstraction around transactions. So naturally, we created a table in Postgres called transaction. And what we ended up doing is storing effectively a primary key in there. And that is because that gets auto-incremented by the server, that gives us a total ordering. And then we basically manage what's called our own MVCC layer, which is multi-version concurrency control. This is a common design pattern for databases. And in fact, Postgres has its own implementation of this under the hood. But what we're doing is basically just keeping track of living data that has been deleted at different versions. So we keep track of the transaction at which data is created, and then the transaction at which data is deleted. And then we have to do that all ourselves. Users of Postgres normally would just get this for free because it's an abstraction provided by Postgres. But then there is this overhead, which is the vacuum. When you have deleted data and it gets very old, you can't just keep building up this data. Eventually, you run out of disk space. So what Postgres does internally for its MVCC is it has the vacuum process that every so often runs and cleans up very old dead things. So with this strategy, we have to implement our own form of vacuum or garbage collection where we go through as well. So that's one of the trade-offs is that overhead. And it's not built into any data store. We have to build it into SpiceDB. So SpiceDB has to be aware of how to clean up Postgres. So this strategy actually works, and it works pretty well, but our larger customers started having throughput problems a couple of months in. So this was not going to be a long-term strategy that was going to work for us. So ultimately, we started to stare at the Postgres documentation to figure out, okay, what else can we actually do to solve this problem? And ultimately, what we did was we found this extension called pgexact. And pgexact is built into Postgres. It ships by default. And what it does is it is basically metadata storage around transactions and snapshots in Postgres. What's most important about that is not only is it keeping the stuff on disk, but it also gives you built-in functions in the query language in SQL for you to be able to probe at these things, ask questions about them, and understand them. So I kind of have this some examples of those on the right-hand side here. But what's really important here is to understand the primitives by which we are working in Postgres. Every single time you query Postgres, you're viewing a snapshot. And a snapshot is actually a collection of transactions. A range of transactions occurs at any particular snapshot. And so we have this representation in Postgres, which is basically 3 sections separated by colons. The first section is the transaction minimum. This is the minimum transaction that went into the snapshot. And then we have the maximum as the next value. And then finally, we have in progress transactions. So these are transactions that would fall in that range in between that min and max, but actually haven't completed yet. So these are exceptions inside that range. And then what's really important here is that Postgres actually gives us this nice function that actually tells us if a transaction is visible within a snapshot. So we can actually provide a transaction and a snapshot and ask Postgres, hey, can you see this inside of this snapshot? That's going to become super, super critical in the next section. So our idea was fundamentally to take these components, now that we have these primitives, and replace our own bookkeeping, keeping track of what a transaction is, with the internals of Postgres. Now that we can poke at Postgres and understand what its transaction IDs are and what snapshot we're working with, we can actually keep track of those and store them in our transaction table and use that as our handle to understand the overarching system. And then when we're talking about the creation and deletion of our tuple data, we can just say, we can reference the transaction ID instead. And the nice thing is we can use server defaults. So we can say, by default, just give me the current transaction ID and just give me the current snapshot. And when SpiceDB is actually talking to Postgres, it doesn't have to figure out what those are and insert them into the table. You might be wondering, why do we need the snapshot ID or the snapshot values if we have the transaction ID? And that is actually because what we're going to ultimately do is synthesize our own custom snapshots. So we're actually going to take that snapshot, which was the view of the system when the transaction executed, and then we're going to take our current transaction and we're going to insert it into that range to say, this thing is marked alive. This transaction is visible. And by doing that with every single one of our transactions in that transactions table, we can actually create a state of Postgres for each transaction in between each snapshot. So that's what's getting us our total ordering that we couldn't get before, the total ordering of each transaction flowing through the system. So the nice thing about the PG is visible in snapshot SQL built in is that we can actually provide both sides. We can provide the snapshot and the transaction. So by doing so, we can actually synthesize these snapshots with our transaction marked as visible inside of it, and then pass that into Postgres and use that as a filter. Because we're not relying on saying, give me a real snapshot coming from Postgres. We can actually just create our own and tell Postgres, this is what the snapshot should be, and tell me all the things that are visible in this snapshot. So we're doing some pretty tricky stuff there, but it actually makes it really simple when we're trying to just filter what's dead or alive, because we can just say, is this visible in the snapshot? We just add a nice where clause to the query of just pulling out the relationship data, the tuple data. Now, what's really, really interesting about this is the watch API I was talking about before, where we have the change feed publishing things in order. To do that, ultimately, we rely on one more bit of functionality from PG Exact, which is something that you actually have to enable ahead of time. So you have to, when you start up Postgres server, say commit timestamp equals on. But afterwards, what happens is the time at which every transaction is committed to the write-ahead log is stored as well. So by having that timestamp associated with the write to the wall, we have this total ordering there as well, because only one thing can be appended to the wall at a time. So that all of Postgres has this kind of serialized order of events that is deterministic and stored inside the wall. And this is really giving us a hook to grab that and understand when the transaction was exactly committed. And by doing that, we can just actually slap on an order by on a query that is fetching basically all the new revisions that happened after a particular snapshot. So the last time we published the change feed, we did it at this particular snapshot. Now we have this particular snapshot. Give me, basically tell me all the things newer than this. And then we run this query and we just sort it by the time it was actually committed to the wall. And that gives us our total ordering. So that's kind of the secret sauce to getting that full total ordering out of the system. Now, how far has this taken us? Right before I said it only lasted a little bit with our naive implementation. Well, this implementation has actually been tested on the largest Postgres instance size on Azure, and it still operated totally fine. So we're pretty confident that this is one of the better ways we could get this functionality out of Postgres. But that's not to say it has no trade-offs. One of the things that's really important about this is the transaction ID counter, the thing that's actually incrementing what transaction IDs are there. That's not something you can set. So if you were to PG dump all of the data from one Postgres instance and then load it into a new one, instead of starting at the transaction ID of the last time you kind of inserted data into our tables, you would start at a very low number, probably like 1, 2, 3, 4, instead of 10,004. So there's no way to actually just set this counter and say, hey, this counter should be like the minimum number we see already inside of our transaction table. So we actually just have like a little SQL script that uses the procedural language in Postgres to just do a for loop and just increment this. We basically create a transaction and roll it back in a loop. And that's just the fastest way that we can actually get that counter bumped up to the value where it's going to be valid again. So that's kind of an annoying gotcha that takes place in what is often a very sensitive operation when you're doing a backup and restore. You could be doing that in a very sensitive kind of outage scenario where there's a lot on the line. So we understand that is kind of like a very, very painful edge case. The other thing to note is that basically transaction IDs have the capability of overflowing. They're just 64-bit integers. And actually, we're lucky that we started the implementation when we did, because in older versions of Postgres, they're actually 32-bit integers, and this was way more likely to occur. But this isn't a problem unique to us, because the transaction IDs are actually being used internally by Postgres. The Postgres developers themselves have to solve this problem. And so what happens is, to avoid overflowing that number, what happens is every 2 billion transactions, the vacuum process runs, and it effectively freezes sufficiently old transaction IDs. And in older versions of Postgres, this freeze was actually just replacing the transaction ID with a magic constant. But I think in more modern systems, how they work is they actually keep like a secondary kind of table that just marks these values as special. Now we're lucky we don't actually have to create any additional logic around this, because our domain of authorization data, as things become stale, as permissions become stale, they become irrelevant to these systems. So we actually can just run our garbage collection, our own vacuum process, way more frequently than how often Postgres is running, and can effectively guarantee that you will never be in one of these scenarios, regardless of just how much writing you're actually doing to a system. So we actually just kind of lucked out that our domain enabled us to never even be close to this particular scenario. Cool. That's all I have for y'all today. I just want to shout out to the Posette engineering team. Jake, actually the CEO and one of my co-founders of Posette, created this initial design. I really want to thank the Postgres documentation maintainers. Without that, we would have never been able to discover this strategy whatsoever. PGpedia is also a super useful tool once you know what you're doing with Postgres and you just want to share, like, how does this function work, or what does this particularly do? Great tool to just share that with your share that knowledge with your coworkers. And then I want to thank Kyle Kingsbury, who created kind of Jepsen and all the consistency content I have, that graph that I showed you, modeling the different models and how strict they are. That is all content based by him. He actually does a service where he will consult for folks and test that the consistency guarantees of their database that they advertise actually meet reality. So he has a great source of information just of understanding the different trade-offs that go into these database systems. And then I want to thank the organizers of the conference for letting me talk on this topic and organizing such a great event. So thanks, everybody.
Super cool. I feel like I don't hear about people talking about things like isolation levels and concurrency control very often in these types of conferences. So it's like nice to go back to sort of the, database and distributed systems and like sort of the base computer science basics, and then hear about people working on solutions that have to do with them that are not theoretical now.
Yeah, it's been a while since I've seen a talk so technical. It's like, oh man, I need to rewatch this like 2 or 3 times to fully get it.
Yep,
Now just at the stage, like, this is really cool, and I see what's going on. It's like, why do I need this today? Jimmy just posted the link in the chat, and I'm definitely gonna watch it and read it.
When we
It's cool
previewed
stuff.
these, I went back and read the Jepsen docs, and then I was like Googling around, looking at the, the Zanzibar paper, and then I found Andy Pavlov's old standard, he always titles papers so irreverently. It's "Nobody Cares About Our Concurrency Control Research," just like one of the talks about database isolation levels, and has some good slides in it too, if you're looking for a less, I say dry, but more animated version of some of what's in the Jepsen documentation about concurrency control and isolation levels.
All right, for the feedback, you can scan the URL, no QR code again. And this was the talk Implementing Strict Serializable by Jimmy Zelinskie. So that's how you can give your feedback. If you have any questions, just come to the Discord channel, ask your question. If you are the one having a question, probably 10 others are also having the same question. So please spill your questions, and we will do our best, and the speakers will do their best to answer them.
Very cool. So next is Ravi. He's actually my manager. He's a group engineering, he's at Microsoft, a group engineering manager of the PostgreSQL engine. And he has a ton of experience in systems engineering, which is really cool because he came to our team having that background in file systems and embedded operating systems. And I think this talk is a really good sort of like, a mixture of that area of expertise and then applying it to Postgres. I mean, Postgres is an operating system, so Postgres is very close to the operating system. So it's, when you look in the code, knowing things about what system calls are being used, and being able to use strace and being able to use these like other utilities that help you see how the database is interacting with the operating system. Like out of all the applications that there are, databases have to really think about how the operating system does certain things, and knowing, what certain system calls are doing, or using a different system call when you're developing a database that's more optimal for what you're doing as a user. Even just like learning more about what Postgres is what operating systems calls Postgres is using, can even help you like tune Postgres. There are, block device settings and other OS settings, like kernel settings, that you could change. And so just like understanding that interaction is really helpful from the perspective of like running your Postgres better. And actually, like every day, Postgres is, like AIO reads went into 18, and every day Postgres is taking advantage of more new operating system functionality. So this is a really like timely talk, and I feel like it's a good refresher for people that took OS classes or who are Linux sysadmins or whatever, but also for for Postgres developers and users. So.
Hello, everybody. I am Krishnakumar. I work as a group engineering manager at Microsoft, working on PostgreSQL open source as well as the managed service side of things. Today, I bring to you a talk called PostgreSQL and Linux kernel interactions. In this, you will learn a lot about the internals of how Postgres interacts with the Linux kernel, and how to look at this, how to debug this, and a lot more. Welcome and come watch my talk. Thank you. Cool. Let's get started. Before we go into details of the presentation, let me give a little more detailed intro of myself. As we just talked about, I'm engineering manager for Postgres engine at Microsoft. I started my career a couple of decades back, porting Linux to custom MIPS and SH4 boards, as well as writing kernel device drivers. From there, after learning about embedded systems, I moved on to HPC and parallel file systems, and more of these deeper storage related areas. Then I joined a startup called StoreSimple, which got acquired by Microsoft, and then thereby joined Microsoft. In Microsoft, I worked while in StoreSimple area, then moved to Kubernetes, then moved to databases space. I have been working in Postgres space for some time now, both on the open source side of the space as well as the managed service side of Microsoft. Then one of the top like top things that happens during my day-to-day interactions is that I get to interact a lot with Postgres experts, and that gives me an opportunity to learn a lot more internals, and I'm fortunate to have such people in the group as well as people in the community from whom I learn a lot. This talk is primarily based on lessons learned from such interactions, as well as a lot of homework and a lot of issues that I have tried debugging in the past as well. Cool. So we'll go look at what are the various areas that we'll cover in this talk. What are you going to really learn in this, right? That we'll talk about that a bit. So first thing is that we will look at this tool called strace, which is usually used for debugging purposes. Here we are using this as an educational tool as well. strace will give you indicator of how what kind of system calls are Postgres really calling. And also will give you where it's waiting, where the cumulative summary of it, and details related to it. So Typically, you would use this as a debugging tool, but in this case, we'll use this more educational purpose again. From here, we will move to like the overview of how Postgres interacts with the Linux kernel. So just so that you know, like the title does say it, but just I would like to repeat this, that we will be talking more about Linux kernel interactions in this case. Postgres runs on many other platforms, and there are internals to learn there as well. But for interest of time, we'll just focus on Linux side of things. From the kernel interaction overview, we will move to typical system calls with Postgres would make. In general, what are the areas that we would cover, as well as that Postgres common calls occur. So primarily, we would then shift to how process management is done within Postgres by the help of these system calls from the Linux kernel. From there, we will look at memory-related system calls, signals, and then we will go and dig deeper into some of the areas of file management. Basically, in file management, we'll dig deeper into the read side of things, buffered I/O and direct I/O. And also we'll talk about recent features which has been added into the into Postgres, primarily in areas where Postgres interacts with the kernel side of things. We'll then quickly switch to exploring how prefetching is done in Postgres using these kernel mechanisms. Then we look at other system calls which are used, then also cover some of the newer, like PG17 and Postgres like 18 newer usages of some of these calls. And from there, we'll conclude our talk. Cool. So let's move. So strace is a very useful tool in many scenarios. These are used to debug issues. In this case, we'll use it for learning how system calls are made. Here is a screenshot of an strace command. Strace has the ability to attach to a running process. In this case, we are using the PID of the process, using -p to attach to it. We are using this flag in strace, which will make sure that even if the process forks, it still can follow the child and then also account for the calls which are made from the child as well. So those are the -f and -p flags. -c would give you a cumulative summary of how the usage of system calls were happened while running the session. So in this screenshot, I ran it for a while and then did Control-C to stop it. As you can see, the summary of the system calls that were made. Some of them were a lot of opens were made, or a lot of closures, and then there were like fsyncs and writes and a bunch of these things. A bunch of the system calls were made. So this shows you the summary of the calls, but typically you would use this to debug scenarios where, let's say, you find a process which is hanging and it's not moving forward. Then you can attach using a strace and figure out which call it's hanging, and then reverse understand what's going on, and from there figure out the root causes of issues. Here we'll continue to use a strace in the next set of next portions of the slides as well. At a high level, Postgres interacts with the kernel via the libc calls, which is interesting because when you run a strace, what you would see is the system calls. And when you look at Postgres, you would see the glibc usage in the code. So a lot of times, what happens is that libc abstracts out the complexities that are there from the system calls, right? Like you don't have to hand code the system call a number and or like wrap it around and various other like complex scenarios that you have to take care. You can just make some calls and things will start working. For example, for fork, the call of fork would actually end up with the system call of clone with a bunch of flags that needs to be passed around, and libc will give you an abstraction which you can directly use, and it would end up in a clone call. Pread is another place where when you look at the calls that are made, you'll see the pread, but the period would translate to period 64 in the platform that you're corresponding. If you're using 64-bit platform, that's where you would end up. That's what you would end up seeing in the histories. Malloc is another example where eventual system call is this break. Then there are a bunch of layers which we go through to before we get to the BRK system call. And once again, glibc comes to your rescue and makes it all a lot more simplified than what actually it has to do. The takeaway here is that Postgres interacts with the kernel via glibc calls, and there is a lot of simplification and abstraction that gets done, believe me, making somebody coding in Postgres their life easier when they interact with the kernel. Cool. So next we will look at the examples of some of the areas that Postgres makes system calls. I have just listed some of the top areas, like process management is definitely an area where Postgres uses a lot of system calls. Postgres currently is a process-based system. So as you can imagine, it needs to start a new process. It needs to get the PID of the process. It needs to exec some other process. Like there's a bunch of these interactions that it has to do with respect to process management. And a lot of these system calls are used in the way of making such operations happen. Memory is another area where we do have local memory for a given process, and also we have shared memory which is shared across processes. For both of these scenarios, there are a bunch of system calls like brk, mmap that we would use in order to make this happen. And again, like this goes through libc, but it's good to understand, learn, and kind of like have a picture around how these operations happen. Another area where Postgres uses system call is the signal area. There are many examples of signals getting used because it's again like process-based architecture. So stopping a process by using sigterm, like killing a process using sigint, and a bunch of these operations that needs to happen between two processes do happen via signals. So not just the user interactions, but also between processes, the interactions happen via signals. The next set of things that happen is like file interactions. So lot of Postgres operations are file based, as in both the val, the write ahead log, as well as the pages that are corresponding to the database are all stored eventually as files. Because of this, you need to open the file, close, read, write, sync, and a bunch of operations that you have to do. All of this again translates back to calling system call via glibc, but file-based system calls. Then as Postgres allows networking connections, you need to have network system calls as well, like listen and socket and accept and a bunch of these calls that you need to do as well. Those all happen via help from kernel and Postgres maintenances. There is a category of calls that Postgres makes, which is called VDSO. It's called a virtual dynamic shared object thing, wherein every process in Linux would get this object. It will look like a system call, but it's a faster way to access some of the commonly and frequently used system calls. For example, getting the time is like a frequent part of dealing with the programming side of things. So VDSO provides you an easy way to do this, where you necessarily don't translate into the don't transfer into the kernel side of things, but at user land itself, you can get access to some of these updated variables which kernel keeps make sure to update. And we are not going to go into details of this in this particular talk, but in general, it's good to be aware that there are these category which is looks like system calls, but like somewhere in the middle, hybrid form of this is what you would get on regular Linux process. Now let's let's go deeper. So first, let's look at the process management side of things. Here in the example, the first screenshot on the top right, what you see is that the postmaster comes up as a main process. Then it is spinning off its children like checkpointer, background writer, wall writer, and so on. All of that it uses this system called clone. On the bottom, what you see is basically an station which is run to trace out what kind of system calls happen. As you can see by the red marked areas, the PIDs which are all generated newly from the postmaster are all done using the clone system call. So every time Postgres starts off with the postmaster coming online, then subsequent children are spun off from it using the clone call. And also at the end of the day, those children also eventually end up calling some of the other processes. Like for example, here the archive call, which is like the process 23678, actually calls in another process whenever the archival has to happen. So that's why you see another clone, which is a slightly different variant of the clone system call, and then a separate PID is spun off from it to actually do the archiving part of it. So as long as Postgres remains to be process-based architecture, it will continue to use a lot of these process-based, process management-related system calls. That's kind of the takeaway from this slide. Let's look quickly at the memory-related system calls. First thing to go back and remember is that we are in a process-based architecture, so there are many mechanisms that Postgres employs to have processes talk to each other. Some of it is via the memory, and shared memory is a big part of how Postgres is architected. The technique generally, which starts off with, in case of a static scenario, is that Postmaster would allocate some shared memory using the mmap call with anonymous backing, and then with the right flags, like in this case map shared, and then it would allocate this memory. Whenever our child process spins off from this postmaster, it would actually get access to the shared memory, and then that shared memory is used as a common area where uh, processes can talk to each other and kind of make make the conversation for the life cycle of Postgres to continue. For the local allocations, like the BRK regular malloc functionality happens. For the shared thing, the nmap gets used, and in regular cases also nmap gets used a lot. So one system call or one takeaway from this slide, it is to remember that in case of memory and shared, and even in some local scenarios, mmap is the system call that would eventually get called into when Postgres operates over the memory. Cool. So the another area which needs a little bit of attention is the signals side of things. Postgres uses signals in various scenarios, both when it is taking in a user input, right? A user wants to tell Postgres processes to do something like, hey, sigterm or sigint, or sig user, or some other communication between the user and the process. Also, there are scenarios where Postgres uses it for its regular operations. And here is an example where that happens, where let's say the Postgres postmaster has some operation going on, and the background worker needs to come in and talk to the operation, and it's trying to synchronize certain operations. So in some scenarios, there is this concept of latch, which is used in many scenarios actually in Postgres. There is the concept of waiting on a latch and setting the latch where we are operating on this common space. So in case of waiting on a latch, it would use a combination of epoll, which is yet again a kernel facility which is available. And then the whole aspect of epoll and polling on a signal FD kind of scenario, which is like file descriptors where you can wait on. Conceptually, that's the thing. Like you have a set of file descriptors and wait on the file descriptors, and somebody who's now used the common resource that Latch is waiting on and wants to tell the other waiting processes that, hey, I'm done with it. Please go ahead and you start trying to access the resource. At that point, the set latch would send the cgurch signal to indicate that the process is now able to free up this resource from what it was doing, and then the waiting process can try to acquire the resource and do the operation. So the concept that needs to be taken away, or like can be taken away from here, is that Postgres uses signal a lot in many scenarios, like for both for user scenarios as well as for internal operations. And a typical scenario of like wait latch, set latch is an example where this gets used, but it gets used as a tool of interprocess communication a lot across Postgres code. That's the point we can note from here. Now, let's talk a bit about read side of things. As I was explaining in the earlier slide, Postgres operates on files, both for the write-ahead logs as well as for the database pages. They're all files on the file system. So at some point in time, whenever Postgres has to read some data from these files, it uses the regular read system call. It's like pread eventually, right? Like the translation is like pread 64 eventually, where it will read from the disk. But the thing to remember is that kernel plays a big role in this, that when we are just doing a pread, it's like a buffered read, where every page that would be read generally is like cached in the kernel's page cache as well. And then when Postgres tries to access it, it's also available in the buffer. It's also brought onto the buffer pool. So the concept of double buffering comes into picture here, where whenever Postgres tries to access some data from the disk, it will actually be accessing the copy of this from the page cache, and kernel will maintain this page cache using its own algorithms and its own mechanisms to make sure that Postgres doesn't incur the overhead when it tries to read it next. But at the same time, it also incurs this overhead that it also buffers itself, right? So Postgres is an area where it keeps these buffers, right? Like the buffer pool, and it has a shared area where it keeps it. In case of WAL, there's a WAL buffer as well. But there's all the extra memory used in kernel to buffer it. But in totality, this mechanism works well because the sophisticated algorithms that are used in the kernel page cache buffering would help Postgres from a lot of performance issues. So it does help, but note that there is like double buffering happening in this case. So that's the summary of this slide. Let's look quickly at what direct IO would mean in Postgres world. So back in Postgres 17 and like around 17, we have this facility where you can enable direct IO now as a debug option. The whole thing is not yet fully wired, so it's requested to use in a developer debug mode. The screenshot that is shown in this picture shows how the signal, the buffer is like read in. Here on the left side, there is a table which is read. Like, note that this experiment was done like freshly. So then when the table is read, you'll find that the next, the third command here would actually indicate that the table read is buffered in the page like buffer pool of the Postgres, and at the end the fincore command is run. This command will show you if there are pages from a given file which is kind of cached in the buffer cache, like the page cache of the kernel. So as you can see on the left, there is an 8K page which is like buffered in the page cache of the kernel run by fincore. And this is the typical operation, like normal operation, where direct IO is not enabled and you have like double buffering going on. On the right, what you see is that we are now enabling the direct IO just for testing purposes. And then we do the same operation freshly. The copy is made in the buffer pool. But then when we look at the fincore operations, we don't find any contents there, right? So that's where the difference between a direct IO and buffered IO would come into picture, where the kernel no longer buffers these pages. At some point in time, we would expect that Postgres would have direct IO and would gain all the associated performance benefits from it as well. There is another quick concept that I wanted to bring to your attention. That is like in Postgres 17, there is this functionality which was brought in where there typically Postgres would read 8K pages, like periods would happen. Here on the right side screenshot, you can see several 8K reads has happening for accessing a table. Whereas in 17, what you would see is that a single period with like a vectored read would happen. What that means is that if Postgres figures out that there is a combining that's possible, it would convert this to one call, thereby reducing the translation cost to the kernel by just single call. Prefetching is another scenario where a lot of these kernel optimizations can be used, wherein in 16, like Postgres 16, 17 kind of scenarios, where fadvice is one of the call that can be made, where you can tell the kernel that, hey, I will need these areas of memory be read in advance. So which is like basically telling it to prefetch them. And then as Postgres gets to the point where it is really accessing it, it's already present in the kernel buffers. What that will bring is a lot of optimization, because as Postgres process through its whatever it was doing, for example, let's say it was doing a recovery and is trying to read each of the records and try to replay. By the time it reaches the right record, all of these backing pages of both the wall as well as the pages would be there in kernel buffer, and the performance would be less performance would be penalty would be incurred with this. Another area where a lot of system call is used is like fallocate, where whenever a relation has to be extended, you typically end up using this fallocate system call, where there's no IO needed. It's like telling the kernel that, hey, extend the area, and then that single operation can bring you that. Another area is like seeking, where Postgres needs to know about the file size, and typically getting the file size information is a like overhead operation. So we would do like an lseek and then like figure out where the end of it, and that is used as the size of it. There's a lot of patches which is being worked on, where eventually these things will get cached and they will not be needing to do a lot of lseeks, but typically you would find this in Postgres operations in all recent versions as well. Sync file range is another space where whenever checkpointer has to do write back, it will do only specific ranges of write back, which would make sure that the IO workload is kind of like spread, and the whole write back is controlled in a way that there is not too many overloads at single point in time. So that's another thing to keep in mind while looking at some of these things on Postgres. Fairly newer usages like copy file range is a space where there's a lot of usage that is coming through, where in the incremental backup restore, we use the copy file range and then create a database from template, which will come in Postgres 18. Also, we use copy file range, where you really don't have to do the copy inside from the kernel to user land and then copy it back. Instead, you just say this and kernel will just do this between the files. So that's another newer form of usages. I mean, the system and infrastructure existed, but Postgres is now using this a lot more. Big area of usage is the IOU-ring, which in Postgres 18, one of the most exciting features that is coming is that AO will be present now in most of the critical read paths. Here, the kernel facility of IOU ring is what Postgres can use, and that brings the async IO into the Postgres world as well. So these are fairly newer uses of it. There are many more usages of this getting planned as the modernization process of Postgres goes in. So that's the take of this thing. Cool. So we have come to the end of this presentation, this talk. I just wanted to say thank you to a lot of folks within the PostgreSQL committers and contributors team at Microsoft. Thank you, Thomas, Sanders, Amit, Daniel, and Teresa for helping with this presentation, and in general, the community for being such open and collaborative environment where a lot of things can be done in Postgres, as well as people can come and learn. Hope you had a wonderful time. To get in touch with me if you want to learn more about more kernel interactions of Postgres. And thank you for attending this session. Thank you.
Nice. It's the second time I see this talk, I think, and I'm still impressed.
Yeah, all the diagrams are super helpful too.
Yeah. So if you want to give feedback to this talk, search for the kernel interactions. That was I was looking for. I was looking for all the words he was using, but it's easier than that. It's just the kernel interactions. It's so easy if you understand that.
I feel like it's a good reference presentation too, if you're like, you want to, think about how to do an example and go back and remember how a particular thing works. So.
Yeah, it's like you run into issues on a live system and you start debugging. It's like, how did it work again? And then it's good to fall back to these kind of things.
Totally.
Speaking of falling back, I wanted to say actually something about the YouTube stream. At the moment, there are captions on the YouTube stream, but they are automatically generated. These are not the final captions. The final captions will be edited to the videos, and these are the bigger captures you also see in the at the beginning of the talk, or the how do you call this, where all the talks are connected to each other with the introductions. I forgot the name of it.
Are they connected by the introductions? What do you like? Transition? No?
Yeah. I forgot. It doesn't really matter.
Okay.
They will be better.
Okay. Yeah. They edit them after, which is really nice, because usually you have to do that yourself after you give a talk at a conference. We're going through that with that dev right now. People going through and editing the file, and they're like, "Can I take out all the ums and ahs?"
Can I change the 12 writings of Postgres to just a single one?
Yes. Cool. So next we have a talk from Sarat Balijepalli. He is actually at Microsoft as well. He's a senior engineering manager. He is in charge of the performance charter for Azure Database for Postgres. And I'm really excited about this talk. I also got a sneak preview of it. But when he was thinking about the topics for his talk and that kind of thing, we chatted, and we talked about, he sees so many, customer systems and like the most difficult customer performance problems. He, ends up in those calls and seeing those systems. And so I was like, I bet you have a bunch of really interesting anecdotes, or kind of like, even themes of things that you see people doing, and that it would be really cool to tell those stories. And so he does some great he goes through some great examples, and also he does some root cause analysis. And it's cool because when you're in deep in the weeds with performance stuff like he is, you also try to keep up with what is going on in the community and what the open source team is doing. So we learn a lot from each other, and I think that you'll really enjoy this talk if you're interested in Postgres performance.
This is the talk maybe I was most scared of watching, because we rely on partitioning like really heavily, and we found a lot of performance issues. And every time I see a title like this, I'm so scared that we didn't find them all yet, and that I have a lot of work to do tomorrow.
And maybe it'll save you the even more work in the future.
Yeah, that's the good thing, but still I'm a little scared. So yeah, let's get started.
Yeah.
Hello everyone, my name is Sarat Balijepalli. I'm a Principal Engineering Manager at Postgres, Azure Postgres team. Today I'll be talking about Postgres partitioning challenges. My talk would be useful for database administrators and database developers. So let's get started. So today I will be talking about Postgres partitioning challenges. So quick intro about me. I'm a Principal Engineering Manager in Azure Postgres team. I have 18 plus years of experience working on Oracle and Postgres databases. Here in Azure Postgres team, I have experience working on diverse customer workloads. This talk is based on the experience that I have working on diverse customer workloads. One hobby of mine, which I like to share, is I like traveling and explore new places. So what are we going to talk about today? So we will talk about basic concepts. What is partitioning? What is the need for that? Then we'll context switch to partition pruning. Then we'll talk about the two partition challenges, the high planning time and lock manager contention. Then common solutions are what we need to take care while creating partitions on the tables. Then we will also talk about what is new that is coming in Postgres 18. So what is partitioning? Partitioning in Postgres is nothing but a technique where we divide a very large table into smaller chunks, which are called as partitions. Essentially, we are dividing a very big table into smaller chunks, which are called as child tables. And the bigger the table, the parent table, is split into smaller child tables. So why is partitioning important? What is the need for that? Basically, I can say that we have 5 real advantages of doing partitioning. One is improved query performance. Second is reduced index overhead. Third one is efficient data management. Fourth one is improved maintenance. Fifth one is improved scalability. So I'll talk about improved query performance and improved maintenance to start with. Improved query performance, because when you partition a table, say you have a table of 200 GB in size, and we do 5 partitions, 40 GB, then we have smaller chunks, and we have queries running on these small child tables. Then it doesn't have to scan entire 200 GB. It has to only look into the 40 GB. Definitely the query performance would be better. Improved maintenance, 2 things I can add. One is we can detach the partitions, and maintaining the tables become easier. There is no need for deletes, so good archival strategies can be built around this. The second one is, since we are having partition tables, which are nothing but smaller chunks of the larger table, the auto vacuum can be efficient, because the auto vacuum runs on the child tables or the partitions, and then we can tune the auto vacuum according to the child table need. So that's a very good addition to have. Then enhance scalability. You can always go and add new partitions, so it provides the scalability option. Definitely index overhead is another partition improvement. The reason being, you index a table which is 500 GB compared to indexing a table with 40 GB. The index sizes are smaller on the child partitions. Again, the efficiency and performance boost it gives on the smaller tables. So this is primarily some of the partitioning, why we have to partition and the need for the partition. So what are the different types of partitions we have today? So we have range partition, list partition, and hash partition. Range partition is a method that basically we divide by range of values or date. An example is monthly partition, quarterly partition, or a yearly partition. A list partition basically is divided by a list of discrete values. A very good example might be partition by state names or a product ID. That is a very good example. Hash partition, the third type, where we don't range and list partition necessarily is not applicable. Where here we use a hash key. Using that hash key, data is distributed among the partitions. So where are these partition tables metadata getting stored? So there are different catalog tables specifically for partitions. Those are PG partition table, PG partition index, and PG inherits. It stores details about the metadata about the partition table, partition indexes, and parent-child relationships. And of course, the usual PG class, PG attribute, PG constraint, and PG indexes are also used, where the column details and constraint details and others related to parent and child tables get stored. So this is more broadly about the metadata tables or catalog tables associated with the partition. So context switching, I'll talk about the setup that I have. Basically, the content that I'm going to show going forward. I have a bunch of screenshots which I have run on a setup. The setup is nothing but a 16-core Azure flexible server running on a PG17 version. I have a schema that uses PG bench schema. Along with that, three tables I have added: sales table, product table, and PG bench test table. That's the table that I've created. The sales table is a partition table on product ID. There are around 5 partitions. It's a list partition table. The PG bench accounts table is a range partition table on AID column of that table. The partitions vary. So the way the setup is made, the PG bench created the database with a scale factor of 500. But I've created 5 or 6 databases. Each database has different partitions, number of partitions on the PG bench account. So database 1 can have 150 partitions. Database 5 can have 10,000 partitions. And I've used all this information to come up with some of the queries and some of the tests or experiments that I've done to show some of the common challenges that we face for the partitioning. So before we switch to anything else, so for the first topic that I want to touch upon is the pruning. What is meant by pruning? Basically, pruning is nothing but removal of irrelevant partitions from the query execution. So I have a table, say I have 10 partitions in it, and my data is sitting in one particular partition, and I don't need those 9 partitions. So the way PG or Optimizer works is that it can remove those 9 partitions which are not needed. That removal of those 9 partitions and getting the data from that one partition is what is called as pruning. So pruning can be of 2 types: static pruning and dynamic pruning. So static pruning is nothing but PG or Optimizer knows at the planning time to which partition it has to go and get the data for that particular query. So it has a where clause on the partition key. So during the planning time itself, the partition that the PG has to go is identified. So in this example that you are seeing, we have a sales table that I spoke of. It is list partition on product ID. And then we have a query. That query is running on product ID is equal to 1. Essentially, we are telling the optimizer at the planning time itself that it has to go and get all the data where the product ID is 1. So the explain output that you see here, explain analyze output, the one that I have marked says sales underscore P1. That is the partition name. So essentially, it has ignored other partitions. This table has 5 or 6 partitions. It has ignored, and it went to that one partition where data is sitting. So this is static pruning. The second type of pruning is dynamic pruning. In dynamic pruning, we have initial pruning, where the pruning happens at the plan initialization time. So a good example of that is prepared statements. So in this example, what I've highlighted, the initial pruning is happening at the time of initialization. So initial plan is initialization. This you see a subplans here. It says subplans removed is equal to 149. That means during that time itself, optimizer was able to identify that one partition where it has to go and get the data and remove those 149 partitions that are not needed. So this is happening at the plan initialization because the and then the data is removed. So if you see in the diagram, I have the subplans have been removed 149, and it went to PG bench accounts 1. That is the partition on which data was sitting, and data has been retrieved. The second type of dynamic pruning is execution pruning. So again, the pruning partition key values are not known till the plan execution. So nested loop giants can use this kind of pruning. So if we see closely at this query, we have a query, we have a join on PG bench history and PG bench accounts. We know PG bench accounts is a partition table, whereas PG bench history is not. So the way it is working, PG bench history works as an outer table, and it tries to retrieve the data from that one partition in which data is sitting in PG bench accounts, and it uses the nested loop. And we have a primary key on AID column, so index scans happen. So and then it identifies the exact partition and retrieves the data. What is very interesting for us to see here is, even though the explain plan shows all the planning nodes, but if we observe closely, in this table we had 5 partitions like A1, A2, A3, A4 and A5, but for A1, A2, A3 and A5 it says never executed. That means that was not considered at all. It's only the A4 that was considered and data has been retrieved. So this is execution pruning, where it is able to identify basically through this nested loops, it is able to identify and get the data, which the planning time, the execution time is pretty fast. Moving on, we will talk about the scenarios where pruning doesn't happen. There are 3 scenarios where pruning doesn't happen. The first one is where queries don't have any where clause, and I'm running a query on a partition table. Second one is queries that use the join condition, like we have seen, but the nested loop person is not possible on those. And the partition key is the partition, we don't know the partition till the plan execution time. The third one is partition key itself is not used, even though we have a where clause, but that is on a separate or a different column on which the partition key which is not a partition key. So we'll go over with each example what that means. So the first one is the scenario where there is no where clause. So I have a query. So we have this sales table, and I don't have a where clause. This sales table has 5 partitions, which has been highlighted. And since there is no where clause, and it starts scanning all the partitions when I execute it. So this is when scenario where pruning is not happening. Second scenario, as I said, we don't use a partition key. Instead, we use some other column. So the sales table that we spoke of is partitioned on product ID, but here we are using sales ID. So because of that, the optimizer, if you see what I've highlighted, starts scanning each and every partition that is present, sales P1, P2 till P5, and looks for that one record, sales ID is equal to 1, and tries to retrieve the data from that from that partition. The next one is a join condition. We have a query on sales and product, Product ID is where we have the partition, we are partitioned on. Product table also has a product ID and a product name. I'm trying to retrieve the data related to product 5. But since we don't know the product ID at the planning time, it starts looking into each and every partition for that data and retrieves the data. So again, no pruning happening. The optimizer looks into all the partitions. Before we context switch, I would like to talk about equivalence class, a concept which is central to high planning time scenario, because this is what makes one of the shortcomings. I would put it in that way. So what is an equivalence class? Basically, in a join condition, like these scenarios where we are seeing, where we have table 1 dot column is equal to table 2 dot column, the equality conditions. These conditions are stored in a equivalence class. So what is the use of this? The optimizer uses these for query optimization, get optimized join operations, and for predicate pushdowns. So this is the usage of it. So optimizer uses it for query optimization. But there are a few limitations of this as of today till Postgres 17. The first limitation is the equivalence member. Basically, I have an equality condition and that is stored in the equivalence class. That member lookup is stored in a flat list and a linear search happens. Let's imagine this equivalent condition in case of a partition table. What happens is that the parent columns along with all the child columns are also stored in this equivalence class. So pretty much the equivalence class will have parent columns, child columns, and the data is stored in the flat list, and then a linear search happens whenever optimizer has to come up with join strategies for optimal query optimization. So this is one drawback. The second drawback is derived clause lookup. That is something whenever a new equivalent equality condition is added, it is derived basically. There's a clause lookup around it. Even that is stored in a flat list, and the way it searches this flat list again is through a linear search. So essentially, what this happens is as the number of partitions increases, the lookups take time, increasing the planning time. So that's where our first partitioning challenge comes, where the planning time is higher when the number of partitions increases. So in the setup that I spoke of, I did a small test. Again, this is no benchmark. This is just a test in the setup to see how the planning time varies. The quadruply increases as the number of partitions increase. I have a query where I've used pgbench test table, and I've used pgbench accounts on the AID column. So at the planning time, till the execution time, we don't know what is the AID range or what are the AID values. So pretty much we are looking into all the partitions here. So we see that the number of partitions as it increases, the execution time remains the same, but the planning time increases. So if we see at the bottom left, the yellow one is the execution time, green one is the planning time. The planning time and the execution time are pretty much same, around 500 partitions when we have 500 partitions on pgbench accounts. As the number of partitions increase, when I have 10,000 partitions on pgbench accounts table, the planning time itself takes 10 seconds, whereas the execution time is in milliseconds. So that is the problem that we have because of equivalence class and the lookups that take time for the optimizer to come up with the appropriate join strategies. So how the explain plan looks like, again, a nested loop is used. We see that never executed is there, so pruning is happening, and it only goes to that one particular I would say partition where data is present. But the planning time, as I've highlighted here, in case of 5,000 5,000 partitions, the planning time is 2 seconds, whereas the execution time is only 30 milliseconds. So this is one challenge we face, over partitioning, leading to more higher planning time. Now moving to the second issue that we get into, that is lock manager contention. So before we talk about lock manager contention, I want to briefly touch upon fast path locks. What are fast path locks in Postgres? These are lightweight locks, basically 3 types of locking. Access share, row share, and row exclusive locks fall into this fast path locks. And one of the drawbacks as of today, I can say that one of the things that how it works is every backend can have only 16 fast path locks. So what happens if there is a scenario where we need more locks? So this might happen in case of partition tables. So we have a partition table where we don't use a partition key scenario, or where there is no pruning happening, then there is a high likelihood that parent table would be locked. Along with that, every child table would be locked. And then if it's a DML, that means we have an update or a delete that has no, again, partition key added, then it is going to lock even the indexes across all the partitions. So that's where the lock manager contention starts to happen. So lock manager contention is nothing but locking is needed for every parent table, along with every child table and the indexes. And this lock manager contention basically creates a waiting, queuing, and blocking, resulting in increased application time, latencies, and we will see a lot of LW lock manager wait events. So I've done 2 tests for lock manager to show how the lock manager contention behave. One, in the first test, I increased the number of clients. That means we are increasing the concurrency. Higher the concurrency, the lesser the TPS. That's how it happens. And then in the second scenario, we change the number of partitions, but we keep the number of clients, and then we observe what happens. So the first scenario, again, I have taken a query where partition pruning is not happening. We don't use a partition key query, and we use a simple pgbench test and run against this query, and I observed the TPS, how the TPS was behaving. And for 25 clients, for example, we had around 220 to 225 milliseconds if I have 2 indexes on the table. And as I increase the number of clients, the TPS reduced like 150 in the test. Similarly, if I had reduced the number of indexes to 2, so we were at 320 to begin with, but it again came down to around 280 as the number of clients increased to 200. Every time we will see in the test, lock manager LW lock, the wait event that I have shown here in this slide was seen, and the contention was pretty high, leading to lower TPS, and it only worsened as the number of as the concurrency increased, and it also consumed additional server resources like CPU. One more test that was done was again the same query, same setup. Two indexes, one index on AID, second index on BID, then 4 indexes. But this time, instead of changing the client was set at 100. The number of partitions increased. So I started with 500 partitions till 2,500 partitions. The TPS, as can be seen, the green one is with 4 indexes, yellow one is with 2 indexes. We started around 2,000 to 2,500 when we had around 150 partitions, but that pretty much reduced, the TPS pretty much reduced to 100 to 150 as the number of partitions increased to 2,500. So again, the lock manager contention, the TPS, there's a high pressure, so TPS reduces. We will also see additional system resources being used like CPU in this scenario. So what are the solutions we have today? So it's always very important that we do the database design properly. We identify the columns which can be made as partition keys according to the not only database needs but even the application needs, which is very important. and most of the queries have to use partition pruning. Otherwise, we are going to get into a situation where lock manager contention might happen if it in a very high concurrent environment. So partition pruning has to happen even if there are updates or deletes or any deletes. It is better to put a where clause with the exact partition on which it has to do. If that doesn't happen, then in a very high concurrent environment, we are bound to see lock manager contention. The third one that we could think of is having reducing the number of partitions. As we have seen, as the number of partitions increase, there is a high risk that the planning time might increase. It quadruples, as we have seen. So many a time, what I have observed is that we don't need that many partitions. Maybe we have 10 years of data, but for example, we have 10 years of data in a table, and we do a daily partition, which will create something like 365 into 3, which will create like thousands of partitions. We don't have to go that route. Maybe we don't need 10 years of data. We need only 1 year of data, where we should have a proper archival strategy. Remove the data that is not needed in the actual table, keep the data that is needed, then reduce the number of partitions. Maybe doing a daily partition might not be a good idea. Do a quarterly partition or monthly partition. That would reduce the number of partitions in the table, which would ultimately help in reducing the challenge around the planning times that we have. Then the fourth one I would say is unused indexes, if there are any. As we have seen in a high concurrent environment, if the queries don't have a partition pruning happening, then the lock each index will also create an additional lock. So essentially reducing the indexes, removing the unused indexes, we are saving ourselves from lock manager contentions, reducing some of those. So the final one is like moving to non-partition tables. So why is this here, you might ask. The reason for that is there might be situations where application simply it's not possible from the application to partition a table according to the application needs. Then better we don't partition the table for the sake of partitioning. It's better in those scenarios to have a proper partition archival strategy to remove the data that is not needed. Have proper auto vacuum settings on the table, maybe at the table level, and tune it properly so that the bloat ratio on the table is controlled and it is efficient. So this is another way of looking at things, where from the application perspective, it is not possible. It's not possible to have partition pruning. Then this is one option that can be considered. Moving on, so I would like to talk about PG18. What new is coming in PG18. So we have 4 commits that I've gone through that I would like to highlight related to partitioning. The first one is speed up equivalence member lookup in Planner. So we talked about 2 things in equivalence class. One is lookup of equivalence member is slow because it's in some sort of a list. It's basically we do a linear search, and that slows it down. The second one is derived clause lookup. Derived clause lookup, again, we have seen that it's a flat list and the lookup can be slower. So these 2 commits that I've gone through, the first one, equivalence member. So now these equivalence members are basically added to an array list, and they are also indexed on the rel ID. So the lookups would be faster. Similarly, for derived clause lookup, basically in scenarios where we have this derived clause lookup happening on flat list now, and linear search happens, there is a now hash table available for the lookups to happen faster. Definitely these 2 would help in making the planning time better. These are 2 very good commits that have gone. I'll come to 4th and then switch to 3rd. The 4th one is like we briefly talked about fast path locks, where every backend has 16 slots allocated. Going forward from PG18 onwards, max locks per transaction, that's a parameter that controls how many fast path lock slots that can be added at the server level. So that's one good addition that's going on. So that would reduce the contention on LW lock manager contentions. Then the final one I would like to touch upon is like don't lock partitions pruned by initial pruning. So what does that mean? So in scenarios where query plans are cached, especially in prepared statements, today what happens is that if it's on a partition table, every partition, meaning every child table and every along with the parent table, is there is a lock on it. So going forward from PG18, what this commit does is basically it doesn't lock all the partitions till the initial pruning is completed. So after that, we know that which particular partition has to be looked into. Only that particular partition is basically locked. So these four are very good additions, which would help in reducing some of the challenges we are seeing in up till PG17, and very good additions to PG18. That's it about my talk about common challenges in partitioning. Thank you very much. You can reach me on LinkedIn, and thank you all.
Thanks, Sarat.
Thanks a lot. I love partitioning.
You can see you're very active in the chat asking questions.
It's like I'm spending like half my time on partitioning and partitioning questions, partitioning strategies. So I really want to know these things.
Yeah, I knew about static partition elimination and the execution time, dynamic partition elimination, but I didn't know about the first type of dynamic partition elimination that happens to prepared statements that he mentions. I'm going to have to look at that because I thought there were only two types of partition pruning. I did not realize there was sort of a third subcategory.
Yeah, I named them kind of the same for me. It's like, all right, pruning and execution time, I skip it. It's just showing differently in the planner, but now I know why.
Yeah.
I do think if you whisper like log manager in my ear when I'm sleeping, I'm immediately awake.
I'll have to tell your family about that one so they have it in their back pocket.
Yeah, they're not going to watch this, and no one is going to tell them, I'm sure.
Who knows? Maybe in 5 years, your 11-year-old will be a Postgres developer.
Daddy, log manager.
Well, please give your talk feedback if you enjoyed it as much as Dirk did, or if you have constructive criticism for Sarat. If you go to the Posette survey talks LS3 and then just like grep for partition, I think it might be the only one today about partitioning or performance, 2 Ps, and then give Sarat some feedback and get some stocks.
Yes. All right. Then the next one. I'm really afraid of this one because I've been practicing Neeta Goels, and I know I'm mispronouncing her last name. And I've been practicing yesterday the entire day, but I can't get it right.
It's one of the hardest host duties, is making sure to get the names right.
Yeah, I've been practicing, and I know I'm off. I'm really sorry. My mouth can't get in the right shape to pronounce it. I'm sorry. And she's doing the talk together with Sandeep, Rajeev, and it's a nice talk because they are the CEO and the sales director of, I forgot the company name.
Newt
Global.
Yeah.
Thank you. And what they are doing is they're doing a lot of migrations to Postgres. And when you're working with Postgres, it's like you know everything about the product and the tools and the tooling around it. But when you are migrating other stuff to Postgres, you learn about all the weird things you do or do not have. So I'm Dutch, and I was thinking like Dutch are very ordinary people. But now I have a lot of people who are not Dutch as my colleagues, and I learn about all the weird habits we have as Dutchies. And I feel the same when I'm watching this talk. You learn all the weird things we do within Postgres. So I think you are really going to enjoy this talk.
Hi everyone, I'm Neeta Goel, CEO at Newt Global.
And hi everyone, I'm Sandeep Rajeev. I'm the sales director at Newt Global.
Today, we will be talking about migration considerations to go from Oracle to Postgres. If you are considering migration from Oracle to Postgres, this talk is for you. My team has been focused on building platform for assessing the complexity of databases and underlying schema, making it compatible to Postgres through auto-remediation. In today's session, we'll cover systematic approach with some examples to get to Postgres faster, smarter, better.
Thanks, Neeta. To introduce myself, I have over a decade of experience in technology sales and specialize in helping organizations successfully navigate complex database migrations, particularly from Oracle to Postgres. I work closely with stakeholders to align migration strategies with business goals, ensuring that transitions not only reduce costs, but also drive long-term value. Today, we will be discussing important considerations when migrating from Oracle to Postgres and the tools and framework to accelerate and streamline this transformation journey. When modernizing from Oracle to Postgres, it's critical to address several key considerations right at the outset. Every layer of the technology stack must be evaluated, from database schemas and applications interfacing with the database to upstream and downstream interfaces, batch jobs, shell scripts, infrastructure, and testing. In the following sections, we will explore each of these areas in detail. Oracle is a robust database and offers a large number of features. Many of these features are not yet supported in Postgres, leading to the complexity in migration while keeping the same functionality and performance. One of the most complex and labor-intensive steps in any Oracle to Postgres migration is schema conversion and remediation. And a big question we often hear is, how do I convert my PL/SQL? Stored procedures, functions, and triggers often contain embedded business logic that needs to be translated to Postgres compliant constructs. We will be discussing some examples to give you an idea of what needs to be addressed for schema to work in Postgres correctly.
In Oracle, simple addition works even if variable is null. The result becomes null, and that's accepted. However, in Postgres, if you try to assign null plus 1 to a numeric variable, it can cause error. So we wrap it with coalesce to safely treat null as 0. This ensures consistent behavior and avoids null issues at runtime. Similarly, in handling null versus a string, empty string, in Oracle, empty strings are treated the same as null. So checking if PV doc code is not null automatically excludes both. But in PostgreSQL, empty strings and null are distinct. So to match Oracle's behavior, we need to use nullif to convert empty string to null. This ensures the condition will work if null or empty string exists, just like in Oracle. It's a small but important adjustment to ensure functionality of the code works as intended. Continuing, we need to consider date operations. There are many variations: date without timestamp, with timestamp, without time zone, etc. Here is an example of trunc operator and typecasting required to deal with different variations of date format. In Oracle, trunc works for both date and numeric values and handles it implicitly. In PostgreSQL, date trunc and trunc have distinct purpose, and they are used for date and numeric values respectively. Additionally, if variable value date is a date without time component, typecasting is explicitly required. Moving on, there are special features in Oracle. which don't have a direct equivalent in Postgres. Identifying such features used in a schema being converted is a prerequisite. It's a long list of features. Some commonly occurring cases are package global variables, associative arrays, dynamic sequels, for all, goto, etc. Each of these objects require a specific treatment to ensure equivalent functionality in Postgres. Here is one illustration for a complex schema with about 200,000 lines of PL/SQL code. Identifying every occurrence of these special features is possible only by automating scanning and remediation of PL/SQL code. Many tools comment some features and many features are ignored and not identified in compilation, resulting in runtime errors. Take an example of package global variable that persists throughout a session. In one single schema, we had over 700 of these variables. PGV can be handled using GTT approach, but requires identifying each incident of PGV used inside the PL/SQL and specifically using set every time. Another example is goto, which is a programming construct and identifiable only if a line-by-line code scan is done. If goto is commented, PostgreSQL objects will compile and will result into unintended program runtime errors. Dynamic SQL is another example. There is no compilation error if it is not converted, and identifying dynamic queries is critical for ensuring code compatibility with PostgreSQL. PostgreSQL handles dynamic SQL string directly using concatenation, and there are many nuances while making the changes in the syntax. Replacing execute immediate with execute, changing position variables, and introducing concatenation, etc. As you saw in the previous example, having to find over 1,600 execute statements manually would be almost impossible and will introduce significant human error if remediated manually. Next important consideration is differences in data types in Oracle versus PostgreSQL and how implicitly Oracle handles these data types and values contained within. In Oracle, the database engine is more flexible with implicit data type conversions. If you're using a string or integer in a numeric expression, Oracle often automatically converts it to the appropriate type. However, in Postgres, the type system is stricter and more explicit and requires data type to be specific. Differences are subtle and mostly not identifiable in compilation. These issues mostly manifest as runtime errors or inconsistent results. Here is an example of a schema with number of table columns. If these columns are referred to in PL/SQL, typecasting is required in thousands of places to ensure consistent treatment. In another example here, EPS_QS can be a text or varchar column in Oracle, and as long as it contains numeric value, Oracle interprets it implicitly and expression is valid. However, same will fail in PostgreSQL unless EPB_QS is typecasted explicitly as numeric. The list continues. Date handling is also very sensitive in PostgreSQL and requires explicit instruction for operation and syntax. Oracle PL/SQL has implicit handling of dates in arithmetic operations. When you add a number to a date or timestamp data type, Oracle implicitly treats that number as a number of days. So term date plus 1 directly adds 1 day to the term date. However, PostgreSQL is more explicit about date and time arithmetic operations. Adding an integer to a date or timestamp column directly is not implicitly treated as dates. Instead, you need to explicitly specify the interval you want to add using interval keyword. Continuing in Oracle, toDate supports both date and time implicitly. The date variable here is having timestamp without time zone. In Postgres, toDate only handles dates. For date with time, conversion to toTimestamp is needed. Default return value from toTimestamp is with time zone. Firstly, to understand variable data type requires complex logic for lineage. In this case, first finding that a date is having timestamp without time zone is needed, to then automatically typecasting it to match date variable a date. Automating these conversions helps eliminate manual guesswork, reduce risk, and speed up what is traditionally the most challenging part of migration.
Next, we will look at things to consider for understanding the Oracle database performance metrics to determine the right target configuration on Postgres. We need to understand key workload characteristics like CPU usage, throughput, IOPS, and storage patterns. Additionally, data distribution plays a major role. This includes analyzing partitions and subpartition counts, their sizes and types, whether it's range, list, or hash. Doing all of this manually by reviewing AWR trends, server parameters, and schema details is very time-consuming. Automating this step helps accelerate the process and ensures we choose the right architecture and sizing in PostgreSQL, reducing both risk and rework. Now we will discuss the various aspects we need to consider for a successful data migration. The data migration journey begins with a pre-migration phase, where the strategy is defined, validation criteria established, and the environment is prepared, including a review and update of key server parameters. In the planning phase, the source system is analyzed in detail to determine the appropriate migration treatment for each object, whether it's a full load, incremental load, or transformation heavy. Tables are then grouped and sequenced based on dependencies to ensure orderly execution and minimal downtime. During migration execution, the process includes automated setup of the target PostgreSQL environment and continuous monitoring of the performance and errors. The ability to rerun failed or partial migrations incrementally, avoiding full restarts, significantly reduces the time needed to do the full migration. Finally, post-migration validation ensures both physical and logical accuracy, confirming data consistency, format integrity, and successful conversion from Oracle to Postgres. Now let's talk about a critical and sometimes overlooked part of the database migration, the application side. Because no one migrates a database in isolation. The applications built around the database have to come along for the ride. We will walk you through some of these real-world cases using code snippets from both Oracle and Postgres to highlight the key differences and demonstrate the necessary changes.
One of the biggest challenges in embedded SQL remediation applications, especially legacy ones, often have hard-coded Oracle SQL, both static and dynamic. These queries are written with Oracle-specific syntax, and data types that PostgreSQL simply doesn't recognize. We need to systematically identify and update these, and that alone can be a massive effort. In this example, scanning the source code led to discovery of session.create SQL query, where Oracle-specific pattern, sysdate, and the use of from dwell is flagged. Using rule-based logic, these constructs are auto-converted to be PostgreSQL compliant, replacing sysdate with statement underscore timestamp and removing from dwell, which isn't needed in PostgreSQL. Dynamic SQL often presents even a bigger challenge than static queries because it is built at runtime using string concatenation. In this case, application code needs to be passed to recognize dynamic SQL.append statements and detect Oracle-specific syntax. In this case, trunc sysdate embedded within the string literal. Using role-based engine, these constructs are auto-converted to PostgreSQL equivalent, replacing trunc sysdate with date trunc, day statement timestamp. Then there are data type changes that needs consideration. PostgreSQL may require different representations. For example, Oracle's number might need to be mapped to numeric, integer, or even big int, depending on the context of the variable. These changes ripple through the application code, especially in type languages such as Java or .NET, where strict type handling can lead to runtime errors if not handled properly. Changes in application corresponds to changes in the data types in PostgreSQL converted schema. To ensure type safety, auto-conversion of code using rules, replacing getString with getInt for those specific fields. This avoids any potential runtime mismatch errors, which are common when database type changes, but application logic is left behind. These data type changes are extensive and are one of the major causes of conversion projects failing, as the changes are found during functional testing. Procedure and functions is another consideration used within application. These needs to be reviewed and modified. Applications that rely on calling Oracle stored procedures, especially those using PL/SQL specific construct, such as out parameters, exceptions, often need to be restructured. Postgres procedural language, PSQL, has different conversions and functions behave differently in terms of transaction scope and error handling. In the example here, Oracle uses call word for all cases, be it stored procedure, function, packages. However, at the time of transformation, packages are converted to stored procedures or functions. In this example, we have replaced select keyword for Postgres compatibility for calling a function. We need to also consider input-output parameters used within procedures and functions. Oracle variables within procedure functions needs to be replaced with equivalent PostgreSQL Java methods in line with data type changes on DB side. And let's not forget interfaces, shell scripts, jobs. The list goes on. Embedded SQL is everywhere. There are batch of shell scripts and interfaces which usually have Oracle-specific syntax. Every interface needs to be assessed for any Oracle-specific syntax, and remediation is needed. Here, SQL Plus is an Oracle construct to execute a SQL command from within a shell script. There are many aspects to take care to make this code snippet compatible to PGSQL, starting with replacing SQL plus keyword with pSQL, then handling attributes for functionality to avoid printing header and footer in result set. Alter session needs to be replaced with search path. In this example, alias is used in set statement, which is not supported in pSQL and needs to be removed. As you can see, there are many syntactical changes required. In a complex batch-heavy database, there will be hundreds of such SQL plus statements needing remediation. As you can see, there are changes in syntax, data types, unsupported features everywhere, from schema, batch job, interfaces, application, you name it. The only way to succeed is by automating all the things.
And this is where DMAP comes in. DMAP is an AI integrated platform designed to accelerate Oracle modernization to Postgres. It streamlines the entire migration process from both the database and application perspectives. On the database side, it starts with a comprehensive discovery and assessment phase, analyzing schema complexity and database performance to recommend the ideal PostgreSQL configuration. It can generate a business case with TCO comparisons to help clearly see the cost benefits of migration. Once the assessment is done, DMAP shifts to automated migration, handling everything from schema conversion, including complex objects like stored procedures and functions, to data migration and validation. This significantly reduces manual effort and migration risks. On the application side, DMAP scans the codebase to identify embedded SQL, both static and dynamic, and calculates the conversion effort needed to make it PostgreSQL compliant. It even automates handling of data type changes that might affect application logic, making the transition smoother and more reliable. However, automation alone will be like chaos with no plan. To succeed in migration, you need a framework that brings structure, strategy, and the full power of automation together. This is where the CMC framework comes in. It surrounds DMAP's AI-driven automation with everything needed for a successful migration. In addition to the automation, the framework supports infrastructure setup and robust testing across environments to catch issues early. Finally, it enables a planned, low-risk production cutover, ensuring a smooth go-live. This would help deliver the migrations 4 times faster. A typical medium-sized database migration that would have taken 12 months can now be delivered in 12 weeks. Now, you have a full understanding of the configurations, tooling, and framework to undertake your journey to cloud-native PostgreSQL on Azure. Are you ready to onboard? Thank you.
Thank you so much, Neeta and Rajeev. It's a really nice topic.
It is a very popular one. It's one of the things we get asked about the most at conferences and when people come to the booth. Definitely a hot topic.
Yeah, I always feel a bit bad and proud when I get these questions. It's like proud to be on the receiving side of the data because data is really important to companies. And they say like, oh, we are on a competitor's platform and want to come to you. It feels good, but it always goes both ways, right? There are also people on the other side. So.
Yeah, well, I like that. The idea of being on the receiving end of their data, feeling good. I think that's a cool way of thinking about it. Like they trust us to keep their data safe.
Yeah, it is a compliment, and it means we're doing the right things. So.
Yeah. Totally. So give your feedback in the survey for Livestream 3 and just search for migration, I think,
Yes.
and give them your talk feedback.
Yes, it's a lot of work building these talks, and it's good if you can learn from every talk you give. So if you get more feedback, you can learn more and your next talk will be better. So as a speaker, we really need your feedback. So please, please go to the URL, leave your feedback. And if you want to be efficient, you can just go there, fill it in, and then immediately go to the next talk. So it's really easy to do.
I'll tell you a secret. Dirk and I are competing with the other live stream hosts to see who can get the most survey responses. So help us in our journey to beat the other hosts.
Yeah, I was not sure whether I should mention this or not. So when people tell me like it's not a competition, but it's like
no, at the booth I always try to get like more badge scans if I can. It's a little bit of a competition.
Yeah, I can be so competitive. My wife hates me for it. It's like, why, if we ever cycle somewhere up, why do you always have to be with your bike like just in front of mine so you know you're up first? It's like, I know I should not do this, but
oh man, that's such
man.
a Dutch story. I feel like bikes.
Yeah, well, we cycle everywhere, so yeah, it is a Dutch story, but it can be anything. Oh, every talk survey counts as one. So the more surveys per talk we get, the more we help the speakers, and the more you help us with our internal, not existing competition.
We should have just picked the live stream that had more talks, and then we could have won.
Well,
I think they all have the same number, actually. So
for the 2 talks in total, that's 21 for 2 streams, so they can't be equal on all streams.
Okay, good. Good, coming in with the math.
Yeah, well, that's at least one thing I can challenge my daughters with, because they beat me at languages even though they're only 8 and 11. So, all right, next talk is from Abe, and he never pronounces his last name, which I really don't know how to handle his last name. And as he never says it, I don't want to burn his name on my tongue. And I want to tell you something about this speaker. I think whatever he speaks about, I'm happy to watch it, because when I see him speak and when I see him already giving the introduction, he's so vibrant and so energetic and so passionate about what he talks about.
He's super fun to watch.
He's definitely fun to watch. So
really engaging.
He's really engaging. And this time he's talking about RAG, which is not really my cup of tea, but still, I can watch this talk every day, I think.
I think RAG is probably everyone else's cup of tea. So this should be, it's a hot topic and a really engaging speaker. So I guess if Dirk loved it, then you're going to love it.
Yeah. As a speaker, I would love to make these drawings as he's making them and how he's telling about it. It's never going to be my style, but I love watching it.
Yeah.
So don't have to waiting anymore. Let's go.
Hey everyone, my name is Abe, and today I'm going to be talking about building intelligent applications with graph-based RAG on Postgres. If you're someone who's already built a RAG application or want to learn more about making your RAG apps more accurate, this is a great talk for you. So let's get started. As I told you all already, I'm Abe. I'm a product manager on the Postgres AI team working at Microsoft, and I have previous experience working in Azure AI, as well as Databricks. So you could say I've been in the AI trenches for quite a while. And obviously I had to hop on the trend and made a Studio Ghibli version of myself as well. If you want to know more about me, all my socials are on the side, and go ahead and follow me. So let's go into the presentation. So question I have for y'all is, has ChatGPT or Copilot ever given you an insufficient answer? That happened for me just today. So I asked ChatGPT, I said, hey, what talk is Abe Omorogbe giving at Posette? And it answers super confidently. There's no public information about me giving a talk when I'm here in front of you giving a talk. And it's not just me that's running into these kind of issues or hallucinations with ChatGPT. These are articles I've picked up all over the internet over the past few months. And the one I like the most is basically saying Gen AI accuracy problems aren't going away anytime soon, researchers say. What I want to address today is help us solve that exact problem. How do we improve the accuracy of our Gen AI applications? Today, I'm going to walk you through building an AI legal app directly on Postgres. We're going to start talking about why Postgres. Then we're going to talk about the legal data set I used. Then we'll talk about the evolution of simple search all the way to vector search. Then we'll talk about basic RAG. Most of the folks might already know about that, but let's level set. And then we'll talk about where RAG breaks and how we can solve those problems. And lastly, we'll talk about advanced RAG architectures. So let's get going. First, why Postgres? The main reason for Postgres, I'm not biased here, trust me. I know I'm the Postgres team, but a big reason for it is Postgres is actually the #1 database for professional developers. So the real reason it's super popular right now, especially in the Gen AI space, is because Postgres is super flexible. It supports a lot of different extensions that help with building Gen AI applications. Things like AI model extensions. So if you're using Azure, you can easily use Azure AI extension. You can work with vectors using PG vectors. You can work with unstructured data using JSON-B format. You can also do graph directly in your Postgres database, which I'll show today, all inside Postgres. And on top of that, you get a really vibrant OSS community to lean on and get feedback from, and also get some answers from. So it's a really good place to start building a Gen AI app, especially as the market is moving super quickly now. And you have a backend database that can also evolve with how the market is moving. So we dive right into building this legal Copilot app. So imagine you're a legal researcher or you're a lawyer in the state of Washington, and you want to help your clients answer simple questions about, tenant rights or property disputes. If a client asks you, hey, water is leaking from the apartment above, how do I solve this? What is the precedence to kind of either sue my landlord or get this fixed? This app will be designed to help solve that. So let's start. So first, we're going to talk about the data set we used for this. The data set we used the US case law data set, and we took a subset of just Washington State. In this data set, we had around 100,000 cases, around 7 reporters, and up to 500,000 pages scanned and put in JSON format. So how it worked is we took the JSON blob of this data, we ported it over with JSON-B format to Postgres, and we created a structured table of the names of the cases as well as the opinions. Right. So now we can easily search this data and do more things. So now let's go through how we search this data and some typical methods most people use. So how do we start using this data and searching this data? The first thing, most folks might just use I-like. So the problem with I-like is, let me just show you right here, is if you're using I-like, you can see you kind of do a regular expression here to figure out, water leaking from the apartment above, but inevitably you have 0 results because there is no opinion from these cases that have those exact text. So this doesn't quite cut it. The second thing you may do is you might say, hey, you know what, let me try use full text search to find this. But you might run into a very, very similar issue where, you do the full text search. I created a text search column. I did my full text search. And again, only 1 result, not much better than I-like. There must be a way we can use to kind of solve this issue. Like, how do we solve this and what can we do to help kind of find data related to water leaking from the apartment above or something your client asked? This is where we introduce vectors, right? So what exactly vectors are is, imagine a vector is just, what I say is like a word represented as a number in the graph space. So as you can see in the picture, imagine the word dog and then the word cat. Both of them can be represented as numbers in the graph. And if I did a similarity search, with the similarity search, I can use an algorithm to find how close dog is to cat and then find, hey, dog is actually related to cat because they're around the same space. This same principle is used throughout vector searching, and we can use this to kind of solve this problem and get more relevant answers. The way it works is we take the word dog or whatever word or whatever sentence and we pass it through a model. So there are many deep learning models out there. One popular one is Word2Vec, but there's also ones from OpenAI, Cohere, and a bunch of other folks that support different input formats as well as different dimensions. So you can take any word or sentence and convert them to vectors. If you want to learn more about vectors and how things appear in different space, I would super recommend going to it's called projector.tensorflow.org. You can go ahead and you can see exactly, where words appear related to each other. So you can see in this chart, I can see here dog, it's kind of related to rat, it's kind of related to all these other animals. So it's a good way to help you kind of visualize what's going on with your vectors. When we go to Postgres specifically, what we can do is we can take all these words and all these opinions, we can convert them to vectors and store them directly in Postgres. And the way we can do this is with two main extensions. The first one being pgvector. So what we'll do is we'll use pgvector, as you can see here, is we're going to use pgvector to define the vector type. So this is a vector type that has 1536 dimensions. So the opinions are saved in those dimensions. And then as we store each opinion, we use Azure AI to create the embeddings, so the vectors, to store in the table. So this is a pretty seamless way to kind of set up your vector search. And you can use another replacement if you have, or if you're not using Azure, there are a bunch of other extensions out there that can do the same AI thing. So basically how it'll work is if I do that same search that I did before, so I did the same thing with vector search, now I'm getting a lot of cases that are related exactly to what I'm talking about when it comes to water leaking from the apartment above. So we're getting a lot better accuracy now. We're getting a lot more results. So it's pretty cool. So now we're going to go on to add in this vector search into a basic application. So most folks already know this. You can use vector search with RAG. And before I go more into it, let me just level set on what exactly RAG is. Simply put, RAG is retrieval augmented generation. And all it is a technique that takes your data. So for this case, my legal data, it chops it up into little chunks. It puts it as context for our prompt, and then we send the prompt to the LLM to give an answer. So this is where we can use vector search to get the right context, pass it to LLM, and hopefully get more accurate answers. The only problem that we see with RAG today are two main things. The first problem being scale. To efficiently scale these vectors to kind of store them in roughly, when you have like 1 million vectors in Postgres, it's hard to keep scaling these and also getting good performance search results. So you probably need something else to either index or do more. And for accuracy, it's another big problem. As this data scales and you have more data in your data set, getting the most accurate response becomes harder. So how do we solve that first problem? Scale. So we can solve scale with vector indexing. There are two big vector indexes on the market today. One, IVF flat, and the other, HNSW. IVF flat is a clustering algorithm that will cluster all your vectors into different clusters. So when you do search, it's easier to find them in specific cluster. The only downside to IVF flat is that every time you add new data, you need to reindex because you need to put the data in the specific cluster. So kind of a disadvantage there. And the second one is HNSW. This is a lot more efficient. It creates a multi-layer graph that has, if you construct that graph, you'll be able to find things at different levels of the graph. So when you do a search, if something is on the top level, you can hopefully get your results a lot faster. But these two things, they have their pros and cons. Generally speaking, IVF flat is usually best when it comes to large data sets, but super low dimensionality. And HNSW is generally good for when you have smaller data sets and high dimensionality. Like I said, it has different layers that are created, so smaller data sets are probably better here. So how do we solve it when we have both a large data set and high dimensionality, when we scale up to millions and we're using maybe like OpenAI for embedding? That's where we introduce the DiskNN vector index algorithm. Basically what this is DiskNN is a highly performant vector index algorithm developed here at Microsoft. It's basically years of Microsoft research and has been used by folks like Bing, Office, already using DiskNN to optimize their searches for those applications. And we brought that power right into Postgres. the way it works is it takes the vectors, it stores them as compressed vectors in RAM, so you can have super quick search speeds, and then it stores the full vectors in your disk. So when you do the first search, you can go ahead and retrieve you retrieve the vectors that you found from disk, and you get more accurate answers. What this basically means is, since your graph is stored as a compressed data set inside memory, it has a much smaller memory footprint. So that results in a lot of cost savings. Let me show you. So basically, if you're using disk ANN versus HNSW, you can see here, I have two tables, identical tables, both around 6 gigs. And then when I did my indexing, you can see right here that HNSW index is what, 150 MB versus 3.5 gigs roughly. It's roughly 25 times smaller than if you were to index with HNSW. This would result over time in better search speeds at a smaller compute size. So because you can store the graph in a smaller compute or smaller resources, you should be able to do more with this index. And the great part about this is this KNN is as easy to use as other index algorithms. All you have to do is index with disk KNN, and that's it. So now we move on to the second problem. The second problem is around accuracy. So how do we improve accuracy as we scale up? And how do we improve it? We're using some advanced RAG architectures. So the last step of this, we've gone through all things. Now we want to go through these advanced RAG architectures and how exactly we can, improve your vector searches. So first thing first, there are two main ways that you can improve accuracy when it comes to GenAI applications. One, you can use basic RAG. So let's think about things like chunking strategies, think about, using bigger embeddings. Maybe you want to do some query rewriting, maybe do some hybrid search, so on and so forth. And there are also advanced RAG solutions. So you can do things like semantic re-ranking. Basically how that works is, first pass, you do a vector search, then you re-rank based on the semantic meaning of the words you return, and hopefully you get better accuracy. Secondly, you can do hierarchical summarization. Basically, all it is it looks at all your information, it clusters it, and creates a tree structure to make search faster and easier, and also more accurate. You can use graph RAG. Basically, what graph RAG does, it uses the relationship with your entities to give you better answers, or just use an agentic system. And the way agentic system works is they rely heavily on different tools to supply the right context to give your thing the right answer. We're going to focus today mainly on graph RAG and how we can use graph RAG to improve accuracy of these apps. So super high level, what is graph RAG? Graph RAG started at Microsoft check the project graph RAG, it's there. So basically all it is it takes all your data, does some graph extraction, does some entity summarization on your data, and then when a user asks questions, it creates a graph query and it retrieves the right information. So that's how it is. And today I'm going to walk you through how you can use graph RAG for this legal case data. So for the legal case data, what we did is for the graph extraction, we used a pre-extracted relationship in the graph. So basically how cases relate to one another. And then entity summarization step, we didn't need to because we're just using the relationships between the cases. And then lastly, we used Apache AGE for very specialized graph queries. So if you don't know about Apache AGE, you should definitely check it out. It supports graph write in Postgres. It supports cipher searches, hybrid searches, and many different things. And just to quickly show you what that graph looks like, you can see here, if you had a bunch of different cases, for example, case 5 references case 3, which references case 4, so on and so forth. So if I were to search here, I can find the relationships and see which one is most relevant. So how do we use this advanced graph RAG technique to kind of improve search? So I'm going to go here and kind of show you what I mean. So basically, the question someone may ask is a question like this. Like, hey, look, there's water leaking from the apartment above, and I want to know the prominent cases to kind of support this argument. So the only way we can do it today easily is with graph. So what we can do is we can look at the relationship of all the cases, and you can see here what I'm doing is if a case is related to another case, just count the cases. So what I want to do is count all the cases that are related and return the ones that have the most relations. So how I use that today, especially in Postgres or a graph query, what I can do is at the top, what I just showed you, you can see here I have a graph query, and basically what the graph query is doing is what I said. So I'm checking for any references to a node, and the node being the cases, count all those nodes. And then at the bottom part here, I'm doing something called RRF. Basically what that's doing is it's reciprocal rank fusion. It's combining the results from GraphRag as well as vector search, combine them to give me a joint answer. And then on the bottom, you can see it's returning back the best rankings on both. So you can see this case at the top is the best because it's one of the highest with vector search and also one of the highest with GraphRag. So it can go ahead and say, hey, this is a better solution for you. So what I want to do is I want to show you what this looks like in practice. So I'm going to go ahead to a quick demo of this. So right here, I already have an application. I already have a vector search application, and I run this vector search application. And I asked my legal copilot, hey, water leaking from the apartment above. What are some prominent, some prominent use cases? So it says some prominent use cases, and then it pulls out some reports here. And I have this handy tool here. It shows me if it retrieved the right information to answer this. So you can see here, what you're looking at is you can see the recall is around 40%. Because what's happening is you can see the gold balls are what it should have retrieved, and the green is what it actually retrieved. Vector search was only able to retrieve things at 40% accuracy to answer this question because it didn't understand what prominence meant. If I switch this application over here to GraphRag, I can try and see, let me just go over here. I can see the exact same search done with GraphRag. We can check it out here. So we can see that this exact same search, when I used GraphRag, there are a lot more relations. So you can see all the bigger balls right here have been selected with GraphRag because what happened is after it did the vector search, it did a re-ranking based on whichever ones had the more relations. So because it's more prominent, those came up first. So this is how you can kind of use GraphRag or graph relation to kind of improve some of your search results. So hopefully that makes sense, and it kind of shows you how. You can kind of see it here. I'm gonna skip that. And yeah, so basically, if you want to build this legal copilot yourself on your own time with Postgres and with all the things I showed, go ahead, check out our solution accelerator for Postgres. It has this legal copilot app plus the UI. You can use the US case law dataset. It's all in the repo. You can test that out. And you can also read the blog about it and learn more about how to use GraphRag to build your applications. And lastly, I'm going to kind of leave you guys with one thing. Again, I'm not biased here, but I really do think that Azure Database for Postgres is a super useful tool that gives you all the same functionality you will get in Postgres, as well as any enterprise applications. Everything I mentioned today can be done in open source. But if you're working in enterprise and have some enterprise requirements like scaling up or high availability, it's super easy to just drop right into Azure Postgres and do the same things. And then lastly, I'm going to leave you with a bunch of resources that you can use, such as you can go ahead and see how to implement agents with Postgres. You can also go ahead and see other solution accelerators we have, like semantic re-ranking, like I talked about, the advanced architectures I talked about, as well as other accelerators that can help you speed things up. And to keep up with the team and learn a little bit more, please check out our blog. And yeah, you can learn more about this. So thank you guys so much for listening. I'm so happy you guys took the time to listen to this whole talk that I had. Hopefully you can explore and you can see that building this legal copilot, that's something that's super or more accurate with your data, is possible with GraphRag, Postgres, and a bunch of other architectures that I described. So hopefully we see you guys build it, and make sure you follow me on GitHub or X. Thank you.
Okay, that was super cool. As someone who works on Postgres internals, I don't really, make a lot of apps. I think and I've been to a fair number of conferences, not just Postgres conferences, where people have talked about AI and use this tool or that tool. And I think that's the first talk I've watched where afterwards I was like, ooh, I might want to build an app that uses AI.
Yeah, it's the same for me today. It's kind of things clicking together, and I started to understand why it works, but also how to use them. What are the actual benefits I can use tomorrow?
Right. Totally.
We also had a lovely discussion about pronouncing names in the Discord chat. So I have a question for you. Let's say we never met before and you have to introduce yourself. How would you say your name? How would you introduce yourself?
My name?
Yeah.
It's Melanie and then Plageman. And lots of people who speak German tell me that that's not how I should pronounce my name. But it's pronounced Plageman. But I guess my family gets to decide how to pronounce it. So yeah, Plageman. What about you?
Yeah, I would say Derek van Veen.
I've been saying your first name wrong this whole time.
No, that's how I say it, because it's impossible for non-Dutch speakers to say it that way. So when I introduce myself to any non-Dutch speaker, I always say Derek. But there was something else I want to say.
Wait, is Dirk? Dirk is not how you say your name.
That's the closest one to Dutch you can get, I think. So if you want to be as close to the Dutch pronunciation as you can get, then that's the one you pick.
Okay.
Funny story. One time at customs, they said duck, and I was making jokes about ducks in the car, and that was not appreciated by customs. So lesson learned, never make jokes with customs.
I could
see
that.
Apparently, a lot of women introduce themselves only with their first name and not with their last name.
Oh, well, if I was introducing myself to someone, I guess I would just say my first name. I said my last name because I thought that's what you're asking about, but I usually don't say my last
apparently name. It's a thing. Like if men introduce themselves, they say first name and last name. And women usually only say first name. And apparently when you say first name and last name, people rate you higher. So whenever you introduce yourself, use them both.
Use my last name. And then ask them to refer to me with the formal version in my last name. So if you want to give feedback, which you should, to Abe Omorogbe, I tried Omorogbe. I think that's very close, right?
I don't know. I hope so.
It's what he put in the chat. So I think it might be close. Yes. Go to Survey Talks LS3 and go and search for AI. Well, there's Bruce's talks. You can't just search for AI. You have to actually search for, I think, building or some one of the other keywords in his talk. And I will personally be giving feedback because I really, really enjoyed it. So do that.
Yeah, it's a great talk.
And as I was saying, this actually inspired me to maybe try building an app with some of these cool tools that Microsoft has. So there's something called Reactor, which is like a network of virtual and physical spaces that Microsoft has for like learning and education and things like that. And so they have one, I think this one is virtual, on building AI apps with Azure Database for Postgres. So all of the cool stuff that Abe just told us about, you can get more hands-on with it and try it out and attend this virtual series to do it yourself. Oh, I think actually before the next speaker, we're going to see a Livestream 2 trailer. So Livestream 2 already happened, but I think we're going to watch and see what we missed. And when the talks go online, you can watch them then.
And actually, should I give feedback to Livestream 2? Let's say like there are a lot of good talks and they watch them back and that you can provide feedback for another week. But you're only helping us out, right? You're not going to help Livestream 2.
No. You should provide feedback for all the talks.
Yeah, I roll back my comment. Give feedback to all of the talks.
Rollback, yes. Transaction rollback.
All right, Livestream 2.
Hi, I'm Bruce Momjian, Postgres core team member and EDB employee. Today I'll be talking about databases in the AI trenches. I've always been curious about how AI worked, and I had the opportunity to do a lot of research to understand the internals of exactly how AI is processed. And as part of that, I was able to understand how databases can be most effectively used for AI workloads. I think that might be the most important thing I'm going to be talking about today. We do have a lot of slides, but it should be an interesting presentation.
Hi everyone, my name is David Rowley and I'm a Postgres committer at Microsoft. And today I'm here to talk to you about what's new in the Postgres 18 Query Planner. And this talk is going to be useful for anyone who's thinking of upgrading to Postgres 18 when it's released later this year, or anyone who's thinking of migrating to Postgres and wants to check in on the latest features.
Hi, I'm Jelte, and I work at MotherDuck, and I'll talk about how PGDuckDB can make your analytics queries in Postgres faster and easier to write.
Hello, my name is Heikki Linnekangas. I am going to talk about how we made Postgres serverless at Neon. Stay tuned if you want to hear how do cloud providers run services in behind the scenes.
Hello everyone, thank you for joining my session today. My name is Shinya Kato and I'm a database engineer at NTT Data Japan Corporation. Today I will talk about Postgres extensions. The title of my talk is Can we use Fast to develop extensions for Postgres? If you're someone who is passionate about Postgres extensions development or curious about how Rust fits into the picture, this presentation is for you.
Hi there, I'm Johannes from Mercedes-Benz R&D in Sindelfingen, Germany. In my session about Azure Postgres security, I dive into details how you can make your database more secure. And I will focus about network security and access management. I'll cover all the basics and explain how it works together. So no prior knowledge is required. I want you to be ready to build your own solution in this space.
Hello everyone, myself Palak Chaturvedi. I am a software engineer at Microsoft.
Hi everyone, myself Nitin Jadhav. I'm a senior software engineer at Microsoft. Today, myself and Palak are going to talk about debugging data corruptions in PostgreSQL, a systematic approach. We will explain our experience on handling corruption problems first, and then we will summarize with the approaches to handling corruption cases, including best practices. The attendees can apply these techniques to avoid corruptions at first place and also learn how to detect and recover from the corruptions if it happens.
Hello, I'm Ashutosh Bapat, major contributor to PostgreSQL. I'm part of PostgreSQL contributors team at Microsoft. Today, I will talk about logical replication, which is a relatively new PostgreSQL feature, and it receives a lot of improvements in every release.
Hello, my name is Polina Bungina. I work as a senior software engineer at Zalando, a European e-commerce platform. But I'm also a co-maintainer of Partitioning project, and today I want to share with you some insights about how it works, which might be helpful for everyone who is building or operating high availability for PostgreSQL.
Hello, my name is Silvano. I work on Postgres in Microsoft Azure, and I'm here today to talk about .NET and Postgres as the next open source application development stack for your solutions that can run on your on-prem, cloud, mobile, and many other platforms, and interacting maybe with the next-gen AI models that Azure is providing.
Hi everyone, my name is Nato Alonso Portillo. I'm a principal technical product manager in the Azure Database for PostgreSQL team. In this session, I'll be introducing a fantastic feature in which we keep investing to extend its scope and evolve its functionality. You're interested in this session if you're a system engineer, a developer, or a database administrator who is struggling with performance issues.
Looks like there's a lot of good content from Livestream too.
I wanted to say exactly the same. There are so many good topics. Sometimes I'm just surprised. I'm like, this is cool, but this is cool. And this is also really nice to watch. There are so many interesting things to talk about.
And I noticed that each year there are more talks. So like some of the people work with me or at my team at Microsoft, but then as you meet more and more people in the community, I feel like I'm like, oh yeah, I know this person and this person, and eventually it starts to feel like you're watching talks from your friends and community members, which is a really cool feeling too. And we're expanding every year, right? The community's getting bigger.
I think I am watching talks from a lot of friends. Some of these, especially the European speakers, we meet each other so often, and more of them I consider to be my friends these days.
Yeah, totally.
Postgres is a community.
Yes, it really is. I recommend to anyone who has the opportunity to go to one of the in-person conferences, because you really will like be taken in and get to hang out with what feels like a big group of friends. So great. Well, next we have Taiob Ali, and he's a database solutions manager at GMO, and he's a Microsoft Data Platform MVP, which I always like meeting our partners and people with the Microsoft Data Platform experience. I think it's really interesting because a lot of times they'll have experience with like multiple different technologies, and Taiyob's one of those people. He has worked with SQL Server and Mongo and everything, so he kind of knows what Postgres is best at. He's not just only ever used Postgres, so doesn't know any better. He's sort of like, this is what Postgres is good at, and he has like extensive knowledge about compliance and security and all the special features that you can use in Azure Database for Postgres that will meet your use case, and especially if you have some expectations coming from some other platform. It's really informative. So looking forward to it.
Hi, everyone. My name is Taiob Ali. I'm a Microsoft MVP on Data Platform. Today, I'll be talking about Azure Database for PostgreSQL, 15 essentials for compliance and security. If you are using Azure Database for PostgreSQL, doesn't matter if you're a veteran or if you're new, you should be listening to this talk. Okay, so let's dive into the 15 essentials that I just talking about. And I thank you all for joining. Hope you are enjoying the conference. And I also want to thank Claire from Microsoft, who actually encouraged me to submit for this conference and helped me with few tips about my abstract. And I also, I'm thankful to Teresa, Isaac, and Mai for looking at my slides and checking this for accessibility. And if you have any questions, you can, if you're watching it live, you can always put in the chat. But if you're watching it later in the recording, I'm going to share my contacts. You can always reach out to me, and I guarantee you that I will answer your question, within a couple of working days. If you have any questions, comments, you can always put it here. I'm not going to talk about my credentials. Just take a note of my contacts, and I'll share those again at the end of the session. So let's dive in. So what we will be talking about today? We'll be talking about 15 standards, as you probably read in the abstract. And I'll try to make a case for each one that why you should be thinking about those standards on particular topic out of those 15. And I'll also give you an example of what standard I implemented, but that is heavily influenced by my workplace, because I work for a financial industry. So I have certain requirements. If you're working for a different industry, you might not follow exactly the standards that I'm implementing, and that's absolutely fine. You should be talking to your application owners, you should understand your business, and you should modify the standards that I'm going to tell you. And I'm also going to tell you how I implemented the standards, right? And I'll be talking primarily about two ways to implement those standards, and we'll go into a little bit more details on those. At the end of this session, I'll also give you a checklist that you should be able to download from my GitHub repo, which I'll share the link at the end. That will summarize the whole talk and kind of give you a checklist that you can take with you at your work, and you can go through the checklist each item by item and cross those off and implement those. When it comes to implementation of these 15 standards that we'll be talking about, so there will be few that you should be implementing during when you are when you are deploying your resources, like when you are setting up your PostgreSQL, whether you do it through template, whether you do it through pipeline, whatever way you do it, doesn't matter. You should check those right at that time. But after you do those, right, then you can still check most of this stuff. So the way I do it is mostly Azure policy, and other one is Azure function. Azure policy is the best thing to do if you can, because you can set it up at a higher level, like at a tenant level or at a subscription level, and it will check all your resources underneath. But there will be situations, right, that you cannot really do it with the from a higher level, because if you have a lot of flexibility with your standard, right, if you give the app owners flexibility, say like long-term backup retention, someone need 10 years, someone need 5 years, someone need 3 years, it will be very difficult to implement this via Azure policy, because now you have to put the policy at a very lower, at a granular level. Right? That's really not the way policy works. So in those cases, if you see that I put both options in the slide, you should probably look at a Azure function driven by a table, right? So if you have a table driven, if you have a table that has all the metadata, that okay, this one I need 5 years, this one I need 3 years, this one I need 10 years or whatever, and the function can go and read those and check against those, right? And if someone changed it, and so you get an alert, you get a notification, you go and double check and fix it. Either you update your table or you reset it where it was, where your standard should be. And before I go further, other thing is for all the 15 standards, you will see primarily 3 slides. The first slide, you will be talking about why should you have a standard, what is the requirement, or what's driving to set up a standard across the board. And the second slide, we will talk about what I implemented based on my experience and my work I just told you. And if there are any exceptions, how do we deal with it? How do we check the standard, right? How do we implement it? And you'll see a third slide, which I'll mostly skip because that will have to learn more, right? If you want to read more about that particular standard, if you want to read more about the implementation, I put some links, mostly from Learn website that's maintained by Microsoft. So every third slide for each standard, I'll probably skip in the interest of time. Okay, so why should we put standards, right, across the board? And basically, what I just said, you might have compliance requirement. And the other thing is, how do you monitor, alert, and forecast, right? A large enterprise. If you have hundreds of this PostgreSQL, how do you know that if something is going wrong? How do you know that a backup is not working or your long-term backup is not there? How do you know that your CPU is spiking? How do you know that there is a timeout, right? For all of these problems, right, if you are not going to sit there 24/7 to monitor all this, once you set up these standards, your operation becomes easier. Plus, you are also compliant from different regulatory requirements or your business requirements. So it solves both the problem. And that is why you should issue standards. And I wrote this like a 4 bullet points here, but I'm not going to go into any further details. If you want to know more, just reach out to me. So the first one we're going to talk about is a workload type. Whenever you deploy a PostgreSQL, you can choose the workload type, either development and production. This does only one thing. It set up a default compute tier, which you can change later on. So on the question you might ask me that if I can change it later on, why you are even setting up a standard? The problem is with the development, if you choose, the default tier, compute tier it chooses is a burstable. And burstable doesn't have certain features that is really you need for a production deployment. Like it doesn't have geo-redundant backup. You cannot have read replica in burstable. So I do not want in my company or at my workplace or for my clients to deploy a production PostgreSQL with a burstable tier. Now, you can change it later on, but some of the stuff that say like geo-redundant backup, you can only set this up during deployment. So if I'm deploying with burstable later on, I want to change it, I cannot do that. That's why I want to have a policy from the top that any production deployment should be choosing production, and the default for that is a general, but you can also change it to memory optimized. That is why I want to implement this one. And again, as I said, my standard is development for non-production, and for production, you choose the production one. And if you can standardize this, I'm not going to say this again and again, I already mentioned this, then policy is the best. And this one, actually, if you can enforce this during creation in your pipeline, that will be the ideal. But if you cannot, for any reason, policy should work. And this is my third slide that I talked about. I will skip this one for each of the remaining 14 items. Tags. So as you can see in the slide, I only have 2 tags that I put mandatory at my workplace. But for you, I'm not going to tell you how many you need. You should, you should decide that for yourself. Why tag? Why should we put tag? Tags can do a lot of stuff. You can group your resources by tag, by department, by business unit, production, non-production, UUID staging, whatever way you need for reporting purposes and for billing. This is a huge, huge win, right? Because as your deployment or as your footprint is going to grow, very soon you will see that you have to take a control of your cost. And unless you plan this from the beginning, right, you push it to different departments or different business units, this will be very difficult. Many shops at the beginning, they think, okay, we'll centrally manage the cost. But as the journey begins, within a year or two, they realize, no, that's not going to work. Then they look at, the different way to, different subscriptions and different way to do this. But tax can help you big time. One thing I'll warn you that the tax does not get inherited from the top to bottom. So do not think that I have this tax as a subscription, all my resource groups under that subscription or all the resources under a resource group is going to inherit those tax automatically. No, it does not. There is a way in the cost management as a line item, which is really not a tag, and I'm not going to go into details. That you can push through that if you want, but the tag itself doesn't get inherited. So just keep that in mind, because there's a lot of things get inherited. You can set that up from tenant to subscriptions to resource group to resources, but the tag is one item that you cannot. Maintenance schedule. So if you are working on premises or in Azure, right, things need to get patched. Whether it's software, hardware, we all know that. Even our phones get, right? How many times you get this iOS updates? How do you manage that? Normally, when we are in our own data center, right, life was easy. I could control this. I could probably do like non-prod this month, production next month, and all that. But now you cannot control that. But it's in the hand of your cloud provider. But for Postgres, Microsoft actually did some awesome work that you can somehow control it indirectly. So there's 2 maintenance schedule. One is called system managed, and one is a custom schedule. So for system managed means it's any day and any hour between 11 p.m. and 7 a.m. But for custom schedule, I can choose a particular day of the week and I can choose an hour. So I have a lot more control on that, right? It's a lot better than any day and between 11 p.m. and 7 a.m. The other good part is any patch that Microsoft deploy, if it's a system managed, it get deployed today, but it will wait for 7 days to deploy to any servers that has been set up with custom schedule. So you really get 7 days of a break for in between. So for me, my standard is if you are a non-production, you get system managed. If you're production, you get custom scheduled. That way I get that 7-day buffer to do my test of the patch that was deployed, right? And I can see if there's any issue. And this one, I think you can easily do Azure policy if you follow my standard. One thing I'll tell you a little bit more is that you can get notification for these patches. So there are 5 different ways. I'm not going to go into details. I have the URL. You can go and see that there's a menu of 5 different items that you can get notified depending on how you want to get notified. Like you can even get a voice message. You can get if you're Azure Resource Manager role, you can get email and you can get text messages and all this. The other thing is normally between the 2 patches, there is a gap of 30 days, but do not count on that. If there is a critical or emergency update, you will get patched in between. You can get, before 30 days. So Microsoft is not going to honor it, right? If there is like a 0-day vulnerability, like as sometimes you see, like even on our phones, right? The Apple release those the 0-day vulnerability, and then Microsoft does it. You see it all over the news. So that time they're not going to wait for 30 days. But otherwise, if it's a normal patch process, you'll see a 30-day cadence between the patches. And there's some more resource for you to look at. Backup retention. This is something we all know if you're working anything with the data, that you need to have your backups. Doesn't matter what kind of data you're working on or what system you're working on. And for this, when you deploy a PostgreSQL, by default, you get 7 days point in time retention, which you can slide up to 35 days. So this 35 days, 7 to 35 or 0 to 35, you can even slide it back to 0 from 7. You get point in time that you can restore. But you can also get long-term retention. Like at my workplace, we have certain transactions in the financial industry that we must keep detailed record for up to 7 years. So for long-term retention, you can set that up and you can keep that for up to 10 years. In my place, we do not back up non-production. But again, as I said at the beginning, talk to your business owners, your business partners, your company policy. You might even need some retention for your non-production. It's up to you. Production, again, based on your requirement. How many days you want point in time? What's the long-term retention backup? And then if there is a company standard, you might still have some exceptions. Like I'll give you an example. If there is a warehouse that is not generating any, it's not saving any new data, it's all, getting fetched from other systems from the company, do you need to take transaction log backups every X number of minutes? Do you need to keep point in time for 35 days? Because you can always reload. So that's the option. So you might have some exceptions. And this one, again, you can use either policy or function, what I said before, based on that. Backup redundancy. This is also important because if you have an issue, how do you restore, right? So is your backup intact? Can you get it from where you have it? Is it corrupted? So there are 3 different ones. There's a locally redundant, which is default if you're deploying in a region which doesn't have zone redundancy. And a zone, I'll just tell you in a quick sentence, a zone is something within a region you can have different data centers. A zone is independent of power, cooling, and all those. So even within a region, if one data center is down, if you have zone redundancy, it will automatically come up in a different zone. So if you're deploying in a zone that has zone redundancy, that is the default. You can also set up your backup with geo redundancy, means it is going to get replicated, your backup, to hundreds of miles away. And Azure, if you go to the Learn website, you will see there is a partner kind of region, right? For just to give an example, for East US2, the partner is a central US. So any backup you do in East US 2, if you have geo redundancy, all the backups get copied to central US. So what does that give you? If the whole region is down, you can use that backup that was copied in a different region and you can restore from there. For my standard, locally redundant for all non-production. Production, we have zone or geo redundant based on the application, and you can again policy your functions. One thing I think I mentioned before, I'll repeat it again because it's important to know. You can only choose geo redundancy at the time of creation. You cannot do that later on. So just be aware of that. Resource lock. This is not specific to PostgreSQL. This can be, this applies to pretty much most of the resources in Azure. So there's two different locks. One is a delete lock and one is a read-only lock. And the name says it. The read-only is going to prevent you from any modification, and delete is going to prevent you from deleting the resource itself. So my standard is put the delete lock in production, and for non-production we use the read-only lock. The reason I do not want to put a delete lock on the non-production because this can have issue with your deployment, right? If you are, if you're testing something, if you're continuously destroying and rebuilding through your pipeline, I do not want to have a delete lock because then your pipeline is going to fail, and it is just going to slow your development. But again, how do you do this in your place? Think about it, right? So again, as I said, mandatory for all production. Azure policy will work perfect for this. If you need an exception for any reason, make sure you document this. That way, you know that if something happens, why there was exception, who requested it, who approved it. Just document those. There's some more info about the locks. Compute tier. We touched it a little bit when we were talking about the workload type. So there are 3 compute tiers: burstable, memory optimized, and general purpose. For my standard at my workplace, as I said, for non-production, you can go to burstable because it's cheaper. It doesn't have all the bells and whistle, which you probably do not need for your non-production. But for production, we only use the other 2, general purpose and memory optimized. And if you need zone redundancy, you want to be careful before you deploy, because there is a list that I put in the resource that which region now allow zone redundancy. Not every region today have zone redundancy. Just be aware of that. And again, Azure policy. And then you also want to have non-compliant servers if for some reason someone want to use burstable for production because it's less cost. The application is not that, it's probably a different tier, a lower tier that they can afford. So just document that. Storage auto growth. So this one is very tricky because if you set it up to auto, it's perfect. Everybody's happy. But then it can also cost you money because if you get an alert that your storage is at 90%, you can always squeeze the developers or the app owners. Maybe they have some logging on, they have some historical data they can get rid of. But if you have auto scaling turned on, you're not going to catch those. So you have to decide what you want to do. For me, again, we talk to the app owners and we do it case by case, because there can be situations that people cannot afford to have disk full, cannot have downtime. Some people, for them, if we give them alert at 90%, they're okay to work with us. Either we increase it manually, or they will find some data that we can purge or put a purge routine. There's some more information about that. NS metrics. So you get a set of metrics that will come automatic when you deploy, but there are 6 different kind of NS metrics, and that also doesn't include, there's 2 more called PG bouncer, and there is another one. You can set all this up for your production if you need. There are different server parameters that you have to turn on. There's one called PG bouncer. If you know about the auto vacuum, you can also monitor those. So you need to decide whether you need those or not. In my company standard, we turn some of those on for production. It's optional for non-production, but if someone is troubleshooting issue in non-production, we might turn it on for them. Diagnostic settings, you can see on the right side. At my place, we turn it on for all production servers because our destination is log analytics workspace. You can send it to storage account. You can send it to Event Hub. You can send it to some of the third-party monitoring tools nowadays. But one thing you remember about the retention of your data. So control that because that is going to dictate how much money you are spending. So the data is there for, I think it's 90 days. And I think up to first 31 days is free. But then after that, you have to pay for it. So, and you can adjust the retention based on your need. Server logs. So this is different than the logs that you saw on the diagnostics picture. There are two logs. One is a server log and one is called an upgrade log. By default, if you turn it on, it retains for 3 days. You can change it to between 1 and 7 days. And you can download those also. And during upgrade is very helpful. And for your day-to-day, if there's issue, you can go and take a look. So for my standard, it's turned on for production, but we don't turn it on for non-production. High availability, very important. How you can achieve this? You can do it through, we talked about zone redundancy, we talked about geo-redundant backup. I'm not going to talk about those anymore. But you can also set up read replicas. And read replicas, you can always bring them up as a primary if the one region is down. So you can do that. But again, it is going to cost you double. So if your app, depending on your RTO, RPO, if you're happy with your backup or zone redundancy, you don't need that. But if you need to bring that up quicker, but that you can set up, but your cost is going to go to double. So just keep that in mind. Authentication mode, you can do both. You can do Entra only. You can do PostgreSQL authentication, or you can do mixed. Entra is the best if you can do it, because then you are not dealing with passwords, but sometimes it will not be possible. So talk to the business owners, and you can do it through Azure policy, very easy to implement. Private endpoint, super important. You do not want your data to go over public internet, so make sure you implement this. I mean, I would not go without this. We do this for all servers. Doesn't matter if it's non-production or production, because we don't want data go over the public access, and we disable the public access. So, and Azure policy will be perfect to across the board to implement this one. Defender, it will cost you money. It costs $15 per server per month, but it can give you a lot of protection. It continuously checks 24/7 brute force attacks, other abnormal traffic pattern. You can get alerted right away. We turn it on for all our servers, non-production and production, and Azure policy will be the best to implement this. So implementation approach, I mentioned a few times. I'm not going to go through it again. During deployment, function, and Azure policy, you can use all this. And here are some of my links. You can go to GitHub, my repo, and download. And you can contact me with any of these. And I thank you for attending my session. Reach out to me with any questions or comments. Thank you.
Thanks so much, Taiob. We had a lively discussion in the chat about how to pronounce Postgres, which I guess I haven't actually run into that discussion before, but it must happen.
Yeah. I'm thinking about it. Where this was, like, how do you pronounce it? Or was it pronouncing SQL or saying SQL? Just also like one of these long discussions, and people can be really passionate about it.
Yeah, I would say SQL versus SQL. I'm not as passionate about as people that call CLIs CLIs. I feel pretty strongly that that's incorrect.
I never heard CLI.
I heard it for like the second time in like years ago. Someone said it, and then I was like floored. And then I heard it like a week ago, and I was like, "What is happening?" Yeah.
All right. So the last one already. I'm getting tired, to be honest, of watching all these talks, but I'm still really disappointed this was the last one.
Yes. Well, there's more tomorrow. So give your feedback to Taiob. And
yes. Search for the title as well.
Oh, yes. Good. We didn't keep meaning to actually say that.
Database for Postgres 15 Essential Standards.
Yes.
I think they are in order, actually. So probably when you go to the last one, you'll automatically have the correct talk.
Right. Yes. So we are at the wrap up now. Dirk and I have been your hosts. It's quite late for Dirk there now. Yeah.
Yes, It's been a long day. It's 11 p.m. now. It's dark outside.
It's time for bed. But there is more. So tomorrow, or is it today? Is it in a few hours? Livestream 4 will be happening. And same things apply. You can join on the Discord, and the replay will be up once it's over, if it's while you're asleep. And we also still want your event feedback. So if you have feedback not related to the talk specifically.
Right. Melanie, before we continue, I think we haven't seen the trailer of Livestream 1 yet.
Oh, I didn't know we were supposed to do that. Okay. Sounds great.
I think we can.
Okay, let's hear it.
Hi everyone, and welcome to the 4th year of Posette, an event for Postgres. My name is Charles Pedersen. I'm the Director of Product Management for Postgres at Microsoft, and I'm pleased today to be able to tell you about all the things we're building in Postgres at Microsoft in 2025.
Hi, my name is Robert Haas. I work at Enterprise DB, where my current job title is VP Chief Architect Database Servers. And my talk is about incremental backup, which is a new feature that I developed for PostgreSQL 17. I'm hoping that this feature will be of particular interest to people who have large databases and they're looking for some new backup and restore options.
Hey, hello, my name is Boris Mejias in the role of Monica de Bea.
And I'm Sarah Conway in the role of Evelyn Cates.
And the reason that we are saying in the role of is because this is going to be storytelling. We are going to tell you the story of a developer who comes and seeks help from a DBA who knows a lot about databases, and together combining their knowledge, they are going to be able to provide data integrity through data modeling.
As you can imagine, if you're an application developer or a DBA or anyone in between, even if you're just interested, you can definitely benefit from this talk.
So hello, my name is Thomas Wondra. I work at Microsoft. I'm a long-term Postgres contributor, developer, and also a committer. And I'm here to talk about performance archaeology, which is an overview of how the performance of Postgres changed over the many years of development. So if you are interested in performance and are a user or a developer, this talk might be interesting for you.
I'm Pamela Fox, and today I'm talking about building modern Python web apps with Postgres. If you've ever thought about building a Python web app and you're trying to pick the technology stack, then this talk is for you.
Hey everyone, I'm Matt McFarland, and I'm an engineer at Microsoft and a contributor to the new VS Code extension for Postgres that's just been released to public preview. Please join this talk if you're interested in learning about a new tool in VS Code that can help manage and you develop Postgres applications using both standard database management tools and also more advanced Copilot AI capabilities.
I'm Luke Svittel, founder and CEO of PG Analyze. We're going to talk about how to optimize slow queries in Postgres. Specifically, when you have an explain analyze output and you don't know how to interpret it, I'm going to give you a few tips and tricks and a better mental model for working with slow queries in Postgres and how to fix them.
Everyone, I'm Bohan Zhang. I'm a member of technical staff at OpenAI. In this talk, I will discuss how we scale Postgres to the next level at OpenAI. Specifically, we will talk about how we operate Postgres and the lessons we learned and the challenges we face and how we address them at OpenAI. If you are a DBA operating production Postgres at a very large scale, you might be interested in this talk.
Hi, I'm Vinod. I'm a partner software engineer at Microsoft and one of the committers of Microsoft's DocumentDB. And today, I'll be talking about designing document databases for PostgreSQL. aka how we leverage the awesomeness of Postgres' extensibility model to build Microsoft's DocumentDB.
Hi all, my name is Gayatri Padalla, working with Microsoft as a PostgreSQL performance expert. Boosting the PostgreSQL server's performance using Azure Advisor recommendations is the best way to identify any vulnerabilities your server is going through. You will be informed proactively, and anyone who is moving from Oracle, who is not aware about the internals of the PostgreSQL, for them this is the best approach to identify their server's vulnerability and get it fixed.
Hi, my name is Philippe. I'm one of the founders and the CEO of ParadeDB. Today, my talk is titled Elasticsearch Quality Full Text Search in Postgres using Tend2V. We're going to be talking about how you can do full text search in Postgres today, what it's amazing at, what it's perhaps not so good at, and then some of the ways in which the work that we do at Parade with an extension called PG Search is lifting the limitations that full text search in Postgres has to make it competitive with Elasticsearch and other search engines.
Awesome. I'm glad that we came back to that.
Yeah.
I feel like it's the season of Postgres talks because I listen to all of the pgconf.dev talks after it happens because I don't get to go to all of them. And then those videos are available at the same time as like Posette's happening. And I always listen to conference talks on my runs. And so like right now I have so much content. It's very exciting.
It's really cool. I'm really curious about the talk from Boris and Sarah. They're
Yeah.
both fellow organizers of PGA Lowlands, and I know they put a lot of effort into storytelling, which is completely different experience. So I'm definitely going to watch that one as soon as it's online.
Yeah, it's really cool to see talks that are good that have multiple speakers. It's really hard to get a multi-speaker talk right. So I'm interested to see how they do that.
Well, especially a multi-speaker talk where it actually increases the intensity or the level of the talk. Like it's not the thing like you do a half and I do a half. Then it's not really added value. Right?
Yeah. Cool. Well, so again, going back to the wrap up, after this, there's Livestream 4, and we still need your feedback. And you can watch the replays for 1 and 2 have already been posted for the live streams. And again, thank you to our speakers. I thanked them in the intro, so I'll let you say something, Dirk, about speakers this time.
I think, I don't know, it's such a nice group. If I look at this picture, it just makes me happy because I know all these people, they put so much effort in building talks, and most of them I know, and I know how much they care about these talks. And it just feels you like appreciated to watch it actually. Because some people, who, if you never give a talk, you don't realize how much work it actually is to build a talk like this. And I feel just very pleased to look at this and really say thank you to all of the speakers.
Yes. And it's also a lot of work to pick which talks should be in the conference. Claire is the chair of the Posette talk selection team, and she is like so this is my second time on the talk selection team, and she really wants to make sure that we get it right. So it's been interesting. Like there were so many submissions this year. I don't remember the exact number, but it felt like 1,000 because we have to read every single one and really like give it time and consideration. And so she's always tried 230. Teresa just told me, okay, not 1,000. That we, to spend time with each one, to read the speaker bio, and then Claire's, tries to come up with ways to make sure that's optimally fair. And she might have a blog post out there, but just like each program committee having been on different ones, you can see how they decide to put together the program and how they decide to vote. Like we put a lot of time and effort into, like the algorithm that we use for comparing talks, do we compare 2 at a time? Do we, whatever. And then synchronous meetings for hours where we discuss the merits of one talk over another and how does it balance the program. And for a speaker, we go and watch speakers' videos from past conferences, or if it's someone who hasn't had a talk before, we do research and try to find blog posts from them. Like it's a so much work. So
Yeah.
yeah.
Do you know how many talk abstracts we had to go through for PGConf EU last year?
I cannot imagine. Tell me.
It was almost 800.
Oh my God.
Yeah.
Wow.
And then people have a free talk limit.
Right.
So, and still you have like so many submissions. So I know how much work it is, but it's also a luxury.
Oh,
because
yes.
people are willing to put in the effort. And as a program committee, you can really do, it's almost like cherry picking. It's like I have a good talk and a good talk and a good speaker. And then you can really build a conference like this.
It's really cool that there are, 800 pieces of Postgres content that people can come up with, and based on their expertise that they're willing to share. Like, I think that really says something about the quality of our community and the number of experts that we have.
Yeah, and then also the statistics are not in your favor. So yeah, you can't present everywhere where you want to.
Yes, keep submitting. There's other tips, I think, like try to present at a meetup first, and then that way when program committees are reviewing your talk, they have something they can see that you've presented before. So yeah, there's ways.
Help speakers.
Competitive. Yeah.
You have to give them feedback. They can grow.
There you go. And we're also really grateful to the organizing team. Putting together this event is so much work. As you can tell, it's very professionally produced, and there's so much that goes into it. So these are the people on the organizing team, and should really thank them. They put together a great product.
Yeah, definitely true. It's a lot of work to organize conferences, whether it's online or offline. It's so much unseen work you never think of until you actually do it. So really appreciate it. Thank you.
And to the hosts, so us, but there is also Claire and Flor and Boris and my teammate Thomas Monroe and Adam Volk. So it's a big time commitment, and it's fun, but it's definitely like a gift to the community that these people gave.
I was really nervous doing it, but I have to admit, I really enjoy doing it. I don't mind at all spending my time on these things. It was a really pleasure to do it.
Oh, I'm glad that you enjoyed it. And thank you to Microsoft for making this possible and the resources to actually do this. So really great. All right, so the ultimate guide, if you had this on in the background but didn't really pay attention to the talks or whatever, and you want to go to see the on-demand talks, aka.ms/Posette guide, and broken down into different areas with tags, and you can, revisit topics that are most relevant to you.
I think this slide has Claire's handwriting all over it. I think Claire must have built this one.
Yeah, it's got Isaac's design vibes, but definitely Claire's mind. So the keynote for the Livestream 4, which is still coming up, Charles, I didn't have a chance to watch it in Livestream 1, so I'm going to have to catch it either on demand or in this next live stream. But I had someone send me a message and say, hey, did you hear about this thing that was in Charles's talk? It sounds really exciting. And it was actually a committer. So I was like, oh, if a feature that we have in Azure Postgres got some committer at another company excited, it must be really awesome. So yeah.
And there are some nice familiar faces in it as well, if you watch it.
Yeah. And so I think this is Livestream 1, right? These are the 11 talks that are in Livestream 1, I believe.
Yes, it was Livestream 1, because okay. I've seen a few of them.
And Livestream 2. And then this is our live stream that you just saw. So there's, 11, 11, 11. So there are the same number and all.
Yes, and I know why. Because there are 2 keynotes, and they are given up 2 streams. So that if you do 2 keynotes twice, that adds up to 44 talks, and then you have 11 talks in every stream.
So there was no day on which we could win the surveys, I guess.
No, the surveys are honest. So
So there's a bunch of upcoming, so Postgres events, both Dirk and I are organizers, and I guess like we're biased, but we both, so I think it's in the next slide. No, I don't know. pgconf.dev is not upcoming, so it's not on here, but it takes a lot of work to organize events, but they're super fun. And so like, we really, if you haven't been to a Postgres event before, you should come to one. Dirk, you can tell us more about PG Day Lowlands. I haven't been, but
PG Day Lowlands is gonna be so cool. It's in Rotterdam this year, and it's in the zoo. So, can I say this? Maybe not, but I will do it anyway. So, when we have the room with the sponsors, it's a huge aquarium. So the huge fishes are swimming like next to you.
Wow.
And you're really close to the real elephants. And you
Can
can
I ask
actually
a really dumb question? Is Amsterdam different than Rotterdam?
like different cities.
Yeah, is it it's a different city, or it's not like
It's
a
a-
neighborhood in, okay, because the
It's-
slide says Amsterdam. So that's not right. It's Rotterdam.
Last year it was Amsterdam, and I would say people in Amsterdam and Rotterdam, they can be really passionate about where they live. So some
Okay.
people living in Rotterdam actually refuse to fly from Schiphol because it's in Amsterdam. That's how passionate people are about this. I kid you not.
How far away are they from each other?
1 hour by train.
Okay.
It's really close, but the Netherlands are really small.
So
But
even if I
would say-
fly to Amsterdam on September 10th to go to the event, I'll still be able to make it to Rotterdam by September 12th. Okay.
There are like 1 million trains an hour going from Amsterdam to Rotterdam and back. It's more, I think Rotterdam is the city of labor. They have the harbor, and Amsterdam is more the city of the art, the musea. Even though there are a lot of musea in Rotterdam as well, but
And
well,
Rotterdam has a fish. The
Yes.
aquarium fish.
yeah, but it's gonna be cool. I'm actually missing PG Day Austria in this list. It's
Oh,
also in
okay.
September. I'm not sure whether it's the week before or after Lowlands. But
Okay, well,
I'm really sure it's there.
I bet there's a piece of content that could be posted in the Discord that has the updated date or location for PG Day Lowlands, and maybe we can put the PG Day Austria
And I
information
think
there
we
too.
have a discount if you go to both London and Rotterdam. We will try to get you a discount. It's a little bit hard because of the separation of EU, non-EU, and taxes and these kind of things, but we try to get you a discount if you visit both.
Oh, that's cool. I didn't know about that. And then, of course, there's PGConf NYC and EU this fall, which are both great places to meet Postgres community people. So just a plug again for our social, and on all of the major platforms, just follow PosetteConf, and you can tag PosetteConf or use the hashtag or both, and just tell us what you thought, and as the live stream 4 is going on, what you're thinking.
Actually, PG Day Austria is September 4th, and I think the call for paper closes on the 15th of June.
Okay, good to know. All right, so this is just lots of different areas: ecosystem, core, Azure database for Postgres, lots of different talks. You can check the schedule for more information on that. And there are swag codes in the Discord. And now, okay, so let's say the conference is over. You want to find like what talks were there. You can go to the schedule page and figure out what's there. And if you want to watch them, once they're up on the YouTube, there will be a playlist on YouTube that has all of the talks on it, so you can find them.
I have to tell you something. Every time I give a talk, I add a sticker to my laptop. So I would love to get the stickers for Posette, and I can put it on my laptop. But now I have my laptop for several years, and I might need to get a new one. And now I lose all my stickers.
Oh, I thought you meant you're going to get a new one because you ran out of space for stickers. That would be pretty fun.
Stickers can overlap, and they can be on the front, the back, the cover.
Okay. My favorite all-time like Microsoft related sticker is this new one, Microsoft Loves Postgres. And like there was this Microsoft Loves Linux little penguin, and that was always my favorite thing. And now this is my new favorite Postgres Microsoft swag.
Yeah. How much can we care about stickers, right?
I don't like putting them on my laptop. I'm weird about that. So I'm always like, where can I put stickers? So I've just realized, I think water bottle. I think that's my new place that I'm gonna do.
Yeah, my laptop is protected by a cover of stickers.
That's true. It's protection. And then there's the Talking Postgres podcast. Again, you should check it out. I've had lots of people. So if you look at the schedule, while the podcast is being recorded, you can participate in the live Discord, a lot like what we did today, which is super fun. And when I have time, I always try to tune in because some of my favorite Postgres people are usually there, or people I haven't heard of that are doing interesting things and help me get exposed to new Postgres things. And it's really technical, and like Claire does a great job of delving in really deep with people on the podcast, and people who find it later and stumble on episodes. I've had people tell me they listened to my episode like a year later or whatever. So I recommend it. A lot of the people who have talks in Posette actually also were guests on Talking Postgres. So
yeah, thank you, Claire. You're doing a great job here, and a lot of people love listening to your podcast. So thanks for still carrying on.
Yes.
It used to be the two of you, and I know you're doing it on your own these days. Well, of course, you have a team with you, but keep on with the good work.
It's such a good asset to the community. There's all the guests. Okay, so this is how many talks. We have 42 talks. 45 speakers. Oh, because some of the talks had 2 speakers. All right. So yes, we haven't quite heard for all 42 talks yet. There's a few coming in live stream 4. But we're 3/4 of the way through the talks, and I feel like today went well.
Yeah, and we have 25% of the talk still to go, so we can look forward to a great day tomorrow. For me, on one hand, this is a more convenient timestamp. On the other hand, I have to give training, so I have to watch them back. I can only watch the first 2 live.
Very fair. Well, thanks so much for hosting with me this year, Dirk. It was super fun.
Oh, thank you for hosting with me. It was a real pleasure. Well, thank you all. Thank you for watching. Thank you for being around with us, and hope to see you soon again.
Yes, at some Postgres event.